Good morning. Thank you for coming. I know it's a little bit early, but there's never too early in the Filecoin, the whole ecosystem and network. Everyone just, got to stay up all the time. I'm Jennifer, known as Jenny Juju on Filecoin Slack. I know people don't know who Jennifer is. I have to do the disclaimer. I work on the Lotus team. This is our very first Lotus summit, along with data onboarding and a lot of the friends that's in the Filecoin ecosystem. There's going to be a lot of great talk and a lot of deep dive into how Filecoin works, how you can get support as a storage provider, as a client, as a developer. So it's going to be a great day. So first off, we have our Andres lead, Momac Molly, to kick us off on the Filecoin roadmap.
Need to raise the mic, tall human. Awesome. If any of you have been at Phil Singapore or other places, hopefully you've gotten a little bit of a taste of past roadmaps for 2022. This is going to be mostly looking forward to 2023 and some of the big things that are coming in Filecoin land. Yes, I am actually being actively bitten in this picture. We were requested to show all of the Lotus cats. This is my Aussie, which is different than Jennifer's Aussie, and he is a little demon. But we love him anyway. So that's Aussie. He can be cute, but don't worry, he's actually evil, and that's his sister Izzy. She's lovely, but he's a little demon. Cool. Filecoin roadmap in 2022 kind of had three main components. Y'all are probably pretty familiar with these things. First and foremost, there was a big focus on capacity and data onboarding, making sure that useful capacity and useful data storage could land in the Filecoin network. And this could be, groups like Internet Archive or New York Public Data or Harvard or other groups could bring kind of archival data to the Filecoin network, and that we could improve the software and tooling such that this was able to grow. And so for context, a year ago, we had something like 20 to 30 petabytes of data stored in Filecoin. Now we have 280 going on 290. I can't actually keep up with how quickly we're onboarding new interesting data. And so that's been a big focus, and we've seen a lot of improvement there. The next focus that started probably in the beginning of Q2 phase and kind of ramped up and is still, a big focus is data retrievability. This is also core to making sure that data stored in Filecoin is useful and accessible to people. So there's been a lot of work happening towards retrieval markets, but even before that, making sure that data stored in things like Boost is accessible to people who are fetching that data from IPFS nodes, and that just generally we're testing the bejesus out of all of the retrieval software so that it can work reliably and robustly. And I think the latest number was 70% retrieval success rate using things like auto retrieve. And so that's way better than we were a year ago for sure. We still have room to go, but there's been a lot of focus there. Last but not least, there was a kind of new early focus in the beginning of last year around programmability and computation. So for context, I think there were two and a half people working on FVM this time last year, and there were absolutely 0 people working on or even really thinking about, hey, how do we do compute over data in IPFS and Filecoin? That team didn't get actually staffed until February of this year. And so this has been a new and exciting area, a lot of research work, but also kind of incremental milestones towards bringing these capabilities into the Filecoin network over 2022. So this is our roadmap that we kind of put together in June and have been working towards kind of since then. Green check marks against some recent accomplishments since the last time I presented this roadmap. So we now have a live FVM testnet up called Wallaby, which has had over 100. Because I'm going to tell you that in later slides, but it's had over 100 smart contracts deployed, which is pretty cool. I believe Bacalhau, which is one of the early compute over data solutions, is literally launching their beta today. So that's exciting. If you go next door, adjacent, way next door, in the timeout market, they are actively announcing that right now. Saturn L1 launched publicly on Thursday, so that's 5 days ago, which is also super exciting. So now I think they went from 50 to 100 L1 Saturn nodes within 3 days. So that's pretty cool. I'm actually running Station, which is a little desktop worker node where you can run your own little Saturn L2 that is supporting the Saturn network for free. There isn't actually, they don't pay me yet to my little Filecoin wallet in there, but I've already done 150,000 retrieval deals, which is kind of cool. And then finally, Project Singularity, I believe did a public announcement yesterday or the day before at Phil Lisbon. And so we're making a lot of progress across all of these different tracks, programmability, data retrievability, and capacity and data onboarding. But y'all are here because you're excited about what's coming next and what the kind of main focus is for next year. So this is our focus. We're kind of laser focused in on the Filecoin master plan, especially the second 2 stages. A lot of focus on data, both onboarding data and making it useful, making there be a flywheel of data coming into the Filecoin network that then powers awesome applications and ways that people want to interface and interact with that data. And so if you stick data somewhere and then never get it out either as an institution or publicly for the world, it's not that useful. So that's a core focus for us, is making sure that all of our tooling makes that really, really easy for people who are clients of the Filecoin network to use it all the ways that they would use, the suite of AWS tools that allow data storage. And then big focus for next year as well is compute, bringing computation, smart contracts. This is the launch of FVM on mainnet. This is all of the exciting compute over data stuff, actually connecting in with IPFS and Filecoin, and scaling so that we can run internet scale applications over the data stored in Filecoin. 280 going on 90 petabytes. We're starting to get towards significant amounts of data to run things like machine learning algorithms over, and definitely want to make that as accessible and meet demand for this really, really growing industry. So this is taking a quick look forward into 2023, breaking up these kind of 2 areas into our data group, which is a lot of continued work on capacity and data onboarding and on data retrievability. So that's our data focus. A lot of this is figuring out ways that we can scale these pipelines, making sure that we scale the CDN side, the retrieval market side of Filecoin, and bring that from early alpha to production ready, acting over all of the data in Filecoin, and also starting to push into things like data access controls. And then after that is our compute thread, again, starting first with things like FVM, but then also going into chain scalability so that we have the chain space in Filecoin to support a bajillion smart contracts that are acting over state and scaling that way. And so those are kind of our 2 threads there: programmability, computation, and scalability. So here's a slightly easier view of that that's maybe a little bit more beautiful. And this is what I'm going to use to walk through a couple of these upgrades if you're not as familiar with them or you just want to know the latest progress. Because we have been here for lab fortnight, lab week, but longer, and have been updating some of our status and timelines of what we're working on. So starting from, I guess that's left to right, your left, with Filecoin Saturn. So Filecoin Saturn is a retrieval market for Filecoin, decentralized CDN, and it has multiple different layers to it that are optimizing for different points of presence and different ways of kind of having really, really fast access to data stored in Filecoin. Saturn just launched their public L1, has over 100 nodes and 100 million retrievals per day. They're currently mirroring, I believe, all IPFS gateway traffic to this network so that they are giving it really, really happy demand so that they can demonstrate that they are actually hitting, I think it was 10x better retrieval performance than the IPFS gateway on average. And I think their 95th percentile is also still like at least twice as fast, if not like 5x as fast. So they are doing a good job against the same corpus of data in demonstrating that Saturn can be a viable replacement for how we currently architect our IPFS gateways. And so the plan there is great. They demonstrate that. We do a small scale integration for a slice of IPFS gateway traffic to go to the Saturn retrieval marketplace, and then we can stop running some of our centralized hardware for the IPFS.io gateway and instead just route all of that traffic into Filecoin Saturn. And then similarly for other folks that are running gateways or that want to accelerate a particular corpus of data, they can pay Saturn, and then Saturn pays their retrieval providers across the network. So both L1 nodes, those are your big, beefy, I have at least 100 gigabytes per second bandwidth, and I will serve you data really, really fast, but I have maybe a limited cache size, and those will fail over to L2 nodes, which, well, I guess not this computer. My computer that's up there runs one of those little L2 nodes on my Mac laptop that then does, okay, I have a little space of that cache miss space that I then send to the L1 nodes whenever they, don't have the content they were requested. So L1s are up, L2s coming next. They will be joining testnet soon, and Station actually already. I think I have Station next. Station is actually already supporting anyone to become a Saturn L2 node, just it's not charged yet. So you can start doing this pro bono. I highly recommend it. It's really fun. It's very gratifying to see your counter tick up. But Station is actually really, really exciting because it's not just focused on Saturn. So not only can you run an L2 retrieval node, but this is geared toward being a Filecoin worker for many of the different job types that might exist more widely in the Filecoin ecosystem. And so focused first on Saturn, but also focused on things like compute over data, where you as a node might want to offer your compute resources into the wider network, or running things like distributed testing. And so this desktop node really helps any node participate in the wider Filecoin ecosystem. It is up. It's already beautiful. If you go to philstation.app, I think that's right, if I remember correctly. Otherwise, check the Slack channel, and you can go and ask there. But they've shipped their website and their first release, and you can go and start running it today. I really recommend it. You do have to put in your little Filecoin address because they are planning to push payments through the FileStation platform in the future. They do not yet today. But I'm super excited for this. I think they're kind of like first, as soon as the Saturn L2 testnet comes online, that'll start shipping payments, which will be cool. Next, sealing as a service. I bet you will hear more about this later today from people who know more about the current status than I do. But this is super exciting. This helps decouple the various different roles that you can play within the Filecoin network. And so previously, it's been pretty challenging, as many people in this room can attest, to come online as a Filecoin storage provider. It involves amassing a large amount of hardware, large amount of collateral, and committing to a long-term participation in the Filecoin economy as you seal a deal and then commit to it over time and demonstrate proofs that you're continuing to store it. And what sealing as a service allows is a bit of decoupling. So say you are someone who's been participating in the Ethereum proof of work ecosystem for the past however many years. You have all these GPUs. You'd love to figure out something useful to do with them now that Ethereum is proof of stake. And vice versa, you have someone in the Filecoin ecosystem who is doing an amazing job of storing lots of useful data for the network and actually has more storage capacity, but is limited on their GPU capacity when it comes to sealing new capacity or new sectors into the Filecoin network. And this enables a bit of a decoupling between those two different roles so that you can have participants that optimize for different parts of the Filecoin storage providing service. Your ex-Ethereum miner can become a sealing service that seals sectors on behalf of other nodes in the network, and then your storage providers can really optimize for, hey, I just want to maintain storage really, really well instead of running GPU farms that give me the really beefy sealing pipeline. And so that's the vision. That's what's happening here. I believe there's already a version of this that is live in Lotus, and a whole chunk of humans who are working on building the sealing software to integrate with that, gearing up for a pilot. I think this is actually maybe a little bit more in the future, but you can sign up to be a storage provider in this sealing as a service kind kind of like early pilot later this quarter, and there's a QR code if you want to join the waitlist. And this, we need people on both sides, both who have kind of like more ceiling capacity and more ceiling demand, so that we can match these groups up and demonstrate that this has helps many more groups optimize their performance in the network. If you care about this, talk to Magic, talk to Daniel Leon, and they can tell you more about how it's proceeding. This is not last, but very excitingly, Filecoin Virtual Machine, y'all have probably heard about this, but this is what allows us to deliver on-chain programmability into the Filecoin network. Super exciting, because really what it's doing is kind of upgrading all of the capabilities of Filecoin with the ability for anyone to upgrade them. And that's allows us to do all sorts of crazy things, a whole multiverse of Filecoin capabilities, but 3 in particular that I love. You can start doing things like perpetual storage deals that kind of auto-renew or auto-repair themselves over time. And if you commit them with even a collective wallet of resources or endowment for that storage, that can persist long into the future without the initial individual who made the deal having to worry about renewals. There's work around data DAOs, where you can have a group collectively curating, governing, maybe selling access to, and benefiting from data stored in Filecoin. So I think that's going to be really exciting, maybe first for things like governing a collection of all NFTs that have ever been created, but expanding from there, maybe you have machine learning data sets that are being created and curated by kind of like larger collections of people, and then using some of the things that are coming around Medusa or other networks, using those as actual revenue generating systems. So I think that's really exciting. And last but not least, there's also a lot of tooling that can be built on top of FVM that just helps the economy transact faster. And so things like helping storage providers grow more smoothly, harnessing Filecoin token holders, and similarly giving Filecoin token holders useful things that they can do with their Filecoin collateral by actually putting it to work with storage providers. And the really cool thing versus maybe DeFi lending in other ecosystems is that these can actually be under collateralized loans based on storage provider history and performance. And so you can look at storage providers that are doing a really, really good job in the network and lower down their collateral requirements, and vice versa. If you don't have much history in the Filecoin ecosystem, maybe your kind of like interest rates will be higher. And so that's a really exciting new thing that we can see many people start to explore with. Our roadmap for FVM is going really well. We've already shipped milestone 0, 0.5, and milestone 1, which actually inserted FVM into mainnet. So if you are doing anything with Filecoin mainnet today, you are actually running on FVM. It's just not programmable yet, because that's the next piece that everyone's working on. And there's kind of 2 main components of this that are headed towards that kind of like ultimate FVM milestone of making all of our smart contracts programmable and deployable there. 1, we're making some changes to the actors within Filecoin so that they have a better interface, a better API for being programmable, and 2, actually deploying our very first foreign runtime, which is the EVM runtime, into FVM, so that you can see kind of our architecture diagram here, where FVM is this hypervisor layer, and you plug in additional runtimes on top. We already have the built-in actors, but our next one after that is EVM, and that is what Wallaby, I guess, there you go. That's what Wallaby is running right now, our FEVM testnet. And so this is already allows MetaMask deployment, hard hat. You can use all of your favorite Solidity tools. You can take an Ethereum contract with 0 changes and deploy it on Wallaby testnet. But the more exciting part for us is that you can also maybe start from that sort of beginning, but then augment it with direct calls into Filecoin native actors. And that's what we're focused on unlocking now ahead of mainnet launch. And there's a ton of tools. If you are excited about playing around with this, highly recommend watching some of these videos from the FVM Foundry. I mentioned that we are working on upgrading some of the core pieces of the Filecoin built-in actors ahead of this. So there's a whole suite of FIPS that are launching in our next Filecoin network upgrade, which is targeted for late November, that are allowing better ways of programming, like into the Filecoin actors from smart contracts. And so there's a number of refactors that we wanted to do ahead of FVM that then creates a better programming interface. And finally, FVM, the Wallaby testnet will be going from a constantly evolving and upgrading testnet, which is pretty much getting reset once, sometimes even twice a week as new capabilities like MetaMask support get launched. This will be upgrading into BuilderNet at the end of November, so it'll become a long-running testnet as we go into Filecoin mainnet launch, and people can then deploy and grow their smart contracts there so that they are ready to go on day one as we actually ship FVM, which I believe is targeted for the 8th of February is the currently scoped timeline, so going well. But in the meantime, I really, really recommend joining the Foundry. This now has, this number is actually out of date because there was a hackathon over the weekend, and I think we had like another 10 teams join the Foundry just during that period of time. But this is our early builders program. It does already have over 100 teams that are deploying smart contracts onto FVM, and it's a great community. There's lots of resources and time with the dev team, and access to things like hackathons and grants. So I highly recommend getting involved if you're building anything on FVM. I probably need to speed up because I think I'm over time, but there's a lot of really cool things that can be built on top of FVM, things like Medusa, Retrieve.org, Web3 Storage Bounty, and much more. These are kind of like new L2 capabilities or L2 networks that can be launched on top of FVM, which bring new exciting things. Medusa, for example, is a scalable threshold encryption network, which can be used to have encrypted data be unlocked for a given user as long as they've met a certain criteria without the set of notaries that are governing that network ever being able to see the data itself. And so those are the sorts of really exciting new things that anyone can launch on top of FVM very, very soon. You also have things like Retrieve.org, which I believe is already deployed on Ethereum testnet, which allows you to do like bounty or you have storage providers stake some collateral, and then you can demonstrate over time that retrievals are actually being served correctly. Last, but not actually last. Second to last, but definitely not least, is Bacalhau and all of the compute over data work. We definitely want people to be able to store data in Filecoin, but even more exciting, compute and interact over that data in highly flexible ways. There are hundreds of data sets, folding at home, Flickr Commons, all sorts of interesting data being stored in Filecoin already, and we expect that to increase significantly into the future. Like, at this point, onboarding like 3.5 petabytes of data into Filecoin per day, and a lot of that is open access data. Really excited to bring things like, compute, AWS Lambda, those sorts of interfaces onto that data as well. And really, we think that there's going to be many computation networks that launch on top of Filecoin as kind of layer 2s that then optimize for different points in Juan's triangle, where maybe you're optimizing for privacy of data with something like fully homomorphic encryption, or verifiability, where you're focused on like ZK proofs, or maybe you're optimizing for a very specific use case, that you're focused on machine learning algorithms, or you're focused on kind of like more ETL data processing, and we think this is going to lead to many groups creating independent L1s that L2s that share some baseline components. And that's one of the things that Bacalhau has been working on, is many of those building blocks that can then power additional computing networks. And the whole kind of compute over data working group has come together to be sharing a lot of best practices, standardizing what makes sense to standardize, but also allowing these different groups to all innovate together in this space, because we think that many, many solutions here are going to proliferate. Cool. There we go. I knew I missed something. There we go. This is last but not least is interplanetary consensus. So we mentioned there's going to be a whole ton of new chain state coming from all of the improvements around FVM and all of the layer 2s built on top. And we're going to need to support that in Filecoin by increasing our chain chain capacity. And this is where what we have been calling hierarchical consensus, but that's hard to say, so we're now calling interplanetary consensus, which is much nicer, which is allowing us to shard the Filecoin chain into multiple child chains so that we can actually support internet scale applications. Child chains do not have to have the same security guarantees, the same block time, even the same token or the same consensus algorithm as their parents. However, you can still transfer state smoothly between these different shards. And so that's the really, really exciting vision that the Consensus Lab team has been working towards for the last year. And they are actually approaching testnet, I believe, end of this quarter. So very, very exciting days in interplanetary consensus land. And so they are aiming to launch their SpaceNet, which sounds the best name for a testnet ever, in my opinion. With their Mir consensus framework this quarter, they will have interplanetary consensus fully integrated into SpaceNet in early Q1, and then aiming to actually integrate fully into Filecoin mainnet and be able to have anyone launch Mir-based proof of stake subnets in kind of like early Q3 of next year. And so that's super, super exciting. And hopefully we don't end up with too much congestion in the Filecoin network before we bring this exciting new capability to everyone. But we think this is going to be a pretty big deal. And we're hopeful that it's not just a big deal for Filecoin, but that we can also share some of this research and knowledge with other networks as well, so that the whole Web3 space can kind of upgrade our capacity and bring all of Web2 into our fold. So fingers crossed. So yeah, that's our quick tour through some of the many things happening in Filecoin in 2023. Warning, we will add more because that's just how we work. So I will be continuing to update this, but the goal is that this, in the future, hopefully this is my last presentation where I do all of this futzing around in Google Slides. And going forward, we have a handy dandy little tool that I can enable all of you to update your timelines for milestones, and they can just automatically populate into my handy dandy little diagram, and then I can take a screenshot of it whenever I'm gonna go present about it. So I'm very excited for that, and I request, keep an eye out, I think in the next couple of weeks, for a request from me to support me with being able to share the good word about all of the amazing work y'all are doing to make Filecoin better and more powerful. And just really, here's to an amazing 2023. It's gonna be a fantastic year. That's it for me. Do I do any questions or otherwise? I've got time for questions. Wow. Anyone have questions? There's a microphone. No? Cool.
Yeah, very good. You didn't see anything. No. You have a title card. That's it.
No, but you put. Oh, okay, cool. Okay,
Sorry.
cool.
Jennifer.
What is Juju doing? You're gonna introduce me. Okay.
People still know you, but for people
This is
that's
Jennifer.
he's introducing me. When people are like standing in the back, there are still like seats in the front, so like come over and grab a seat. So how many of you guys are here before Space Race? How many do you like know Space Race? Yes. Okay. So all those amazing things that's happening in Filecoin network today and all the amazing future that's presented by Molly just now will not exist without this legend. Known as why are you sleeping? Who created Lotus? So tell us how you did the whole thing.
Okay. Yeah. Great. Lotus and stuff, I guess. So I think I was told to show pictures of cats for 20 minutes. I really don't know what she was talking about, like telling you about a flower or something. Like cats are really, these are my cats. That one's Chick Chack and that one's Shadrach. The one on the right, you'll recognize from my GitHub profile picture. The one on the left is even more fluffier. These are my cats. So yeah, I guess there is a talk. In the beginning, we had a problem. We were building Filecoin, And we were in a weird spot where it was 2+ years in. We were at the point where we had a spec that was probably close, and the existing implementations weren't developing on the spec fast enough, so they weren't getting us the feedback we needed. And there was also ridiculous amounts of time pressure. We were 2 years into, building this network. We had raised a ton of money 2 years ago, and everybody was like, "Where's the network? Launch the thing! Oh my God, make the thing! Ah!" And not just people in the community, but everybody across the spectrum, from people in the company, people out of the company, investors, miners, what have you. People really wanted it to exist, so we needed to build Filecoin. And kind of a hard thing to do. So you don't just make it go faster. You can't just say, all right, we're going to throw more people at the project and it's going to just go faster. You can't just tell people to hurry up or work more hours. That doesn't work. Those are ineffective ways of getting to your goals faster. So there are ways of getting things done more effectively. And they're kind of ambiguous, floaty things. You need to have really high context. You need to have high trust. You need to have high freedom, and you need to have very clear goals. I'm going to quickly go over each of these. High context is very important because for the problem you're trying to solve, the people working on it, in order to be as effective as possible, need to understand the scope of the problem. They need to know what they're doing, why they're doing it, how they're going to do it, and they need to be familiar with everything that came before. And you can get work done without this, but if you want to get work done fast, this is a bottom line requirement. The next bit is high trust. You're working on a team, presumably. If you're working by yourself, who cares about trust? If you're working on a team, which is generally how you do more things, you need to be able to trust as much as possible the people you're working with. And this is not easy to do, especially if you're working remotely, especially if you have a bunch of random people on your team, you've hired recently, you've got new stuff going on. Trust is very, very hard to come by, and it's kind of a rare asset that a lot of people don't think about when building a development team. Secondarily to trust, familiarity and knowing how people are going to react under different situations and circumstances is also extremely valuable to building a team environment that allows you to go very fast. Cats are the next thing that you need. You need a way to de-stress from your busy day, so you need cats that might not claw you. The next one is high freedom. Now, this one's really interesting. As you are moving fast, you're building things at a rapid pace, you run into things that don't make sense. Now, if you aren't in charge of the project, you won't be able to make the judgment calls you need to make in order to unblock yourself in the moment and keep moving. If you don't have high freedom, you will have to wait for, you have to write up a doc about the problem and get it discussed by other people and yada, 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 which in some circumstances is the absolute right thing to do. But it is not fast, right? If you want things to go fast, you need to have the freedom to make the calls that you need to make at the time you need to make them. And finally, clear goals. There's obviously other things. This is just the last one I'm going to talk about because I made my slides this morning. Clear goals. You need to know what exactly you're doing. What are the acceptance criteria? What is okay? If I ship a particular thing, which of these things are people going to be happy with? And this is honestly the hardest of the four here, is to have clear goals. You can think you know what you're building. We're building Filecoin. Okay, what the fuck is Filecoin? Really though, what is Filecoin? Every document you read about what Filecoin is will disagree. From the white paper all the way to the spec to our documents about the future, they're all different things. So having a clear goal about what you're shipping is critical and impossible. So how did we start? I was working on the spec at the time, and over the course of working on the spec, I had sketched several prototypes. I had my own little toy like F2 implementation that like did Filecoin things. And then I also hired somebody to work with me on a Lua implementation of Filecoin, not as a serious project, but as a way to tease out issues in the spec. But as we were doing this, we kind of like figured, okay, it's actually pretty reasonable to get to the point of this is a thing that does Filecoin-ish things. It's like from 0 to a Filecoin is not actually all that hard if you have the context of knowing like this is what we're building. So we kind of got it in our minds that like we can just do this from scratch and just start over. But you're not starting over, you have the spec. You're really just like translating the language of a thing, right? So next up is you acquire a team. You have to assemble a group of people, and you have to also take in mind those 4 things from earlier. You need high trust, and high context. And I was thinking through, okay, well, who do I get to come and do this that I trust and who also knows what we're building? And Kuba and Magic came to mind as people who I'd worked with very closely on the IPFS project before Filecoin. And they're also brilliant. You all should know Kuba and Magic. They're like genius. They're wonderful.
And you can get to know them today.
Yeah. So we co-opted them. We made a bunch of people very upset by taking them from the things they were supposed to be doing and putting them on other things. But we acquired the team. And then we formed a plan of attack. We figured out exactly what we were going to do, how we were going to do it, and we split up work. We decided on how much we were going to meet in person versus not. And we were trying to be very clear about what we were going to get done each week. And we had a lot of communication back and forth. I think the amount of Slack messages we would send was just obscene. We also worked quite a bit. The development philosophy that we kind of iterated on but mostly agreed on is you do the simplest possible thing to get the job done. You have a thing that needs to be done, don't make it complicated. Try to write the littlest code, the simplest code, the most maintainable code, the most debuggable code. Fuck it, ship it, test, and prod. Now this is a controversial one, but the key here is as you think about like, oh no, what if this, what if this, what if that, throw it out there and see what happens. The system should be able to handle things breaking. So in the testnet scenario, you should be able to build your code such that if you try a new piece, obviously you're not deploying it to everybody, but if you try a new thing, you deploy it to the testnet on your node and it breaks, great, cool, that's prod, you just broke it, you learned something, move faster. If you try to catch every possible little thing before like getting out there, getting up on stage, you're wasting time. Like, there's a real world out there that can break your shit faster than you will. So let it. Next thing is unit tests are for preventing changes. This is both a pro and a con. If you write unit tests on things that will need to change, you're going to waste time changing them, or you're going to delete those unit tests, which is you wasted time writing them. So be careful of what you throw unit tests on. However, integration tests are completely different. Integration tests, you know what the top-level behavior is going to be, so write a test that runs that, and whatever changes inside, who cares? You're just testing that, Lotus runs and makes a blockchain. That's a great test that you should write tons of. Next up, debuggability. Like, make things that are easy when they break for you to figure out, why they broke. Developer tooling is also extremely important. This is one of the key things you'll notice about Lotus if you dive into the code base. There are little tools everywhere for everything. And those aren't necessarily for, users as much as they are for us to make the network work and run really well. And that saves so much time. I can't tell you how much time we have, put down just because, oh look, Lotus Shed has this tool for us to fix stuff and it just works. And there's all sorts of other stuff, but that's kind of the high level. And then the secret sauce is that I was in America, those two were in Poland. We worked overlapping each other on both ends of the day. We never stopped writing code. So I would wake up, we'd have a few hours of overlap. Whatever one of them was working on that needed to keep going, I would take on during my day. When I went to sleep, they would wake up, we'd hand off the same way, and things just kept rolling. It's a lot of work. It's a hard way of doing things, but we were under the gun. And then meeting up in person is extremely important. Like, all this remote work stuff is great, but like if you don't see your like people you work closely with like every other month, honestly, like you're gonna have a breakdown in trust and things aren't gonna be as nice as they should be. So on that note, Osaka's really beautiful. We met up in Osaka for DevCon. I think this was the first time we met up as the Lotus team. And it was wonderful. We shipped the initial testnet, or like we launched Lotus. It was more of a DevNet than the testnet, because that has all sorts of connotations you don't want to deal with. Okay, so the code works. Now you just take 6 months without making any changes, paid on technical debt, stress tests, unit tests, integration tests, out of the code, clean the code, make the refactors you want to make, get comfortable with the code, and all these other things. Look at all, wouldn't it be great just to do all the good things, right? Everything else that comes after launch is going to suck, right? So you should take the time to get it right. No, that's not going to happen. You'll never get that. Don't count on it. Whatever you don't do now won't happen. So, pet a cat. Google also says this is a cat. I searched Google Photos for cats to get pictures of my cats, and that's a cat. So yeah, in the real world, requirements are changing rapidly. Like, we have a research team that's actively figuring out new things. They're pushing new requirements down on us. We have learnings from the community. We have different things. All sorts of stuff is changing. And there's this testnet thing that just keeps breaking for, I don't know why, we'll figure that out. And also the world might just decide to end. There's some pandemic thing that might happen, and then everything just goes to shit real quick, and that also sucks. So everything's gonna get in the way of you doing the thing you want to do. Your plan is worthless. So dealing with changes is really the key at this point. It's make sure that everybody understands if you really, really, really want this change, it's gonna cost this much. And avoid making changes if you can. And if you have to make changes, make sure that the people are aware, what that's going to do to the timeline. And I realize that point 1 and point 3 are basically the same thing, but it's really important to communicate to people what the change they're asking for will cost, and making sure that that is clear, and not just saying, oh yeah, we'll do that. Because you could just say, oh yeah, we'll do that, but then that's not honest. So yeah, testnets. This is one of the most painful things, but also the most important thing. The testnet will go down. It is extremely stressful. I don't know if anybody here has launched a blockchain of their own. That is a special hell. I have several other friends right now who are working on new fancy blockchains, and the only advice I have for them is you're gonna need a therapist. It is probably the most stressful software project to launch. There's hundreds of millions of dollars riding on it. There's so many people angry about it. Your code's out in the open, your development's out in the open. Everything is just out in front. Everything you do gets criticized, whether it's good or bad, and it's extremely mentally taxing. So buckle up. But keeping the testnet online is super important. Without a reliable testnet, you don't get testing, right? If testnet's not on, it's not being tested. And furthermore, if you let the testnet go offline frequently, you're going to get less engagement from the community, and you're going to get overall less good testing. You really want the testnet to be as active and lively as possible in order to maximize the amount of test hours you get on the code. And the debuggability tooling you made before is going to make your life easier. And yeah, pretend it's mainnet, because mainnet will go down, and you will have to respond to that. It's horrendous. So how to get things over the finish line. Hire Ayush. Thank you for coming to my TED Talk. Oh, wait, yeah. So decide what's good enough to ship. you really need, there's an infinite number of things you can keep doing. One more thing, one more thing, one more thing, one more thing. Where do you draw the line? Where do you actually say, all right, we're going. This is go time. This is the set of features we're finally going to do. Because all those changes I talked about before are going to keep coming. Up until the day of launch, people are going to want to make changes, and you really need to stop those at some point. Ideally, like over a month before you actually launch the thing would be nice. No comment. Yeah, and have a clear criteria for each component to like what is good enough, what interfaces work. And yeah, see that earlier slide with all my hopes and dreams on it. Maybe try to do some of those. But other important thing is support the people around you. If you're in a really stressful work environment, which this was, you got to support your coworkers. You have to like keep people's spirits up. You have to like keep everybody moving in the same direction, and morale. Like the actual like day-to-day of the code is actually less important than how motivated people are to get the thing done. So in retrospect, make your slides earlier than the last day of the talk. That's all I had. But if anybody has any questions, we can do, I don't know, a little Q&A or what. But yeah, thank you.
So any project with projects like this that are pure software, but they're delivering a tangible product at the end of it.
Yeah.
The hardest part for any team that I've been a part of or led is coming up with a definition of done. And you hit on a point there that the unit tests are there to prevent changes or detect changes and whatnot.
Yeah.
So in this context, you were lucky that you were part of a four-person elite squad on a mission. But in a broader context, how would you define done with so many moving targets? His follow-up question is, how did you manage change? Because I'm sure you didn't know what you didn't know starting it, and revelations hit you probably on a daily basis.
Yeah, so for the like final several months of the project, my only job was change management. I wasn't writing much code anymore. I wasn't doing anything but basically trying to say no to as many people as possible. And yeah, I would wake up, say no to a bunch of people, hopefully, and then go to sleep. And that was it. The yeses were the hard part. And if there were, basically every time there was something that came close to being a yes, that was like a long conversation. We had to figure out exactly, like, is this actually critical? And like, literally my entire job was figuring out what's in and what's out. And then if something was in, I had to work very closely with the development team to understand the changes, update everything, and like get that integrated without breaking things, which is hopeful speaking. But yeah, like really change management at that stage of the game is more than a full-time job. I don't know if I have any other like heuristics than that.
I was just curious to hear your response.
What was the hardest no? What was the thing that came like the hardest no you had to make? Like the thing that was most important, very excited to get in there, but you were like, we just can't do this, even though it's a great idea.
Oh man, what?
What I was going to say is we actually launched the network without actor upgradability.
Oh yeah.
Yeah, FYI. And that came as an upgrade after the fact, or launch the network with a different Filecoin minting strategy.
Oh yeah. There's a lot of really hard no's. I think the harder ones honestly came earlier on. Like there were things that I was really personally excited about, like repair of mining, where you could actually make a deal that would be replicated on chain instead of just doing a one-off thing with a miner. The complexities of that were enough that I was finally convinced that we couldn't do that in time. But like that was one of the big ones that I still wish we had today. Like you have to rely on external services to manage the replication, and that's a hard one. I think the other harder no's, I don't know. Honestly, a lot of this time period was a blur. So I don't know, Ayush Magic, do you remember any hard ones?
You were doing it all.
Which bug is
Yeah.
you need to fix before or after?
Oh yeah, there's the number of potential, like, you have to fix this. I'm like, we're not gonna hit that problem for another 6 months. Let's go. 6 months later, we hit the problems. Who'd have thought? Yeah. Good question.
Yeah,
Wait, more?
yeah. I just wanted to ask. You mentioned developing context and that being really important for working well with the team. Do you have any advice on how to build context specifically on Lotus itself?
Specifically building more context for people working on Lotus.
Exactly. Yeah. Or
Yeah,
anyone in the community, who's just engaged
Yeah.
in using Lotus.
I mean, a lot of it is like diving into the code base and related code bases. So like in our case, a lot of the people, so like Magic and Kuba had the benefit of working deeply on IPFS and libp2p and all the related projects beforehand. So they just had that context. In Ayush's case, we brought him on, and his first job was actually to be the support technician. So people would ask questions in Slack, and his job was to go find the answers. And that's actually a really good job to build context, because every time somebody asked a question, he would just have to go dive into the code base, read code, and figure out the answer to that question, which led to him rapidly building context and eventually, like, I think within a couple weeks, just start writing code and like contributing to the project. So quickest way to build context is just to dive in wholeheartedly and like just try to understand as much as possible, because it is possible to just understand a code base, but you have to really immerse yourself in it. Ayush?
So you run Lotus Notes to this day. What is your biggest regret from that story? So you run Lotus Notes to this day. What is your biggest regret from that story you were telling, kind of pre-mainnet launch, that causes you pain today and that you would like to fix?
We don't have good light client support. I think one of the biggest things right now that I wish we had better is like either running a full node was cheaper. Like I don't necessarily run a full node all the time right now, because if I don't pay attention to it and the network upgrade happens, it goes out of sync and I can't get it back into sync. So I mostly just run light clients, and the light client support is okay, but I wish we'd done it better. And like it's just a matter of time. Like light clients got cut from the scope for launch, so we didn't get it done. And since then, we've been running a mainnet cryptocurrency, which is a lot of work, and there's not a lot of extra time to go back and do that thing you wanted to do. So.
In case people don't know, like my first day working on Filecoin was the first day when Space Race, like the testnet, was like launched. Like my dear team just decided to throw me out the community. I was like, if you have any question, like go ask Jennifer. And I'm like, I don't know shit. I don't know how Filecoin works. But yeah, definitely like the best way to learn is like get there and like dig into the code and try to understand things. So thank you, Y, for giving us all the context as why, moving forward to contribute to Filecoin ecosystem, like making Filecoin more useful by building S3. If you haven't checked out S3, you should, S3.tech, which is like onboarding a lot of data to the Filecoin today. If you are SP, you should be, providing storage on S3 platform. Some people with more cats are taking over maintaining Lotus and try to not kill the network. Let's welcome Ayush to talk about the current state of art of Lotus and the Lotus team.
Alrighty. Thanks, Jennifer, for the introduction. And thank you, everyone, for being here today. This is the first time the Lotus team has undertaken an endeavor like this. So very excited about the support, and even more excited to talk about the stuff we're building, the stuff we're working on, and the various other teams building on around Lotus, onboarding data onto Filecoin, and so on. I'm very excited to be here, and I hope you are too. So we creatively, I was supposed to give this talk with Jennifer, but it turns out after almost lab fortnight, her voice is a rare resource by this point, so we're trying to conserve that. So I'll be doing this solo. So we titled this talk Lotus Daemon Start, because we're clever engineers. Our goal, honestly, and one of the biggest goals of this summit today, is to get people a little bit more familiar with Lotus writ large. So that's Lotus the software, Lotus the team, the various dependencies that maybe folks consume through Lotus but are built by completely independently by different teams and so on. So that was the goal, to have a kind of Molly telling us where Filecoin is going, because obviously that's where Lotus will be going over the next year. And also the goal of having Y set the stage for how Lotus came about, so that if you do interact with Lotus, you kind of know the almost cultural context of how it happened, and if you find that it has certain quirks, that maybe you can trace it back to the content that Y just shared. In this talk, I mostly just want to talk about what Lotus does and what the Lotus team does, which many of you may already be familiar with, perhaps some portions of it. I'll try to go relatively quickly, but my goal is to describe what the Lotus node and the Lotus team does and what makes it difficult. And maybe that makes you excited and makes you want to be a part of this grand endeavor. Cool. That is a very attractive picture of Ozzy, whom you've been seeing today. My cat is Nina. You may recognize her from my GitHub or Slack or other places. She's got all the colors. Cool. So obviously, to talk about Lotus, we start by talking about Filecoin. I think most folks are familiar today. Most folks who are here are familiar, but Filecoin is a crypto-powered storage network with a mission to create a decentralized, efficient, and robust foundation for humanity's information. And so in many ways, Lotus's mission becomes to help with that mission of Filecoin, to solve some small part of that puzzle. Filecoin is big. We have 16.28 ebibytes of storage. You've probably seen these numbers before. And the Filecoin ecosystem is big as well. What it means to be a part of Filecoin maybe involves, the protocol and the network, but also things like the decentralized economy, these open services, and so on. And Lotus kind of gets involved with small little pieces of almost all of these bubbles, but in particular focuses on the blockchain and protocol and network bubbles over on the left-hand side of the corner there. So usually if someone asks me what is Lotus, I usually answer the question with Lotus is the reference implementation of Filecoin, and then ask them, do you know what Filecoin is? So if we try to unpack, what Lotus does, this is a somewhat useful place to start, but that doesn't really tell you all that much. So mostly what I want to do in this talk is kind of like pull some threads at what I mean when I say that Lotus is a reference implementation of Filecoin, and in doing so, get to what I and my team spend my time building. So to start, I think a good place to start isn't what does Filecoin need, but really what does any implementation of a blockchain need? Because that is fundamentally and at its core what Lotus is. So what does a client implementation of a blockchain do? There's kind of like what you would expect. The most important, perhaps, is you have to correctly implement the protocol. Whatever the rules of whatever blockchain protocol you have to implement that correctly. This could be very simple if your protocol is check if a certain hash solves some puzzle, and could be very difficult if your protocol is, and I'll use Filecoin as a more difficult protocol, if your protocol involves things like storage being provably replicated and then being verified every 24 hours, and you have tip sets instead of blocks in your blockchain, and so on. In addition to that, so if you correctly implement the protocol, cool, you can validate the Filecoin blockchain, but you probably want to do more. In particular, you want to have a peer-to-peer component. You want to identify the other participants in the Filecoin network. You have to be able to connect to them and decide who's a good peer, who's a bad peer. You probably want your users to be able to actually understand what your blockchain state is, instead of just having that information and pretending like that's inherently useful. So some interfaces to query chain state are needed. And you probably want to interact with the Filecoin blockchain itself by sending transactions. We call them messages in Filecoin. And these transactions could be simple balance transfers. Here, have to Filecoin, happy birthday. Or it could be more complicated things like, I wish to contract a storage deal to store this important piece of data, and here are the terms of the deal, and so on. You probably want to support the production of blocks. This isn't core to an implementation, but if you don't have any software that's producing blocks, then you don't have a blockchain. So someone needs to be doing this. And as any developer of a piece of software needs to, you need to support your users. And in the blockchain space, I find that if you're building an implementation, you kind of wind up almost being a face for the protocol itself, and so you have a slightly broader community to support. So that's what any old implementation of a blockchain needs to do. Filecoin is a little bit more complicated, and so at the very least, you want functionality to commit and prove storage. This is what helps Filecoin deliver on its promise of verifiable storage. So you need some software that can receive data, perform whatever transformations needed, in our case, proofs of replication, and then commit that storage to the network, and in Filecoin's case, again, prove it every 24 hours. You probably want more things, such as the functionality to negotiate storage and retrieval deals, because that is the point of Filecoin, as well as a data transfer component to actually get that data from client to provider. I don't know if it's obvious, but points 2 and 3 are a little grayed out. They are things that are actively supported in Lotus, but we are actively working on moving those tasks to other teams, and you'll be hearing a lot more about that today if you stick around, in particular from Lotus's best friend, Boost. But the functionality to commit and prove storage is still pretty inherent to Lotus. So now we can go back to this definition and say, okay, well, Lotus is a reference implementation of Filecoin. We've kind of agreed what an implementation of a blockchain needs to do. We've kind of agreed what Filecoin needs. So from that, we can try and get at what the Lotus piece of software and the team building the Lotus piece of software needs to be doing. And I've broken it out into this big 5, where there's 5 kind of big pieces that we work on. Piece number 1 is Lotus itself, as you would imagine, but it is not an exaggeration to say that's only about 25% of what the Lotus team and what I think the Lotus project represents, if that makes sense. But obviously, so one piece of software is Lotus itself that needs to sync the Filecoin blockchain and do so correctly and be resilient to attacks. The Lotus team maintains or co-maintains a suite of actors. Actors are basically Filecoin's term for smart contracts, if you're familiar with that term. And they're more like precompiled contracts almost that define the core Filecoin protocol itself. So things like, did this storage provider correctly prove their storage in the past 24-hour period is written in actors code and run on the Filecoin virtual machine. Piece number 3 is the Lotus miner. This is the piece of software that seals data, so performs these proofs of replication, proves that data every 24 hours, accepts deals from storage clients, produces blocks on the blockchain, and so on. We will be going into a much deeper dive of that piece soon. Point number 4 we call drive research to production. This is one that we recently added because we realized we weren't accurately representing a lot of the work we do in our stated goals. It is a little bit of an implicit mission that we have, but basically what this comes down to is being the team building the implementation of a blockchain gives you a really, really useful vantage point in that you know the protocol as it exists today really well. You know what the users experience because they're talking to you every day. And this gives you valuable feedback to provide to research teams that are thinking much higher level and much longer term. So if someone has a brilliant idea tomorrow on how to make Filecoin better, whether that's put a virtual machine on Filecoin or a new consensus mechanism or a new proof system, whatever else, it's great. We're not the ones creating those ideas, but we're often one of the best teams to talk to in order to provide feedback along, will this idea be feasible? Will this idea be secure? Will our users want this idea? Like, will the Filecoin community say, no, absolutely not, I don't care about that, or will they be jumping out of their seats in excitement? And then we wind up doing a lot of the kind of integration, testing, maybe even the implementation work. And point number 5 is the community, as I mentioned. So what I wanted to do was dive deep into each of these 5 points. I covered them at a high level. What I'd like to focus on is what makes them difficult, because I think that's what makes our jobs interesting. That's what, but also if you're a user of Lotus and often annoyed by things that Lotus does, maybe this gives you a sense of why some of these things are challenging. If you're a developer, maybe this gives you interest in trying to solve some of these problems because we need the help and we're hiring. So I'll try to do that at a relatively high level, starting with Lotus itself. So what does the Lotus daemon need to do? If you run Lotus daemon start, it spins up a process. What does that process need to do? It needs to find and communicate with peers, as discussed. You need to execute messages, transactions, to compute chain state and validate these blocks that you're receiving. You need to store the chain state. And I didn't have this point in here initially, and Jennifer, our TPM, pointed out, you really should include that because that is a challenging thing when you're dealing with Filecoin, because our chain state is big, as you probably know. So we need to store the chain state and support querying it for users who want to inquire about the chain state. You want to maintain a message pool of messages that are waiting to be included on chain. So someone somewhere wants to be sending some transaction, they send it to your Lotus node. You want to support having it in your pool, sharing it with your peers, and for folks who are producing blocks, yank messages out of that pool, include them in blocks, and have the logic to support that. And you probably want an internal wallet for easy access to funds as needed. This doesn't have to be the most secure wallet in the world, but it should be easily accessible. Just as an example, if you're running a Lotus miner, you need a wallet to be submitting your proofs every 24 hours. And so we have that built into the Lotus wallet. What makes this difficult? I think the single biggest piece that makes this challenging and that leads to issues is that you are receiving a lot of untrusted input at any given time. This kind of goes to just participating in any decentralized distributed system. So every message that any peer might be sending you, whether it's a block, a transaction, a whatever else, could be designed to attack you. Most of the thorniest bugs that we have, bombs that we have defused in Lotus since mainnet have had to do have been unearthed in audits of the P2P layer, where auditors have said something to the effect of, hey, if I send this bad message, I will crash your Lotus node. And so that is one of the most challenging points. Scalability is a big problem, and continues to be a big problem. And there's things we can do within Lotus to address that, and there's things we can do at the Filecoin protocol level, as Molly alluded to in her talk, to address that. And being correct is not the easiest thing to do, because the Filecoin protocol is dense and complex. This is one of the advantages to having multiple implementations, where it is one of the best ways to realize that you're not implementing the protocol correctly is having someone else that's implemented the protocol correctly, and then you're not in consensus anymore, and you know that one of you has made a mistake somewhere. So that I think those are kind of the key challenges that Lotus faces. Built-in actors, as I mentioned, are the precompiled contracts that kind of run the core code of the core protocol of Filecoin itself. So these include things like the storage miner. Anyone that's running a miner has deployed a miner contract or a miner actor onto the Filecoin blockchain. The storage market currently transacts all deals on the Filecoin blockchain, and so on. The number one thing here is it needs to be very, very carefully tested, because, as I said, this is the kernel of the Filecoin protocol itself. Any mistakes here are going to affect every participant in the Filecoin blockchain, because they're all using this as their source of truth, and also are going to be very, very painful to fix, because in order to fix any issues in actors' code, you essentially need to perform a network upgrade. Other blockchains call this a hard fork, and that is complicated and time-consuming and involves getting the community aligned, but you don't want to reveal issues if they are a big issue, because that leaves the protocol vulnerable. And yeah, it's written in Rust and only co-maintained by the Lotus team, and as of July this year, runs on the Filecoin virtual machine. So biggest challenges here, security and correctness, we kind of talked about already. Determinism is another really big one. And for folks who were around back in December of 2020, the Filecoin mainnet chain halted, the only time we've halted, for about 3 to 4 hours. And that was not a vulnerability issue in any way. It was not, something was not being attacked. We just had a non-determinism in actors' code. And so everyone ran this code. Everyone got technically the same correct result. There was nothing wrong with the result they got, but they weren't agreeing on what that result was. And so everyone the chain fragmented into 20 million little pieces, and the chain halted. So ensuring that your code is deterministic is really important there. And performance is critical, because this is basically the piece that's going to dictate your block validation time, how long your actor's code is taking to run. So any optimizations you can make there are going to speed up block validation, and also lead to greater chain throughput as a result. The Lotus miner, I'm basically going to skip because we're going to have a very deep dive from Magic, who basically wrote all of the code. But yes, the high level is it is responsible for sealing your data, proving your data, accepting data from storage clients, and producing blocks on the network if you choose to participate as a Lotus miner. And Magic, we can go into why that's not an easy thing to do. If anyone here is running a Lotus miner, I'm sure you have thoughts on why running a Lotus miner is hard. Cool. So this was the fourth point that I mentioned around driving research into production, where your job is basically to provide feedback based on your knowledge of the Filecoin protocol, as well as your knowledge of what your users like. And in doing so, can also improve new ideas. So maybe someone has a cool high-level cryptographic idea, but doesn't quite know how to make that useful for Filecoin, by communicating with our users and maybe connecting them to speak directly. We can kind of almost play a facilitator role in making such exciting ideas useful to Filecoin. And honestly, this is a really fun part of the job. I really enjoy working on this aspect of the Lotus team or the Lotus project a lot. A lot of this work is done in partnership with the Filecoin Foundation, and so we get to work closely with them and with the other core developers, the other client implementations of Filecoin. Challenges here mostly revolve around keeping up with everything. Filecoin moves way too fast for anyone's comfort. There's a lot of very, very smart people very invested in this protocol, whether that's at Protocol Labs, Entres, or the Foundation, or the core devs, or just folks who are in the broadest sense of the community who have kind of been like keeping an eye on Filecoin, and one day open a discussion being like, hey, I have this brilliant idea about how you can change things. And so trying to keep track of all of those gets very difficult. The Filecoin Foundation is our major partner in helping facilitate that effort. Another big challenge is identifying unrealized cross-team interactions. I was struggling to figure out how best to phrase this last night. So let me explain what I'm trying to say with those 5 obscure words. Essentially, 3 people might have 3 very good ideas about how you can improve, about how they think they can improve Filecoin. Maybe it's a new proof system. Maybe it's they just want to change some aspect of how we prove storage every day or something. All 3 of those could be independently very, very good ideas. They might be and independently deliver some improvement to Filecoin. It makes things cheaper. It makes things faster. It makes storage more reliable. Unfortunately, they may interact with each other. And because of how open and big our community is, they're not talking to each other because everyone that has an idea about Filecoin can't talk to everyone else that has an idea about Filecoin. Lotus winds up being an interesting choke point for these ideas. And so one aspect of our job that has nothing to do with building Lotus software itself essentially becomes hearing about these ideas and then going, okay, that's good, but this is going to essentially be incompatible with something else that someone is excited about that I heard about yesterday. And obviously, you want to try and nip those things early in the bud if they exist, and ideally try to figure out ways to make them compatible with each other. But the earlier you do this, the better. What we really want to avoid is people coming with fully built ideas, both wanting to get them in the network upgrade in February 2023, and us having to say, ooh, only one of those is going to happen. And this requires a lot of creativity more than anything else, because it requires communicating with people and thinking about how ideas are going to play with each other. And it's an interesting problem that combines kind of the human and technological aspects of our job. And working across various team boundaries, because as I mentioned, we're talking to a lot of different teams, and that can be difficult. Having a good TPM is critical here. Cool. I won't talk with the community too much because I think a lot of you are here today, and I think there's general familiarity with it. But our job here is pretty much to support our users because Lotus is can still be a difficult piece of software to run. New bugs are introduced every day. New issues are discovered every day. So essentially, nip those in the bud. We have a team of talented technical support engineers whom we'll meet shortly, who primarily help with this effort and also identify areas of improvement. Communicate developments happening with Filecoin to our users, because again, we kind of, for a Lotus user, we are the source of information about Filecoin. Run test networks. The calibration test network was reset yesterday. So if you were participating in that, you can start syncing that as of today. And as I mentioned, a lot of this happens in partnership with the foundation. Cool. So yeah, going back to kind of what Filecoin is, you can, so if Filecoin is trying to create a decentralized, efficient, and robust foundation, hopefully it's clear how Lotus's mission tries to tie into that and try to deliver on some of those promises. And that's why I like working on the Lotus team. We can skip that. Cool. So here's the Lotus team really quickly. If you're interested, almost all of us are here today. All of us are here in person today. So we're a team of 5 engineers, 2 PMs, TPMs, and our friendly TSEs. You'll hear from a bunch of these folks later today. Those are our cats, most importantly. Cats, as you can tell, are important to team culture. You can find us at various different places. Our Twitter is Lotus_Web3. If you get the PDFs to this, there's a link to the Lotus Home website. It's basically a Notion page that we try to keep updated with what's going on, what we're excited about. We've got a YouTube channel, and most importantly, perhaps, you can find us in Slack at #PhilLotusDev on the Filecoin Slack. We are hiring, as I've indicated in multiple points. There's a lot more work to be done to make Lotus better, resilient, more performant, and just keep up with the pace of development of Filecoin. In particular, we have a lot of interest in getting more software engineers and more technical support engineers. So if you are part of the community today, think you know Filecoin well, know how to communicate how Filecoin works to and help grow the community as a result of that, we're very interested in growing that TSE team. So please apply. And this was kind of my takeaway slide for why I like working on Lotus, why I'm excited to talk about Lotus, and why I'm excited that we're all here to talk about Lotus. We're a relatively small team building a relatively small piece of software. It may be a little cumbersome, but at the end of the day, it's not some massive code base that'll take you years to dive into. And yet that code base is the foundation of one of the largest storage systems in human history. And I think that's pretty cool. And so that's why I like working here, and that's why I'm grateful to everyone here for being a part of that process. Cool. That is my pitch. Any questions? Sweet. Thanks, folks.
This is going to be the last cat photo you see before we have a break. So here we're going to join by everyone's favorite, Steven, who is now started working on everything PL has ever built, I guess. Like P2P, IPLD, IPFS, then Filecoin, then Actor, then Lotus, and FVM. FVM is the same. If you haven't heard, it's a Filecoin virtual machine, which is bringing programmability to Filecoin. I actually try to make storage useful. So deep dive, please don't spend too much time on your beautiful cat. Focus on FVM, please.
Will do. So yeah, this is a deep dive. It's actually going to be somewhat more of a high level because the deep dive would take an hour or two, and I want to make this pretty quick. But yeah, for people who don't know, the FVM is the Filecoin virtual machine. Internally, it does not actually implement a new virtual machine. It actually uses an existing WASM or WebAssembly VM called WASMtime. But in theory, you could use any WebAssembly VM you want it to, just based on WebAssembly. For some terminology, before we get confused, the FVM, again, is the Filecoin virtual machine. FEVM is the EVM on the FVM. So this is what we call our version of the EVM that we're going to be introducing in February of next year. An Actor is a Filecoin smart contract. It's based on the concept of the Actor model. In Ethereum, you call into the Actor. In Filecoin, you send to another Actor, and then you receive back a response. This right now it's still very much calling based, but in the future we really want to add more asynchronous operations and some parallelism. This is kind of be covered later in the Beyond section. But Actor model also captures the fact that Filecoin actors tend to be a little more complicated than Ethereum contracts. They do a lot. They're basically just real programs. Okay, interplanetary linked data. I don't know how much you guys know about that. Some people know a lot. Some people know very little. IPLD is a very, very important system we build on that allows us to abstract over different types of Merkle-linked data structures. It's one of our secret sauces to building a lot of really cool things. Right now, you can't see too much of this, but for example, we had, what was it called? Optimistic window post. This was made possible by using IPLD. If we had used anything else, it would have been really, really hard. But because we use IPLD into the covers, like we were able to snapshot certain data structures and just like sort of keep them around for a bit, so we could check historical state. Without IPLD, we would have had to like copy data structures very, very carefully, like avoid touching things, and like it would have been really, very painful. But this made it really easy. And finally, WASM WebAssembly. It was an assembly language made for the web, but we were using it because it's designed to run like in a very like sandbox environment with no trust. It's very easy to also like to sort of statically analyze WebAssembly code and to instrument it. So we're doing that. We're using that for gas accounting. It's very, very structured. So most assembly is kind of just like, well, you have some assembly, whatever, you can jump anywhere. WebAssembly is more like an AST. It's actually a Lisp under the covers. Yeah. It's the background. Fundamentals. So as I was saying, the FVM is built on a WebAssembly VM. This gives us near native performance. WebAssembly has very, very good performance, primarily because it actually compiles down to native bytecode, and they play some weird games with addressing and what's it called, and address spaces to make it so they can actually align most of their pointer text. So you can kind of just effectively like compile these untrusted programs into native code and just run them and know that they can't do anything bad. It's also enables us to do like good static analysis. It enables other people to audit code. So one of the cool things here is in the FVM, you have to import your syscalls to declare which ones you import. So if there's some kind of dangerous syscall, you can actually tell if someone's importing or not importing it by just looking at their imports. In the EVM, you kind of scan the bytecode and hope that you find the right bytecode, but you couldn't, but it's hard to be sure about things. Okay. Another part about the FVM is it's designed to be a hypervisor. Basically, what I mean by hypervisor is like it's an underlying machine that runs other machines on top of it. So we are currently running the built-in actors, but right now we're building the EVM, and we really want to make this so people can sort of drop their own system in on top of the FVM, because that enables us to kind of like borrow other ecosystems and really play nicely with everything else. This is just the theme at Portugal Labs you may have seen, where we try to like just sort of integrate with everything. So if you've seen like multi-hash, multi-adder, like libcpu's transport system, IPLD, and all this kind of stuff, like it's all around like creating some abstraction over a bunch of different systems and allowing you to sort of use whatever you want and sort of take, it allows us to like interoperate with things. So we did this by, first of all, like compile the runtimes with WASM. Because it's WASM, it's very fast, so you can actually do this without like having, performance is not amazing if you're trying to run some foreign environment, but it's not like nearly as bad as it would be if you tried to do any other system. We're supporting user-defined addressing, so we can literally take another addressing system, kind of like put that inside a Filecoin address, and then take it back out. So it allows people to take their system as is with like address, basically address generation logic the same way. So like this, a lot of tooling will predict addresses. It'll say, okay, if I deploy this actor from this account with this code, like I will get this address. This allows you to actually like keep whatever guarantees you have in your old system the same when you import your system into Filecoin, if you do that. Finally, we're adding user-defined account types. So this is called account abstraction if you come from Ethereum. This will allow people to like sort of like use MetaMask or whatever they need with the Filecoin network. You can also, again, use other systems. It doesn't have to be Ethereum. You'll just be able to sort of like create your own account type and deploy that on the network, and people will be able to like send messages to the network, transactions to the network, using their favorite native or like their favorite system. Fundamentals, again, it's built on IPLD. This enables like really easy on-chain version snapshots. It supports pass-by-reference between actors. So this is a feature you don't get on, I don't think, any other blockchain really. Basically, in Filecoin, you can actually send an entire substate tree. It's like you send a pointer in a programming language. In most systems, okay, you could reference an entire actor or some other state. So like in Solana, you have like your accounts that have state, but that's like the granularity at which you can reference state. Here, like even within a single sort of atomic object, you can actually reference sub-objects and send them around with basically pass by reference, but copy on write semantics. So like I can pass you reference, you can't really modify it, but you can create a new version of it very cheaply and then send that back. This will be really important later for a lot of parallelism stuff because it allows us to sort of like spawn off a bunch of read-only parallel workers. They can do whatever they need to do, return their state, and then like the sort of the coordinator can then like commit the final results. Which is something that's very hard to do in something like Ethereum, where everyone just kind of has to write into the immutable state. Finally, it allows for user-specified data layouts. This means like basically users get to decide like what data goes next to what other data. So if they have data that's frequently accessed together, they can put that next to each other. Okay, that covers a lot of the details. This is the scary slide. This is how it actually works. You can tune out for this next section. I'll wake you up in a few minutes. But I do want to like give some people here an idea of how this works, so that when they touch the code, they can understand this. Basically, that blue section is the executor. That basically is sort of one. Well, I say block. Actually, that's wrong. Tip set execution. So basically, for a single tip set, you have a single executor that executes all the messages in that tip set. It executes those messages on top of a machine. The machine kind of represents the state of the system and also the externs. This is how we interact with clients. So like the FVM is this Rust program right now, at least. We can have other implementations of other programming languages, but right now we only have one in Rust. But it doesn't implement everything. It doesn't have like a block store. It doesn't have a chain. It doesn't understand any of that kind of stuff. So instead, right now, it shells out to the client, so Lotus or Forest or whatever, to ask if like randomness or chain information or whatever. That's what the externs are. So that's how basically effectively a message, the executor applies messages to the machine. It does this using that sort of block over there, the call manager, the kernel, the invocation container, all that stuff. Basically what happens is message comes in, when you create a new call manager, this manages the single sort of call into the system. It's the call stack really. That then creates an invocation container to run your actor, your WebAssembly program. That then runs inside there. If we have the EVM, then we put the EVM inside the WASM, the little WASM section there. That can then call back out to the system through what we call syscalls. It's like on Linux. They look very similar, actually. You basically just call it these special host calls. The kernel then handles these, and if, for example, you're sort of sending to a new actor, the kernel will then call back into the call manager. The call manager will create a new kernel, which will create a new invocation container, sort of go back and forth and back and forth and back and forth. And that's kind of the life cycle of a message, where you kind of go, you call down, creating a bunch of new invocation containers, then you destroy them as you go back up, and then call back down. So that's how that works internally. Then we just do this over and over and over again, once for each sort of top level message. Finally, this is built on top of an engine. We use WASM time as our sort of our core execution or VM, and we have some module caches and stuff like that. So that's this. Okay, now you can wake back up if you are not paying attention to this. And now I'm going to talk about FEVM, which is the next milestone. This is coming in February 2023. We already have, as Molly was saying, a testnet. It's very, very bleeding edge. It is missing a lot of important features that we are still working on. And some of the features are currently built with hacks. But like we have a plan, we have a testnet, and it's actually working. So the goal of FEVM is really to bring the entire Ethereum ecosystem to Filecoin. We're not trying to compete with Ethereum. We're literally just trying to say, hey, like there's all this stuff there. There are all these tools. Why do we have to like make our own things? Why can't we just use what's there? Because like we don't have the bandwidth, the capacity of the people to like build this stuff. Yeah, that's the main reason. The other part is that like this lets us sort of play a little bit safely. This means that, okay, we don't have to expose all of our fancy IPLE stuff right now. We get a bit more time to bake that and make sure we get it correct. Instead, we can expose like sort of battle-tested Ethereum APIs first and let users use that. So the way we're doing this is basically we're compiling EVM inside of an FVM actor. Every single FVM actor, every single smart contract or EVM contract will have its own separate FVM actor and its own separate FVM address with its own sort of separate EVM instance. This is fine. It doesn't cost anything in terms of like state on chain because we content address the EVM actor. So basically, the actual actor is two CIDs, one which is the content ID, I didn't explain that, basically one hash that points to the EVM actor code and one hash that points to your current state. So it doesn't really cost us anything to sort of like create one instance of the EVM per actor. The next part here is we have Ethereum addressing through a new F4 address class. This is what I was talking about before. It lets us embed an entire Ethereum address inside of a Filecoin address. So like I can like go to Ethereum tooling, get the address, embed it, use it, get some result out, get back in another Ethereum address, put that back into Ethereum tooling, and all this kind of works. We're getting Ethereum accounts through account abstraction. This basically lets someone submit an Ethereum transaction through, actually, we're going to expose the Ethereum JSON RPC API on Lotus. At least that's the goal. They submit their Ethereum transaction that way. We kind of like smoosh it a bit, make it look more like a Filecoin transaction. And then you can have an Ethereum account on chain that sort of like turns it back into an Ethereum transaction and validates the signature. But this means you can submit like native Ethereum transactions and it just kind of works. So all of your tooling just works. Yeah, as I said, a JSON RPC API in Lotus. This means, again, like MetaMask just works. We're using it right now. There's some hacks properly and stuff right now, but we're still working on fixing all of those. And then finally, we're introducing an Ethereum event system via a new FEM event system. For now, our events are going to be very bare bones. It's basically like, okay, you can write events, but we're not really going to worry about indexing them too much. We're hoping that in future releases, people will come with good proposals for this, but the current proposal is very much like, no. We just write the events. People can use them for like tracking minor actor state and all this kind of stuff, but they're not, it's not going to be like the sort of the end goal. Okay. EVM inside the FVM. So basically as I said, we've compiled the EVM into WebAssembly. We've actually built our own EVM implementation. We based it off of, I think, something called evmodin, but we've rewritten everything basically at this point to make it try to make it as fast as possible. There's no special EVM support. That's really the goal here. Like, we don't want to have any hacks or anything that says, oh, this is necessary for the EVM. We may have some kind of whitelist in Lotus for certain types of messages. This will be more of a minor decision though, and not a Lotus specific thing if we have to do this. But there are some edge cases around account abstraction that I don't really want to go into right now. It make it a bit complicated. But basically the goal is like, we don't want to have any like, oh yeah, this is only used by the EVM. It's like this EVM specific feature, and like instead we're trying to make this general purpose hypervisor where you can sort of put whatever VM you want on top of it, or users can even deploy their own optimized or whatever EVMs. And the final thing is, again, it's first class. It's Filecoin gas. They're all Filecoin, top level Filecoin actors and accounts. There's no like sort of EVM sandbox that just sort of keeps the EVM world separate. It uses the native fill token. There's nothing special about that. As I said, Ethereum tooling. I think I've basically gone over all of this. There's no trusted bridges or translations anywhere. You basically just point your Ethereum tooling at Lotus and it works. As I was talking about, pluggable addressing. This is sort of the specifics. If you have an actor ID 1234, you can plug that in, you'll get F4, which is the address class, 1234 F, just as a separator, and then you get basically the Ethereum address. There's actually a little bit of a checksum after that, just to make sure people don't mistype things, but that's basically how that works. This, again, supports any Ethereum addresses. It supports like create2 and create and all these other counterfactual interactions and like addresses that don't exist on chain interactions, all that kind of stuff. And as I was saying, the custom account types. This is MetaMask using Filecoin with some weird funky gas numbers because we had a bug, but we fixed that bug. Those are insane gas numbers, but yeah, basically, whatever. If you want to test this out, you can. This is bleeding edge. And when I say bleeding edge, I mean really bleeding edge. So like we are actively hacking on this. The network will be reset pretty frequently as we ship upgrades. But it's really cool to play with this because you can just plug your existing Ethereum tooling in with Brave and it just kind of does the thing. But yeah, that's GitHub in case you didn't realize. Or you can scan the QR code. Okay, native actors. This is what we are planning on shipping in around Q3 of next year. Maybe that's the goal, but like Q2, Q3, somewhere around that area. We still haven't nailed down the final dates. We're not going to promise anything until we have actually done our full road mapping. But I could say it's probably around then, but this is like the Steven who has not yet done his road mapping saying that, so you can't hold me accountable for that. So this will allow you to deploy native WebAssembly actors for better performance. You can take advantage of all the applicability features, and you can add new runtimes. The version that's shipping in February will let you deploy EVM smart contracts, but it will not let you deploy new native WASM smart contracts for like security reasons and like just API stability and stuff like that. It gives us more room to sort of finalize some things, but ship programmability now before we're done finalizing those things. Beyond, this is the fun part. So like up next, after we actually get data programmability, we'd love to look into things like parallelism. As I was saying before, parallelism, like I feel that he makes parallelism, like at least certain kinds of parallelism, fairly easy. In terms of parallel processing of messages, that would require some more thought into how we process transactions in general. But like in terms of like parallel workers, where like some single actor could spawn off a bunch of parallel threads and like let some work happen in the background, that's actually fairly straightforward. There's also been a lot of talking about the FVM and the Lotus and actors teams about on-chain task scheduling, or cron. basically user accessible cron. No other chain really has this, but we really want a way to like sort of schedule new tasks on chain sometime in the future and have those automatically executed. We think this would really unlock a lot of cool use cases. We've also been talking a lot about like on-chain reactive programming reacting to events. This is something I don't think anyone else can do either. Most systems require some kind of like Oracle, something off-chain. This is where we'd like to go. And yeah, I mean, hierarchical consensus is not our team. This is the, I guess it's now called interplanetary consensus. But yeah, the FEM is really looking forward to supporting this. But yeah, that's really beyond. So that's it for my talk. I don't know if we have time for questions, but. It's Mike.
What's up? Right. So I think all of us support FEM. This is really awesome. As a storage provider, I think one of the things that we care about is that we are able to prove our data. One of the really annoying things is when you have these spikes of gas when the base fee goes up, and it's faster than your daemon can actually, reset or like up the gas until you actually get your messages on chain, meaning that we start losing our window post. I just want to make sure, because the interplanetary consensus here was also set for Q3, I think, something like that. Yeah, exactly. Which means that we won't have the sharding and that kind of stuff in place, or maybe at the same time. So I just wanted to make sure that, on FVM, that we don't deploy something to mainnet that is actually, I know that we are using the Filecoin gas model and it has been like calibrated, but still that we don't have something where you put on some FVM and now you start to make these massive congestions of the mainnet network, because that would basically kill all our storage proving.
Yeah, that's a very good point. So at the moment, we don't think, like basically, we know that there's a fair amount of loose capacity that's not being used by, it's basically like, it's been taken up right now by sort of like an unaggregated sector ceiling. But if the chain or usage goes up, a lot more sectors get aggregated. We have not done the numbers on exactly how that's going to happen. We have another team working on that right now. I know CryptoEcon is thinking about that. We also have like some ideas of how we could create some kind of like multi-lane system if we need to. This would probably be in a subsequent upgrade. It's kind of like we don't actually know if it's worth it, or it's not if it's worth it, but like if it's necessary, and we don't want to delay programmability for that. The other thing I do want to note here is that this is a very different situation than like December several years ago when like gas was through the roof. Because in that situation, basically, the storage providers were paying for all the gas in the system, which was just a really bad situation to be in, because if the gas is through the roof and storage providers are paying for all the gas, then they're paying for all the gas. But in this case, if the gas prices go way up, that's going to be because other users are coming into the system to pay for the gas. And these users are buying this gas probably from the storage providers, mostly, I assume, because they're the ones getting the block rewards. There needs to be economic modeling here, where basically where the money would come from and how the flows would go. But effectively, like as long as really over 50% of the network is being used by other parties, then the storage providers basically should fine that they get some block rewards, they spend some on themselves, and then sell some to cover the gas. It should be basically a wash. That's my understanding. Again, this requires a lot of very careful modeling that has not been done yet. That is being done. But yes, we are definitely thinking about this. But basically, we don't want to put a lot of work and delays into the sort of we don't want to address this problem preemptively if it's not actually a problem. Because that one, that'll take a lot of time. It could delay the launch of general programmability, which is really important for the network in general. And we just don't have enough information to know if it's really going to be a problem.
You mentioned that there's the whole system is EVM agnostic, but is there a contract that you expect EVM to agree to, and what happens if they break that contract? So right now we are deploying a built-in EVM.
So this is the EVM people will use. It has a well-known code CID, so every actor in Filecoin actually has a code CID. So you don't have to compare the entire code. You just look at the CID and you know exactly what actor it is. In the future, once we have native actors, people will be able to deploy their own EVMs. Then it'll come down to actors to decide which EVMs they trust and which EVMs they don't trust. Is that approximately your question?
I think so. I think my concern was that because like getting Ethereum integrated is huge, but it also creates this weird inverse dependency on if they change something.
Oh, I see. Sorry.
How does that affect us?
Yes. That's a very interesting question. Yeah, so basically that will go through EIPs, and we actually haven't figured out the final answer to that yet. Like basically, if the EIP is generally useful, we think it's useful, someone will make a FIP to import the EIP, and then we'll upgrade the sort of the built-in EVM. If someone deploys another EVM, one of the plans, this is not done yet because we're working on M2.1 and M2.2, but once we have native actors, the goal is to allow actors to upgrade themselves if they choose to, if they import the right syscalls with a bunch of security checks and all that kind of stuff. But that would allow an actor to decide to upgrade itself to like a new version of the EVM. This would be sort of like a choice by the actor itself if they decided to need the feature. Honestly, it's probably not necessary though, because like what you can usually do is you just deploy a new version of the EVM. Because like if you have an old actor that doesn't support this feature, if you have an old EVM that doesn't support the feature, the code running in there is not going to be using the feature. So if someone introduces a new EIP that adds some feature to the EVM, okay, fine, you just say that new actors use the new EVM, old actors use the old EVM. It doesn't really matter too much.
So now, if we bring the EVM and VM on the table, again, I just want to figure out, now we know like lots of smart contract language like EVM Solidity and then Move, and then also Near is using Rust, and we are going to use Rust. So my question would be like, there are so many language and there are developers not just coming from Solidity community. And if I put on the table, here, this is FVM, this is FEVM. I'm not sure what's the pro and con for them to choose what's the better option to go and then to develop on Filecoin.
Well, okay, so that is actually a very good question as well. So for M2.1, so February next year, the answer will be FEVM, because that's the only one they have. They can't deploy native contracts. After that, it does become trickier. Basically, the answer is there will be a lot more tooling for the EVM, at least at first. So like if they want to use the thing they're familiar with, they use the EVM. If they want something that will probably have better performance and better gas usage, native contracts will probably be better in that way. At the end of the day, like it shouldn't, like we're working very hard to make sure we don't have split ecosystems. Like we're adding a couple of opcodes to FEVM that allow you to basically like send and receive sort of messages in native formats and handle native method numbers. And you will also be able to basically just implement the EVM method number in your native contract. So you'll be able to send and receive that way. We're also working on different calling conventions and ways of describing these things. These probably won't completely land by M2.1, but we hope to have them all in place by M2.2. But yeah, basically the goal is to not have like the EVM ecosystem and the native ecosystem. Instead, is to have just the ecosystem where you can kind of call back and forth between them.
Yay, break. You actually get to take breaks, be a part of Filecoin. Ooh. We're going to take a quick 5 minutes break. So, if you have to get any coffee and think there's drink like upstairs, actually can ask the Lotus team to raise your hands here. So if you want to talk to the Lotus team, these are the people you can find. But yeah, I will see everyone in 5 minutes. Hello, hello? Yeah. Test, test. Okay, people that's outside, I think you can hear me. It's time to come back. Time to come back. The cats are summoning. Hello, all the cats that's, wandering in the lobby. Time to come back. Does it work? I don't know if I don't even know. Okay, Ayush, you're on mission. Ayush, bring everyone back because we wanted to hear about data onboarding. Everyone come back. I'm gonna.
Do I have? We have until.
You have like 20 minutes.
20 minutes?
Don't worry about
12:05?
overtime.
Okay, cool.
Who won't cancel the last minute, so we have.
Oh
to-
yeah, that's right.
It's fine. Okay, are folks ready? Yes, we saw some retrieval market friends. Hi, Patrick. Double Patrick. And D-Rand. Woohoo. Okay. Hope everyone had a great break. It's a short one. But anyhow, so we have heard a lot about like core Filecoin, like Lotus, FVM, and like all those like roadmap stuff. But like as Molly mentioned earlier, if you cannot do data onboarding, if you don't have data on Filecoin network, what's the storage network for, right? So Joao, and he's like he just like formed a new team like recently that's like focused on like the data onboarding. So let's hear about the role of data onboarding.
All right. Wonderful. Thank you so much to everybody. Thank you so much for the Lotus team for letting us crash this event. It's an incredible venue, and it's amazing to see so many people here. So I'm João. I am the PM lead for data onboarding. Actually, not quite data onboarding. I'm the PM lead for client growth. What that means is I'm responsible for helping clients, large data clients, whether they're enterprises or research groups or other on-ramps built on the Filecoin protocol, to onboard their data. And I will discuss today a little bit about how we're structured, what we do, why we're here, and hopefully get a better sense, give you a better sense of like all the work that's happening to enable large data onboarding on the Filecoin network. I am a dog guy. I'm sorry. This is my I know. Woo! This is my friend's puppy. I don't yet have a dog. I'm planning to. That's a 2023 OKR. Yeah, I negotiated carefully. I managed to get a dog picture here. I did last minute add a picture of my cat. He is dead, unfortunately. It is Halloween, so I thought that was somewhat appropriate. But that is my cat, Microwave. He did not die in a microwave, but I named him after a microwave because I thought that was cool. I wanted to call him Miko. And so I thought, well, why not? And so, yeah, rest in peace, Miko. But anyway, let's move forward. What is data onboarding? It is a new team within network growth that comprises data programs and client growth. Our teams are tasked with onboarding large amounts of data. And we are the leads here. This is me on the left. And Deep Kapoor, who is leading data programs. I'm not sure if you're here, Deep, but if you're not, there's a few people in his team here that you can talk to. Yeah, together we are responsible for driving the adoption of the Filecoin protocol with regard to the amount of data that's onboarded. And there's a lot of great faces in our team. We're so happy that we've managed to build out this team. It's going to be a really important task for 2023. There are lots of people here because we are going to onboard lots and lots and lots of data. We are setting a target for 2,000 petabytes, right? 2 exabytes of data onboarded by the end of next year, which is frankly quite insane. And so we need a lot of folks who are going to help us figure out the cryptoeconomic incentives, the tooling, the process, the interfacing with clients, if you will, like how can we establish SWAT teams of people who can go in and really onboard data, and in doing so, learn about where the gaps are with regard to product, tools, infrastructure, et cetera. So what do? We support the adoption of Filecoin by providing insights, analytics, ecosystem investments, better tools, and we lead strategic initiatives that enable and accelerate data onboarding. That is, broadly speaking, the mandate for the client growth team. And of course, there is a very equivalent mandate on the data programs team. Data programs, their mission is to design, develop, and operate programs, incentive mechanisms, and tools. So as you can see, it's actually very similar. The way that you can think about it is the data onboarding team is really split into two. My team deals with like actual clients. For example, University of Berkeley. We also deal with storage providers who are onboarding data like Seal Storage that just announced the partnership with Atlas experiment in CERN. So we are actually dealing with like large entities, whereas the data programs team is more concerned with things like Slingshot that I will talk to in a little bit, and you can learn about this afternoon, that are efforts at really onboarding large amounts of public data, for example, right? Like what if we could just take the AWS Open Registry of data and just onboard it all and hopefully create a really useful foundation for data analysis in our distributed network for data scientists who want to do genomics research, Landsat data, et cetera, right? So we're here to really establish product market fit and really test and do a bunch of stuff here that'll make this number go up. What you're looking at is month by month, the total amount of data, cumulative data that has been onboarded to the network. We are tantalizingly close to 300 petabytes, which is fantastic. But it's been really incredible to see the growth coming from all these great partners, whether it's there are more Web 2 native, working on very large scale scientific experiments, or whether they are Web 3 native, like Mirror and Zora and OpenSea, dealing with NFTs, for example, or even Starling Lab, which is a unique partner of ours that is really leveraging the fact that there is a chain of custody on data and really leveraging the immutability aspect of the fact that, if there is data that is being onboarded that is perhaps an attack vector from, with regard to a nation state that does not want to see pictures that may be sensitive for a particular reason, we want to protect those, right? And we want to really employ the immutability and censorship resistance. And so that's an example of a client that is using Filecoin. And so really, these comprise very different use cases, whether it's cost, whether it's immutability, whether it's scale, decentralization. People come here for many different reasons. Okay, and so you saw the number go up. This is another number go up chart. This is the daily rate. So we've hit a peak of almost 4,000 tebibytes last Wednesday, which is amazing. And we really want to sustain this growth. If we want to get to the 10 petabyte, if we want to get to 2 exabytes of data onboarded by the end of next year, that implies a growth of, we want to get to about 10 petabytes per day. And so it's about a 0.5% daily growth rate, which is crazy. It gets to about 15% month over month. So when you get to these very, very large bases, we're really talking about extremely large numbers. Where's it all coming from? I mentioned a few clients. I also mentioned Slingshot, that's being run by the data programs team. Really an incredible effort to get people to work together within the ecosystem to onboard very large public data sets. And Evergreen is an effort to really just preserve them on the network. And so whether it's through special tooling and a deal engine that they're building, for example, to really facilitate this whole process, or whether it's through process work like Phil+, which powers this whole thing from a sort of governance perspective, our team is doing lots of things across the board. So really, we can split it into 4 main sections. We do a lot of marketing, right? It starts with education, and so we have to educate the public, whether it's with our website, whether it's with case studies. We really have to convey the value proposition of Filecoin and really showcase why we're here and why this is important. We do tooling. I'll talk a little bit about some of the things that we are building today. We do process. We facilitate the sort of interactions between actors in this network to really create mechanisms that make use of social trust and a social layer for to really expedite data onboarding. And we do insights and analytics. And so I'll talk to a few of these examples, and I'll speak to a couple of things that I think are particularly useful that we've worked on in the past year. So number one, analytics, right? We've put a lot of emphasis in being able to track and measure what we're doing. Where is growth coming from? We are looking, for example, in the top, like how many daily active onboarders do we actually have? And of those, how much data have they onboarded in their lifetime? So it's really interesting to see the proportion of red really expand over time as people get over that sort of 100 tebibyte range, the threshold. So we're starting to see really clients accelerate their data onboarding and become legitimate, very large clients. On the bottom left, also the same thing. This is a total number of large data clients we're seeing, where a large data client could be a business, it could be an entity, but it could also be an on-ramp. So Web3.storage, which you've heard about, is an on-ramp. S-Tray.tech is an on-ramp. And so these sort of aggregate a lot of different users, perhaps with smaller data, and act as a really significant way for clients to leverage the utility of our network. And so overall, one thing that we're focused on doing is really increasing that proportion of red. Right on the bottom right, you'll see the left expressed as a proportion, where really we're trying to get to about 20% at least, right, of total clients having crossed that 100 tebibyte threshold. 100 tebibytes, really we see that as an appropriate threshold to say, well, this isn't peanuts anymore, right? This is like a large amount of data. You might require specialized tooling. You might require specialized resourcing, whether it's for deployed engineers working with you to identify the gaps that you may be holding you back. So really, we want to make that number go a little higher. So that's analytics, and this is also an example of a process improvement. So Kevin, who is I think in the back over there, yep. Working on improvements to the Phil Plus program. I won't go too deep into that. You can read about it yourself, but it's really a way of using social trust as a mechanism to accelerate data onboarding of verified deals. And the E there stands for enterprise. We all know that most of the data is actually in the hands of private entities. We need to create a better process to handle private data. And so eFil Plus is a really cool program that is being run. The pilot has just been launched, and the goal here is to really qualify enterprise clients and accelerate their onboarding. The website. We've also worked on the website revamp. Right now, you go to filecoin.io/store. You think it's an actual store for merch. I'm not kidding. Many people think that. And so we felt like it was very important to revamp our website and really give users a better sense of what Filecoin is as a protocol, but more importantly, what are the products built on top of that protocol, right? Ultimately, it's about the ecosystem investments that are being made and the builders on the ecosystem that are helping us build better solutions to onboard data, whether those are built around a specific use case or a specific data type. It's really important that we actually help users find the right solution that is built on top of the protocol. And so this site is literally just about to go live. We're talking about DNS records like back and forth. And so I believe that today it'll be live. So I'm really excited about that. OK, what else? We also do a lot of case studies, right? Right now, we don't really have a product-driven growth loop. A growth loop refers to some mechanism by which you accelerate the virality of a product. Like, for example, Dropbox, right? I onboard data to Dropbox, and if someone wants to consume data from Dropbox, it's very easy for them to become a user, right? You say, hey, you want João's PDF? Why don't you sign up? And that's a way of really scaling user acquisition. In the absence of that, we have case studies, which are really a good way also to convey what we're doing and why this is important. And so this is an example of a case study that was done by the Filecoin Foundation for a really cool client called Generate involved in genomics, where I think it's really cool to actually showcase and tell a really meaningful story of how Filecoin really enables an entire business to exist. It could be because of cost, right? We offer comparatively much lower cost compared to, let's say, S3 Glacier. And so this is a way for startups to bootstrap their growth without being too concerned about getting crazy $50,000 bills per month when their business model depends on vast amounts of data being onboarded and used for research. So most importantly, onboarding data to Filecoin, that's been sort of top of mind for me. It feels like a crazy sort of Rube Goldberg machine where you just have to keep doing things and things and things and transformations. And so I feel like each time someone joins my team, I lose my voice on like a 4-hour call describing like how this actually works. And so a lot of the work that we're doing and that the ecosystem is focused on doing is abstracting away a lot of the complexity in onboarding data. It really should be as easy as a drag and drop, or it should be as easy as like, hey, here's where my data lives. It's on tape, it's on Postgres, it's on whatever, I don't care. It just make it easy for it to go from A to B, right? And so a lot of the work that we're doing is really focused on identifying what the process actually looks like for enterprises, for researchers, for individuals, and abstracting away a lot of that complexity. I'm not going to go into this because I don't have that much time, but this is an actual illustration of like, a few of the steps involved in actually executing a deal, right? Like, so Lotus is crucial in this whole thing, but it's, abstracting away some of it, but not all of it. You still need to be fairly technically proficient to run a Lotus node and, learn, like really run some of the libraries that it leverages. So when it comes to data cap, right, like this is a fill plus process. You need to get that done. It's not super easy. When it comes to extracting the data from where it's located and pre-processing it, we need to understand how data is extracted, encrypted, chunked, etc. Transformation from, the data as it is, from bytes into these Merkle trees, and then from the Merkle trees into car files, and all the stuff necessary to really derive the benefits of the Filecoin network when it comes to these cryptographic proofs that are issued to really verify the integrity of the data. It is a two-sided marketplace, so you need some way of executing deals, whether that's sort of in the real world IRL, right? Like you meet here, you meet someone, you meet an SP, and you like figure out a way, like what are your miner IDs? Let's figure out a way of transacting, or it could be online deals, as Lotus facilitates, where it's like a little bit more abstracted, but people want varying degrees of control over where their data is, where it goes, and who is in charge of it. Crucially, last but not least, the transfer piece, right? I keep talking about this these days. The data is super heavy, right? When you're talking about 1 petabyte of data, it is very difficult to move that back and forth. Even with a saturated 100 gig line, you're talking about days, if not weeks, to do that. And so we are working on different ways to engage partners and storage providers themselves to improve their network configurations, to use different infrastructure, sneaker nets, to facilitate the movement of all this data. So, crucially, I see our team as a steward of the ecosystem. We are in the ecosystem team, and so our goal here is to really identify cool opportunities and really elevate them. And so these are a couple of examples of tools that have been built by the ecosystem to facilitate data onboarding. Estuary.tech, which was mentioned previously, is a really cool way of like really abstracting a lot of the complexity. It's almost a drag and drop, and it leverages IPFS and Filecoin both together to create like a more seamless experience. Big Data Exchange is a really interesting example that you should check out that leverages the fascinating cryptoeconomic results of us heavily incentivizing network growth, which really means that in many senses, many examples, you have storage providers willing to pay for data, right, rather than the other way around. And so we're actually seeing certain data owners be paid upward of $2,000 for their data because it is so rewarding to take these verified deals, seal them, and get that 10x power on the network. Web3.storage is also, I think, the best example I find of a really, really usable product that has a very, very sort of clear sense of who their users are, what they're building, what their requirements are, and really making it super easy. So it is absurdly easy to go here, get an API key, and leverage their really clean APIs to do all the stuff that I just talked about, onboard data to Filecoin and IPFS. And so Singularity is something that I actually mentioned at Phil Lisbon a couple of days ago. It's an example of a tool that is aimed at doing all this stuff, but for very large data sets. Again, even if you figure out how to convert files to car files, when you're talking about extremely large data sets, you still need better ways of keeping track of how these things map to car files, right? You're essentially archiving. How to actually, how to build composable and modular tooling that can run either on the storage provider side or the client side and really facilitate very large-scale data ingestion for storage providers. We're also very focused on compatibility with where the data is, right? I've talked about extraction. Can we figure out ways of building out something like S3 compatibility where I can just say, hey, go check out the data. It's in a public bucket on S3. Pull that, do all the car file transformation, execute your deals with miners X through Z, and go, right? And so a lot of that is really trying to identify these really crucial components in that user journey and then figure out how to make them more seamless. So, call to action. I really urge you to engage with our data programs. There's a lot of excellent work being done in our team to help storage providers bootstrap their growth. What that means is, I didn't mention earlier, but our sort of sibling team is storage provider growth. But really, we're two sides of the same coin, right? In order to bootstrap growth of the storage providers, they need to not only have access to hardware, capital, and know-how, but they also need actual deals, right? So two things. If you're in a group here and you have data owners that you're talking to, make sure that you talk with us to help us figure out where and how to onboard their data. And in doing so, we can also leverage programs like Slingshot and Moon Landing that are going to really help storage providers grow much faster. Because it's no use to sort of make all these investments. I spend $2 million coming up with this business. I hire people, I get my hardware, I get my collateral, and then I don't have deals. So we're working hard on that, and I encourage you to check those programs out. I know Caro will talk about these a little later in the day with Angelo. Try your new tools. There's a bunch of really cool stuff being developed. Singularity is a good example. It's at singularity.storage. You can check it out. It's all open source. And I encourage you, even if you're not using it for the end-to-end journey, if you want an easy way of basically taking a bunch of files from S3 and preparing some car files, do that. If you want to do the whole thing and integrate it with Boost and really do the whole deal management with a storage provider and do that whole thing end-to-end, fantastic. There's also some stuff that I think is still a little early to talk about, but there are deal engines that are there is a deal engine being built that will really help, again, abstract a lot of the deal management and deal execution side of things and make it way, way easier for storage providers to just go and be able to go and say, sort of pick verified data from a bucket almost, depending on a policy that a client sets. And so we're trying to figure out how to bring everything together into a cohesive user journey. Join our data onboarding working group. We're on Slack. We have been operating over the last 6 months. Really, that's like the entire existence of the team. But as we, I think, hit our stride, as we have a team, as we've built out tools, as we've made our first launches, we really want to engage with the community. We know that there's lots of people out there building great tooling, building great documentation, figuring out how to do business development and marketing for your various respective teams and tools. So let's help each other. We are a group of people who are passionate about onboarding the world's most important information, whether it's private or not. And so really encourage you to join us here. We will be starting a monthly working group call for data onboarding. This is agnostic of whether you are a data owner or a builder. I don't care. If you care about data onboarding, join us. And that's that. Okay. Here we go. Any questions? Do we have time? Okay. Crickets. I scared you off with my weird cat joke in the beginning, didn't I? Yes.
Do you have any maps of, Two questions. You had the rate of onboarding and the size of the data sets that are being onboarded. Do you have any geographic or spatial or demographic information that indicates data is coming from where it's coming from and geographically where it's going to? And the second question, on the data lifecycle slide, there was a bump at the end that says you must keep these CIDs. Do we have any conventions in maintaining those CIDs and helping the end user keep track of that?
Oof. All right. So with regard to geography, we're working on that. There is a process that is, in my opinion, pretty cumbersome, but it's cumbersome because we want to be transparent of these LDN applications through Fil+ involving applications made on GitHub. We're in control of, or not we're in control, my bad. The governance team is in control of what questions we ask in that LDN process, and we are actively engaging them to add some more metadata so that people who request data cap at least tell us not just like who they are and what their data is, but like where they're coming from and maybe what industry vertical there is. Like there's a few things that I, as like a data person, like kind of I start twitching when I'm like, I can't break this down by like basic things. And so we're working hard to get those that additional information. We do have some more information about where it's going to. It is difficult and tricky to figure out where certain storage provider entities are because not everybody wants to be public about it. There's ways of triangulating their location with IPs. There's ways of looking at wallet funding. But we know that the majority right now is being stored in Asia, over 50%, with a few countries growing really quickly, namely the United States. And so what we are shooting for isn't so much like we don't want centralization. So in 2022, we want to make sure that no single region accounts for more than 40% of the total data onboarded. So we actually expect, hopefully, a pretty even distribution, although right now we're definitely over-indexed in Asia for obvious reasons. Yeah.
I just wanted to share with you here that we have a research scientist, and his day job is studying the transactions on the chain. And I wanted to compare and contrast his sleuthing to what you guys are pulling out of it. And
Definitely.
we see hotspots emerging, and would like to get in front of that.
Yeah, that'd be cool. Any options we have to really figure out location data. For me, it's one of the most fascinating things about working in Web3. It's like you're used to having like infinite dimensionality. It was like exactly where everyone's coming from and what they've done in their whole lives. We don't have that here. Jim Pick is a great person to speak to. And Shannon and Reba, I know in the room also, they've both been exploring different angles at figuring out where these storage provider entities are. Yeah, that'd be great. Cool. Hey, Deep. Oh, wait. Sorry, I'm so used to.
If you're a client, you want to onboard data, go find Joel's team. However, if you're a storage provider and you actually want to onboard data and having that into a sector or on the Filecoin chain, this is the guy you want to talk to or his team.
Thanks, Jennifer. So, hi everybody. I am Jacob Hune. I work at Protocol Labs. I'm an engineering manager, and I currently lead the Bedrock team. And so, what's the Bedrock team? Very quickly. So, if you care about finding data on the network, we operate network indexers. We run a lot of this infrastructure. We partner with other people to do this. We work on data transfers, so improving underlying reliability of existing transfer protocols and then evolving those in the future. So I think Molly said at the beginning that we've improved, we've almost doubled success rates of online data transfer. Still quite a bit there to go, but we're working on that and continuing to improve that. And then Boost, we also work on, which I'll talk more about right now. So the course of this talk, we'll go kind of quick 3 things: the history of Boost, what Boost can do today, and then what the future of Boost might look like. What are we focusing on? And so quickly to dive into the origins of Boost. So back in August of last year in Lotus 1.11.1, we released a split markets and miner process. So Lotus, prior to that, was a monolithic set. And this created problems when you're onboarding lots of data, you're consuming a lot of processes. This can conflict with storage providers getting to window post. So how do we separate those two so that we can independently scale and so that we can protect that miner process? And so this is kind of the architecture that we've moved into, where on the right, upper right, markets becomes this kind of interface for clients. Like this is ultimately where you're making deals, where data is coming in, where data is going out, and then your mining, your stealing processes can then be protected. They can be run on completely separate machines, which is really great, and we'll have some discussions on what this looks like for scaling in the near future. So, and with that foreshadowing, that markets process, in order to do all of this work, we needed to take a lot of these internal code interfaces and actually build APIs around them. So allow the markets node to talk with the Lotus miner process over RPC APIs, right? And so this set up the future of what we'd be able to and create with Boost. And so while we did separate those two processes out, there was still a lot of remaining challenges there, right? We wanted to make sure that for the markets process, for client usability, for storage provider usability, that we could reduce our time to release. We want to make sure that we're landing improvements and patches quickly, and those don't have to match up with Lotus release cycles, right? These can be independent. And so we also want to improve that storage deal reliability, right? So currently, previously, a lot of storage providers were getting around issues with online data transfer by doing offline imports, and so moving data externally and then importing that locally. So how can we improve a lot of this? And then how do we get better UX for storage providers and for clients? A lot of visibility into this system was like really hard to get at. And so we wanted to expose more of that and provide more tooling and better APIs for storage providers, other builders in the ecosystem to be able to extend all of this work. So how do we go about doing that? So, spoiler alert, Boost came from Lotus. So this is why we're best friends, because if you tear something out of somebody and then you make a new thing, you got to be best friends, right? So best friends. Yeah, so we ultimately took the markets process out of Boost, out of Lotus. So if you run Lotus today, you can still run a Lotus markets process, but you can shut that down and run Boost in its place, right? And so this is kind of the evolution of how do we create these companion apps that we can then scale independently. And so the first thing that we released Boost with in June, is when it released, is a new storage deal protocol. And so this is the storage deal protocol 1.2, which we'll talk about in a bit. And the big thing here is we're allowing extensibility of transfer protocols. So if you wanted to store data prior to protocol 1.2, if you're still using 1.1, you have to do that over graph sync, or you have to do it offline. Those are the only two options for storing data. And so what we wanted to do is we noticed that a lot of people were packing up data, throwing car files on servers, and then curling that down, doing the transfer, and then storing that data. So, hey, let's build a thing that meets them where they're at. And so this actually used to be a flow for Textile created Bitbot, and this was the flow that they used. And so when we released Boost, we enabled them to just use the new deal protocol, and then that transfer automatically happened. So there's removed this manual step for storage providers. So we also shipped with a basic lippy2p HTTP protocol. When you're just packing and sending very large files, you don't really need to care about the underlying DAG. You just want to get the thing from the client to the storage provider. And so lippy2p HTTP is just a bare bones bytes transfer. And we actually worked with the estuary team to land this in their system as well as part of launch. Cool. And then with that, we also added unique identifier to deals. So as we've started, as the longevity, the life cycle of these systems has increased, you might want to renew deals, right? So the PCID for that data was kind of the unique identifier, but this creates problems when you might have that piece in multiple places, right? Maybe it's in a sector that's about to expire and then it's going to be in the new sector for the piece. That's not super helpful when you want to look at a deal and you're looking at by the underlying data that might exist in two places. And so we added some unique identifiers for that. And then we also added the deal storage protocol, which lets you leverage that new unique identifier to query that information, get more accessibility to folks. So where we're at today, we can kind of look at adoption. And here you'll see this isn't Lotus versus Boost. This is the markets protocol, because what we're doing is we crawl the network based on every markets actor who's announcing their multi-headers, and we see which libp2p protocols they support, which version of markets are you running. Today, we know that if you're running 1.2, you're running Boost because it's the only implementation to date. But if you're running 1.1, this could be Lotus, which a lot of it is, or it could be Venus. It could be any other implementation that's running the v.1 markets protocol. And so right now, we're slowly growing up over time. I think people are celebrating Halloween and Diwali, or maybe prepping for the 1.18 Shark upgrade. But hopefully we'll get that up in the near future. And so the other thing that we're also tracking is raw byte power and quality adjusted power for Boost nodes. And so right now, we're about 470 petabytes of QAP and about 170 pibs of RBP. And our market share for Boost is right about 17% of total markets node. That number is a little bit higher for actually folks that are actively making deals, because right now that number comes from folks that are just running the protocol and not folks that are actually ingesting. What we want to do is transition over to storage rate by implementation, so we can actually track ingestion rate of data to see how well Boost is scaling over time. And so Lily runs chain data, does some analysis on that. We want to take that data, cross-section that with the information that we have on markets implementation so that we can monitor this ingestion rate over time. So, history, yay, let's talk about what's in Boost. So, one of the things I want to do, because we talked about getting up to speed in this ecosystem can be a little bit painful. One of the things we added recently that will give you some spoilers for some of the things that we have is if you go to the Boost repo, there is the ability to spin up a DevNet. And what this does is it spins up a Lotus Genesis node, a Lotus full node that exposes your RPC API. This also runs on 8 kilobyte sectors, so you don't have to spin up huge nodes. You can run a full cluster on your local machine. Super easy to do. We'll see a little recording of some of that in a bit. This also spins up your Boost node, an experimental HTTP retrieval server that we've kind of built to make it easier for the Evergreen program to replicate data, an experimental bit swap retrieval server, which we'll talk about more in a second, as well as optional monitoring clusters. So you can get in there, get Grafana information, get Prometheus data, like all there. And then a sample deal script. So if you have never made a deal with a Lotus node locally, you can walk through that process, and we'll show that right now. So here, we're just SSHing into a Docker image, our Docker image for Boost, and then we're going to run the sample deal script. And so this is kind of a tutorial that will walk you through exactly what's going on, as well as the commands to run it, so you can experience that whole thing. And then you'll see some fatal stuff here, but that is because of ultimately, like, there's a little bit of wait that needs to happen before things are propagated locally on chain. And so you can just rerun that, and that'll automatically happen. Ways to generate car files, calculate comp with the Boost CLI, make your deal, publish it, and then pull up the UI, see your data. You can do all of this locally, and it takes about 30 minutes or less, which is pretty great, because that used to be a very time-consuming process, so you can spin up that cluster locally and move on with your life. Cool. So with that, with Boost, we also released a pretty simple web UI. You can see a lot of failures here. So one of the things we like to do is dog food. So this is the storage provider that the Boost team runs, thanks to Anton. And so you can see here, like, hey, we're having a problem with a client. We should dig in to see who's doing that, see what's going on, so maybe we can help improve some of that software. With that, we can also dig into the deals as well. And we can go through and see full event logs of what's happening when it's data being transferred, what issues are there, are we getting hookups, is it on the client side, is it on the Boost side, where are these problems existing, so that we can reach out to those groups and say, how can we help? Is it a client issue? Is it a data transfer issue? Where's the problem, so we can help fix it and make that system better? So you also get a lot of insights into storage space. One of the things we noticed prior to moving over, it was difficult and tedious to get into the underpinnings, like what's beneath the hood in Lotus. So we worked to make sure that we had more exposure to those APIs and that we could expose those to users as well. And then you can also see ceiling pipeline. If you like snap deals, you can see everything that's coming up for upcoming activation. You can look at your regular sectors. You can also keep track of where your funds are going, what's being tagged for publishing, for collateral, all that stuff. And then one common question we get is, what about a CLI? Web UI is really nice if you're running a small provider, but if you have to do a lot of automation and regular tasks, that can be super annoying. So what do we do about that? So again, one of the things that we wanted to do when we're building Boost is focus on extensibility. And so with this, we created a GraphQL API, and this is what the web UI uses. Anything you can do in the web UI, you can do in GraphQL. And so ultimately what this exposes is the ability to query everything, the ability to manage deals, so you can publish, you can cancel that, you can execute all of that with curls or anything that you can run over HTTP. You can also manage your escrow funds, and you can subscribe to new deals, deal updates. So in the web UI, you'll be able to see deals changing over time. And so there is on the doc site, boost.filecoin.io GraphQL API. You can actually go through here, and Dirk's got a little video of how to take and go through this Explorer that runs locally with Boost. And you can actually go through there and compose curl commands. So you could create your own bash scripts, you could create your own CLIs on top of it. Again, more extensibility because the Boost team is currently a very, very small team, can't build a lot of stuff, and so we want to make sure other people can do that. So I talked about these experimental services. And so we're going to talk a little bit about those. And so ultimately what we wanted to do with Boost is make sure we're not baking it into a monolithic API. Storage providers need to be able to scale things independently. So how do we make sure that we can do that successfully? Well, an example of this is the HTTP sidecar retrieval service. And so again, part of the Evergreen program we wanted to do was make it easier for them to transfer car files. And so in order to do this, you can just spin up a Booster HTTP server. SPs can actually configure what their HTTP endpoint is. Clients will have the ability to discover that HTTP endpoint, and that allows them to fetch that over HTTP much more quickly. So giving more options based on your flows. We're not trying to push people into any one area. Give them the flexibility to do what they need to do. And BitSwap sidecar retrieval. If you care about IPFS and you care about interoperability, which I hope you do because there's a lot of good public data out there, there's also a QR code to a demo that Dirk did last week at IPFS Camp, where you can actually see this happening live in production. So ultimately, what the BitSwap sidecar does is, along with announced indexes, we'll say, hey, we support BitSwap and we support GraphSync. These are the protocols that we support. Later this year, we'll actually also be able to say, hey, that BitSwap transport that you want to talk to, go to this multi-adder, and that will allow us to independently scale these services, right? We can independently scale BitSwap retrieval, we can independently scale GraphSync retrieval, and we're going to do that over time. Remote ComP. So one of the things we want to do is scale. And so with that, Boost has been a bottleneck for ingesting data. Eventually, you get to the point of you have to run so much ComP that it gets really slow and you can't ingest more data, and we're now a bottleneck. There's a bunch of ceiling workers, but we can't leverage them all. So one of the more immediate things that we can do until we get more horizontal scaling with Boost is hand off remote ComP, hand off ComP calculation to the ceiling workers. So we can say, hey, I've got this data in, ceiling worker, can you go ahead and check and make sure that's good to go? And then I'll run into ceiling later. Thanks to Magic, I think did this in like an afternoon after talking with him, gave us the API endpoints that we needed so that again, we could handle that ourselves, which has been really great. So those are some of the features that exist in Boost today. And so what I want to talk about is a little bit of what we're looking at for the future of Boost. What did the next 6 to 12 months kind of look like? And the big word is scaling. So I think the network growth team is hoping to hit 2 EB on the network next year, which is a huge number. And so Boost is going to be, we want that to be a big part of that. How do we improve this? We also have Saturn that just launched and is eventually going to be falling back to storage providers to retrieve data. We need to make sure that we scale. We need to make sure that storage providers can handle that without it causing problems in their system. And so part of this work is Boost is still somewhat stateful. We've gotten most of it pulled out. The thing we're currently working on is the piece directory. And ultimately what this does is all of the data that you store that is being indexed, if you have indexing turned on, hopefully you do, for public data, that the index store or the piece directory keeps track of all those indexes for retrieval. So as users come in, they can go to the piece directory, they can get that information, we can fetch that subset of data, serve it back to them. Right now, that's part of the boost process, and what we want to do is move that out to a scalable process so that we can treat boost nodes as ephemeral, so that you can spin them down, spin them up, it doesn't matter, all of that state is contained elsewhere. And so this is a huge thing for us getting to N+1 boost nodes, which we're hoping to do as part of our work in the coming months. So, and then on this storage side, so kind of a rough number that we want to hit is to get to a state where storage providers can pull in at least 1 petabyte per day and beyond. So there may be very, very large storage providers who can do more of that in terms of their ceiling capacity, and we don't want boost to be a blocker. So how do we get there? And part of this is getting to end-to-end boost nodes to Lotus workers. So we're going to be working very closely with the Lotus team. We've had some discussions this past week as well. And so ultimately, we want to make sure that we're in a state where all of this can scale and that the software is not a problem, it's not a blocker for storage providers. So on the retrieval side of things, like this has been a big thing that we've been working on in the past months on Bedrock. And so the things that we care about are resiliency, reliability, and performance. We need to scale to meet the needs of the network without causing problems for storage providers, make that really easy to use. So we're looking at the ability to also scale. We talked about extensibility, modularity of these pieces. We want to be able to independently scale retrieval and storage, because onboarding rate and outboarding rate might be different, right? And so how can we independently scale those to meet the needs of those particular storage providers? Because they're likely all not going to look the same. So the other thing is optimizing for performance and improving visibility and hot paths. We talked about some of this like default monitoring that we're doing. So our team's actually been working on doing like full tracing all the way down from a retrieval comes in through HTTP or BitSwap or GraphSync. We can trace it all the way down to the sealer and see like where are the issues? Like what problems do we need to fix so that we can make sure, again, it's not a software problem. And then we want to make sure that providers have, or SPs have the interfaces to optimize their own setup. We want to give them some sane defaults, but then work with them to make sure that they have everything they need to customize it for themselves. And then reducing operational overhead. So one of the big things that we believe on Bedrock is to dog food. And so we have network indexers, we run network indexers. We're building stuff for storage providers, we act as a storage provider. And so as part of what we're doing for scaling, we're actually going to be increasing the size of one of our own storage providers so that we can deal with the pain points here, like feel the pain, so we can make sure that all of this is easier to do. We don't want to be in a situation as a team where like, we've got to hire somebody to focus on running these systems. Like, we want that to be as lightweight as possible. We've already made a lot of really good improvements there. I think we used to babysit our storage provider like multiple times today, and now have gotten to a point where that's much lighter, and we want to get that even lower over time. So the other thing is, if you're having difficulty getting data in or out of Filecoin, come and talk to us. I think there are several folks from Bedrock here. You can raise your hands, wave, say hi. Yeah, talk to all these folks. And yeah, questions, come chat. Hit us up in the project repo or on Filecoin Slack. Question in front.
Let's say I have a storage or a miner instance of about 10 petabytes. Can you plot the trajectory of the ratio of the number of miners to Lotus instances that are required over the span of, I start off completely empty, I'm fully onboarded, and I'm going to carry that through to the last contract for data retention. What would you plot as the ratio of market nodes to a 10 PIB miner instance across its lifetime?
Yeah, so that, I do not have that data off the top of my head. So I think this is something that we need to figure out for part of our onboarding, is to figure out what the throughput rate is. What do your outgoing pipes look like? Are you ingesting data locally? Like, how much can you actually ingest? And then what is the throughput rate on all of the ceiling workers so that we can verify that, but don't have that number right now.
Thanks for the presentation. So Lotus and Boost are best friends, so we don't have to be each other's only friends, because nothing about Boost is ultimately specific to Lotus. Are there active plans to integrate Boost with the other implementations, such as Venus and Forest?
Yeah, so we're actually, I think, just talking with the Venus team today. So some of the stuff that we can do, because again, Boost is separate as an RPC. It just talks to Lotus over RPC API. So it's very probable for us to get to a state where we can actually just talk to a Venus cluster and hand data off. And so there's actually, you can join some of that discussion happening right now in the Boost GitHub, or the Boost Slack on Filecoin. But that's the state that we would like to get to. There's obvious advantages of having more implementations of markets, but we also want to collect them all. So, yeah.
Yeah, so obviously Boost is also doing a lot of retrievals right now, and we see with Evergreen that has been running that we actually rely on using something like Boost to actually make this happen. I just wondered, in the UI, there is very light coverage of retrievals. Is that something that's going to happen now? I know it happens underneath the hood, but will that also be reflected in the UI at some point?
Yeah, I think that's a really good point, and I would say yes. And so a lot of the work that we had done leading up to this year was focusing on the storage aspect, like how can we improve some of those aspects. But retrieval is becoming more and more of a problem, especially as we look at the scale of scope that's coming in. So we absolutely do want to improve visibility there, and would love to talk to what that should look like. Yeah. I can see. All right, thank you, everybody.
Lifesaver. Thank you, Soso. Now people can hear me. 2, 1. Yeah. Woohoo! People people on YouTube, welcome back to the Lotus Data Onboarding and like Friends Day. I didn't even know we are live streaming, so I'm sorry for all the bad cat jokes in the morning. I'm gonna try to not make any this afternoon. But yeah, as I was saying, we're gonna do 2 tracks like later this afternoon. So one is gonna be more technical, focus on the deep dives into the Lotus miner, into the Filecoin proof system, data onboarding, workshops, things like that. And on the other room, like the Nina room, we're gonna be focused on the business development ecosystem, like data onboarding, all the program that support you to joining the Filecoin ecosystem. But to kick us off, we are gonna be joining by 5 amazing human beings to show you the path to become an enterprise level storage provider on Filecoin. Do we have the folks ready? I guess not. We're gonna wait a little bit. Okay, I'm gonna take this time to actually introduce all the Lotus cats, because like you have seen a lot of the cat photos this morning. But as you have seen that we have like Magic's. So this is Magic's cat. Ayush's cat. Ayush, that's Ayush. So we have like Nina here, and that's like Kuba's cat, and that's my cat, Aussie baby. But yeah, okay, I stalled enough time. Stefan, come on stage. Yay!
Thanks, Jenny.
Some other people joining us. Where are you sitting?
I guess I'm here. Okay. All right. Oh, there we go.
What's up?
You guys want to grab mics in the back?
Oh, you need a mic. You have a mic? No. Oh, you need a mic. I need a mic.
Well, we can go ahead and get started as we're still figuring out the AV. Thank you all for joining. My name is Ashwanth. I'm a startup operator at Protocol Labs. Excited to be moderating this panel today with some very esteemed guests. We've got both kind of the business development side here represented, and we've also got the engineering and tooling side represented. So pretty excited to talk to you today about path to being an enterprise storage provider. So before we dive into a lot of these topics, I think we can just go down the line here. If you guys could introduce yourselves, explain a little bit about what you're working on, and maybe something cool that you've accomplished this year that you're excited about and want to share with the group. So with Stefan, we can start with you.
So Stefan, I work for Protocol Labs. Responsible for network growth, and that includes 3 pillars. 1, the storage provider ecosystem. 2, the client growth, bringing more Web2 customers to our ecosystem, which is led by Joao, which you've already seen before. And then the 3rd one is data programs, which is led by Deep Kapoor.
Thank you, Stefan.
Oh, something exciting?
Yeah, I don't know.
Oh, I think
there's anything exciting.
Lots of exciting stuff, but the most exciting stuff has been us going back into the field, like actually meeting with our ecosystem members. And we've done 6 major events. This is the 7th event in different regions. And everywhere we go, whether it's Korea, Singapore, Amsterdam, Lisbon now, Austin, you name it, or Bogota, you name it, the passion for Filecoin is there. And it's the same no matter what culture you come from. That's like the coolest thing, that you find all these people worldwide that have the same desire, the same excitement for this technology.
Great, thank you. Anton?
Hey folks, I'm Anton. I'm working on the Bedrock team, lately with the Boost team, basically developing the Boost market implementation. If you've seen the talk from Jake before lunch, that's basically what I've been involved in for the past 1 year. And before that, worked on various testing strategies for Lotus.
Great. It's great to meet you. I don't think we've ever met before, so it's nice to meet you on this panel.
Likewise.
Great. Orion.
Hey, everybody. Can you hear me? Yeah. So my name is Orion. I am on the Lotus team. Before I joined PL, I was a storage provider, so I know a little bit about running a storage provider. Not at a big enterprise scale, but I also see a lot of issues around there. Currently I am a project manager and working with all the cats.
Great. And I've met Oran many times on Zoom, but never in person. So great to see you in person. And Kevin.
Hey, everyone. I'm KZ. I work on the network growth team with Stefan, and I'm heading up as project lead for the Enterprise Phil Plus project we'll talk about here.
Awesome. Well, thank you all again for being here and for your time. We'll go ahead and kind of start with almost like a state of the union. Would love to hear, where is Lotus, where is Boost, Bedrock, the teams at, where are these teams at today in terms of building for enterprise scale SPs? And so, Oran and Anton, we'll look to you to kind of kick us off here. Would love kind of just an overall look back of where we're at.
Yeah. So I think we are at a very interesting point in terms of the Lotus miner side, because we have SPs that started in their basement with a single computer that are now running racks and racks with servers. So we start to see a couple of issues that was not present before, just because of the sheer size of their operations. So we are 2 years into this Lotus and Filecoin experiment, and we are growing very large, and that also brings new challenges, which are kind of interesting.
Yeah, and maybe a follow-up question there. You mentioned that you're now building for these enterprise scale storage providers, and before maybe a bit smaller. So what are some of the trade-offs that you have to consider, and how difficult is it to build for both of these types of SPs?
I would say it's quite difficult because you have to consider the complexity of running very large operations. And we don't want to cut off people from starting with a single computer and learning how a Lotus miner works. The developers need to run their dev setups. So when you get to 100, 400 servers, there is a lot more complexity involved. But as a software, you also want to make it easy to deploy a dev net.
Got it.
Or dev setup.
Yeah, that makes a ton of sense. Anton, any follow-up there, or do you agree? Do you disagree?
Well, at the moment, there are some indeed scaling issues with Boost and Lotus in general. If you are running at enterprise scale, for the past 1 year, we've been focusing on improving reliability, mainly of storage deals. So we've done a lot of work there, but at the moment, if you try to onboard data with Boost, you do have an upper limit of how much you can do with a single miner ID on chain. I believe the upper bound is probably around 200 tebibytes per day. And we want to be able to do something in the realm of 20, 50x that in the future. Admittedly, the reliability has improved a lot over the past 1 year. So storage queues are mostly working nowadays, both offline and online. As Jake mentioned earlier, before Boost, storage providers literally had to add a lot of hacks around online deals. So transferring data over the network, they were leveraging offline deals to do that, which is not ideal. So that's what we've been focusing on, improving the reliability of the system as a whole. We're also looking into improving retrievals so that you can actually get your data from storage providers. And last but not least, reducing the complexity overall within those Filecoin implementations, namely Lotus and Boost. We want to be able to have bounded context for specific functionalities so that we can easily onboard new engineers, spread the knowledge around within the teams so that folks like Y, Magic, and the rest of the Lotus team can go on vacation without worrying what's happening within Filecoin.
Yeah, protected vacations are definitely a goal to strive for. That makes a ton of sense. Well, I guess as we think about this, do you all see Lotus and Boost branching off into maybe different versions, one mainly meant for enterprise SPs, one meant for smaller SPs? Where do you kind of see this going? Where is that tipping point?
I think I can only speak for myself here, but I think we still want to keep Lotus, certain parts of Lotus the same for the same entities. Because if you start to have like two different versions of the software, that introduces like complexity in like maintaining both. So there are trade-offs just like branching them off. Ideally, you could keep it in the same software, but rather have the ability to like spin out like microservices for like different parts.
Well, ideally you need to be addressing the whole market, and that's very difficult to do with such small teams. So I think in the future we want to keep both Lotus and Boost flexible, so that whatever the teams within Protocol Labs can't address, it should be possible for the community or to individual companies to come in and address those needs. So we're thinking from a perspective of not limiting the functionality and how folks can actually help themselves solve their own problems. So in a sense, we're not focusing only on, let's say, enterprise storage providers or on small storage providers. We're trying to address the whole market and make it possible for other folks to also specialize within these areas.
Yeah, you bring up an interesting point, and don't worry, Kevin and Stefan, I'll be getting to you guys in a second here.
I like this.
But you bring up an interesting point, I think, around community, right? And the scope of the Lotus and Boost teams is very large, and the way that we're kind of talking about it, it seems to continuing to increase potentially increase in the future. So where do you see that line being drawn between, this is something that will be taken care of by the Lotus and Boost teams, or this is something that we'd actually encourage the community to kind of take on and build out themselves? Filecoin is a very unique ecosystem where you have Protocol Labs and then also community members building and working together. So where is that line drawn, and do you see a line drawn? Oh, yeah, it's fun.
Chime in on that,
yeah.
if you don't mind.
Yeah, jump in.
No, I think it's what's really cool about our stack is that we didn't take care of everything. And I mean that in a good way, meaning there's potential for innovation on the top and innovation on the bottom. What I mean by that is, for example, encryption, compression technologies can be implemented by the tooling that's actually onboarding the data. It doesn't necessarily have to be embedded in the stack. Same thing on the bottom, meaning the lower layers, like erasure coding or similar redundancy solutions are not embedded into Lotus. And we get this question once in a while, like, hey, why did you not embed this into the stack? And to me, the answer to me is like, yeah, this is actually better because now you as a storage provider, you can actually choose what stack or what technologies that are already in the market or in open source stacks like ZFS, or maybe it's an object store that has built-in erasure coding. You can just apply that so you can kind of accelerate your path to where maybe alternative solutions are, right? Like Dell or NetApp or you name it. So you can kind of use those technologies. What we then have to do in Lotus, in my opinion, is ensure that we also take care of those integrations and test those, right? Like, for example, use an object interface on the back end of Lotus, or use a distributed file system. I mean, there's ways to go about it. But to me, that is, ensuring that we have the core functionality, and definition of core is quite crucial here, but is going to be important. I don't know if that rings a bell or if you disagree with it.
No, I think that makes a lot of sense. Since Lotus has to think about all the different users, there will be gaps where different companies will probably try to implement their own solutions, right? We will have to think about what hardware can this software run on. Some companies might want to fine-tune that to their specific hardware components, and such things will probably never be implemented in Lotus.
Yeah, I think we see that today, where some storage providers will definitely take the base Lotus and then kind of jerry-rig it themselves to maximize performance. So I think that definitely makes sense. Anton, anything to add? Or?
Well, I agree with what Stefan basically said. You have to kind of define what's the core functionality, and you have to limit the scope of what you're building. Within the Boost team in particular, we've certainly said no to a few tools that folks have asked us from. For example, everything related to building, let's say, the car files out of your data. There are already a ton of tools out there, and different organizations have different process around that. So we've consciously decided that we don't want to support those tools, and we basically want for this to be outsourced to the community. Yeah.
Got it. Thanks for the extra context. Amazing. So now that we've kind of focused on the tooling side and what we can provide to enterprise storage providers, I want to flip it to Kevin and talk a little bit about the client side of things. So when we start approaching clients to potentially store data with storage providers, what are they thinking about? What are they looking for? What are some of their KPIs that they want to see from enterprise storage providers?
Well, and just to touch on, actually, when you get to the beginning of the cycle, the first piece is getting data cap through the Fill Plus program. So for those of you not familiar, TLDR, it's a mechanism where we use to verify the data and provide the clients or the SPs with the mechanism to incentivize storage providers to store the data that's been verified through notary approvals. So when we start thinking about enterprise, data owners, the majority of their data is going to be private. So because we're not going to be able to sort of, as they go through Fill Plus, it's not easy for them to go through and get the data cap as it's set up now. There's been a few use cases where some private data sets have gone through, have got approvals, but it takes a long time, a lot of energy from the governance team and the SPs. So we're looking to streamline that and help them, these private data sets, get onboarded a lot more quickly. We're asking for the data owners to actually provide us with a bit more information about who they are, to do a KYB, know your business check up front, just to sort of showcase they are a legit verified business operating somewhere that we can start to build trust around. And then hopefully the notaries will be able to do the due diligence easier and provide the data cap for them. So that's really the first piece of this, is enabling these private data sets to get data cap. And this is what eFill Plus is setting up. And also there's the SP component of this. Is there's a lot of SPs right now that aren't really set up or enterprise qualified, let's say. They're not running a large data center, having potentially all the fill they need to support the deals. So this is also a pilot to help SPs sort of level up, and as they're growing, they're bringing clients on. They have use cases that they want to onboard data with. So this is an opportunity for them to sort of lead and build out the SLAs, come with the client requirements that they're looking for, and bring all that through and help it get approved and start onboarding it. So
yeah, let's definitely dig a little bit deeper there. Stefan, what are some other factors that storage providers must implement in order to become what is considered to be like an enterprise storage provider? Kevin mentioned a couple. Do you have any more to add?
Yeah, I mean, there's a ton of things, but in general, if you look at the ecosystem, there's definitely, as what Kevin was saying, there's different types of storage providers, right? There's the wholesale, the ones that just want to, really bring down the cost as much as possible. They understand technology really well, but they don't necessarily want to go deeper into how to onboard data, and they're expecting the network to bring in that data to them because they have a cost benefit or a performance benefit, whatever you name it, or they're in a location where no one else is located. Second is the other storage providers that we see are more like white glove, that are providing more white glove services. So they're really like going out to customers, bringing those customers on board. They're looking for quality storage providers, right? So they're trying to build social trust and try to build the relationships that guarantee that a certain SLA is met. And so that's why we're doing some of these programs like Project Moon Landing to bring more storage providers together. A perfect example is we went to Korea. Some Korean SPs weren't aware of Snap deals, even though it's been released for more than a year. And so we had a lot of education to do. And then second, they were looking for other storage providers to close deals with. And so a lot of the challenges that we've seen is like making sure that we connect those storage providers, because in the end, the trust, the social trust, is, even though we're trying to build social trust with Filecoin Plus, it still takes a little bit of time to build that trust. And typically the trust is built after you do some transactions, right? And you start to understand what is the network connectivity, what's really the performance that they can drive, are they reliable, meaning do they have capacity when they say they have capacity. So that tooling is extremely important to build trust with the enterprise customer that's actually going to use that service. And so a lot of the programs that we're driving right now are really to help enable and accelerate that social trust. And one of the key changes that we've made, or the requirements that we've made in Filecoin Plus, which has been so crucial to achieve that, is exactly the need for storage providers that apply for a deal, or whether it's an enterprise client, but mostly it's a storage provider at this point, that applies for Filecoin Plus. They are required to store 4 copies with 4 other SPs in the ecosystem. And because of that requirement, they're forced to reach out. And so basically ensuring that we have tooling and we have ways to build that level of quality, that level of trust between these SPs is going to be crucial for enterprise customers to feel comfortable, like, yeah, I'm getting the same experience, I'm getting the same quality of service if I use this set of SPs.
Yeah, so it sounds like tooling, establishing relationships. I'm curious, how much do you think specialization in a specific industry matters in terms of becoming an enterprise SP? For example, we've seen Seal really hone in on the research vertical. Are you kind of seeing that in clients? They're looking for storage providers who are already storing data in a specific industry.
I think we're starting to see the different use cases pop up. Stefan probably has seen some of the different verticals that are standing out, but I'm curious, as this eFil pilot kicks off now, we just started last week, I'm curious to see who's applying for data cap with private data sets, what industries they're in, where they're located. So we'll have a lot more information really soon to answer your question. Yeah, and I think each use case is going to be a little bit different. So our job is just to enable everyone, collecting feedback, connecting SPs with each other, finding tooling if they need it, just to help them get through the system as efficiently as possible with a good experience. Data owner.
And we're seeing like a natural evolution, right? I mean, it feels very similar as 15 years ago when object storage came out. Same thing. We also then saw the academia research institutes jumping onto object storage. Why? Because it was easier to access. It was more cost efficient. And not only that, actually the research departments, they feel the pain. They feel the pain of not having the budget to actually do more compute and do more research, basically, instead of spending all their money to storing the data. But also the type of person that's willing to take on a new emerging product like Filecoin has to be someone who is like willing to take bets. And so that happens in like with these early adopters, and the early adopters are typically less regulated because they're just moving forward. They're going against sort of like the traditional, more conservative, right, architectures and so on. So that's why research is coming up. We're seeing also like video data sets, like surveillance as well, like because that's a very cost-sensitive market. We're seeing smart cities. So we already have some SPs that are working on smart cities, so IoT use cases, which is amazing. So early signs of that, where they're looking at, Filecoin can be deployed at the edge, and then we can maybe even start to look at Saturn eventually. But right now, it's like that is very promising.
Got it. And before moving on from this topic, Kevin, want to give you an opportunity to kind of share with the group about eFil Plus, which is a new initiative that I know that you're working on piloting and is really geared towards onboarding and more enterprise storage providers and clients.
Yeah, we touched on it briefly a little bit earlier, but just to quickly highlight again, it's this idea of enabling private data sets to get data caps. So we're asking for the data owners who are applying to provide a little bit more information to build a sense of trust within the Fil Plus system with notaries to enable them to get data cap. We're also supporting SPs who are leading these projects to either become enterprise qualified or to continue to hone their skills and sharpen their qualifications. And then also one other thing to mention that I think that's pretty cool is we're sort of spinning up working groups. So there's been a lot of SPs that are interested. 30 SPs signed up to work on this pilot, saying that they have customers. So they're part of a working group now where we're talking about requirements for this project, connecting the SPs together, finding ways to help with, starting to talk about encryption tooling now. Now that they're going to start getting data cap, they need to be thinking about how are we going to onboard the data. So SPs are asking each other, well, what tools are you using? And so they're starting to build a nice supportive community, which I really like. And I saw yesterday there's another working group that was built, permissions. There's a permissions working group that's being set up to start talking more about encryption and those types of things. So it's good to kick this off and get things started talking about private data. And then when we start talking to bigger enterprise customers down the line, the system will be set up well.
Yeah, it's a super exciting project that I think is going to put Filecoin in an amazing spot for taking on enterprise clients. So thank you for all the hard work there. And briefly, I think, Jenny, let me know if 14:20 is our stopping point. How much time do we have here? Keep going. Okay, great. Well, one other thing is, in terms of blockers, what are some of the biggest challenges that we face in helping enable storage providers to become enterprise storage providers? We'd love to actually hear from the whole panel here. Maybe Orion, we can start with you. Do you have anything from a tooling and product perspective? What might be the one biggest blocker in your mind?
There are a couple of things, and Magic is going to talk a lot more in depth about these things later. But it's basically around just getting to a really, really high scale, as well as having redundancy around the data. So I think those are like the very high level blockers to like making the Lotus miner a enterprise ready software.
Got it. Anton, anything from the Boost side?
From my perspective, it's very important to close the gap between storage providers and the actual engineers who built those projects. We are building an open source project. We don't have control over the environment of SPs. It's a decentralized ecosystem, and that's very different to the traditional storage providing products, so to say. You don't have access over the infrastructure of those storage providers. You don't necessarily understand their needs very well because they're not within the same company. They're not your clients. They're basically using a public protocol which is permissionless. So closing that gap, I think it's important so that engineers understand the scope of the problems they're facing, also understanding who the user is, because as we explained earlier, we are trying to build for the whole ecosystem, not just for a specific subset of storage providers. So nailing down the user stories there, the actual requirements, and having a tight feedback loop with those storage providers is very, very important. Yeah. And that's what's challenging in the decentralized world compared to the centralized.
Yeah, it's great to hear you say that, because I think we do hear that a lot from the storage provider community, right? There's a lot of feedback coming in that you all have to balance as the ones who are in charge of building the product and tooling. As we kind of turn to the future, what are some ideas or ways in which you think that you can kind of make that feedback loop a little bit tighter? What has worked in the past? What hasn't worked? We'd love to just dig in a little bit more.
I think what has worked is meeting those people at conferences like this one. You need to meet them somewhere. You need to be getting feedback from the specific people who are actually using your product. You have to be using those protocols and software projects internally as well. And that's what we are heavily focusing on within the Boost project. We are also a small storage provider ourselves. We are also trying to scale our operation so that we can feel the pain of our, I wouldn't say customers, users. That's the main thing.
Yeah, it's a great way to put it. Yeah, going back to the original question, Stefan, biggest challenges to becoming enterprise storage providers?
I agree. I totally agree with what you're saying, Anton. I mean, it's focus and getting a tight feedback loop around the focus areas that we do want to focus on, and being clear about what we can't do right now because we have limited resources. And so our focus is in like particular use cases that we just described. Start there. Definitely those that have a higher probability of success, definitely with like the current feature set that we have. And then two, enablement. I think, the other challenge we have is, and, I've seen this globally now, is, we have to translate our content. We have to, be more actively reaching out so that everyone understands what is Boost, why is it so important, actually making sure that they install it, engage. And I think that's the community effort and the marketing effort and our continuous engagement with the community, not just in person here, which is awesome, but also online for those that couldn't make it, because it is quite an undertaking to come here. So that's going to be our effort, right? A lot of our focus area for the next year is to, and that's a KPI, that's a target for us. Right now we have 13% of the storage providers or SPIDs worldwide taking deals. Our goal is to get that up to 40% by the end of next year. Hopefully we'll outpace that, but we're setting clear targets, and we're doing that through a combination of, new projects, meaning like bringing SPs together, but also training content, translating that in local languages, because that has been proven to be a bottleneck, right? And I can totally understand that. and then making sure that the feedback gets collected back to the engineering team. So yeah.
Yeah, and it sounds like a big priority, for next year is also onboarding data. I think yesterday you mentioned 2 exabytes of data, and that would also require a lot of collateral. So I'm not sure if you want to.
Yes, I was going to bring that up. But so if you look at our target is 2 exabytes of capacity by the end of next year. So how do we come up with those numbers? Today we're onboarding around 3 to 3.5 petabytes a day of actual data that's being stored on the network, which is awesome. Around 50 to 70 onboarders on a daily basis. Our goal is to increase that. So by the way, the average onboarder is onboarding around 53 terabytes a day, right? So you can support that with 2 10 gig Ethernet interfaces or network connectivity. And so our thought process is that this could easily go up to 10 PIB. Just looking backwards at the growth rate that we have seen, if we just project that forwards, we actually would maybe even go beyond that. But we think 10 PIBs a day by the end of next year is a great target, which gets us to 2 exabytes of total capacity. Our target initially for the end of this year was 350 petabytes of actual data stored on the network. Looking at the current rate, we're probably going to outperform that, and we're probably going to reach 400 petabytes, which means that next year, if you want to achieve 2 exabytes by the end of next year, we have to do 1.6 exabyte, and that turns into close to 100 million Filecoin in pledge. Now, this is, of course, rough numbers because it's more complex than that. But what does that mean? That means that we need a lot of liquidity or a lot of fill for this, and we are very excited to see the DeFi solutions. There's some startups here right now that are working on liquid staking on FEM, which is awesome. That means that anyone that in the future could be able to stake Phil onto our network and actually share in the upside of the storage providers' rewards, and at the same time help grow the ecosystem, which is exactly what we want to do.
Great, thank you. Kevin, want to give you a chance to respond as well in terms of biggest challenges you think we face, and then maybe we can open it up for questions in our last few minutes.
Yeah, just to really touch on, again, the beginning of the data onboarding funnel, for SPs, again, the clients aren't necessarily coming to us. The SPs are bringing them on right now, right? So SPs are coming and saying, hey, I have a client, want to onboard, and there's a handful right now that are able to do all steps of that, from the BD, the contract management, to helping them actually onboard the data and store it. But a lot of the SPs that want to become at that level, they have some work to do, and there's a lot more that they don't know they need to manage. That's a lot of work. The SLAs, the contract management, the making sure they have enough fill, those types of things, and just being more than just a storage provider. They actually, becoming the business development side and setting that up. So by us enabling them and supporting them as much as we can during this pilot that I'm working on and other projects, we're also looking to, like Anton mentioned, collect as much feedback as we can from them about their experience and keep iterating. So hopefully, because we're supporting them, they're going to give us lots of feedback. We'll keep that loop going, and we'll just help make this better for everyone and sort of rise all the SPs up to become enterprise qualified as they wish.
Yeah, I think a word that all of you have mentioned is enable or enablement, right? And I think that's great. It's very indicative of what all of you are building, all of your teams are building. So yeah, did you have?
Yeah, one thing I want to mention too is we get the question at times hey, what are you doing about the ceiling? Right, it takes a long time. So there is this is why we started the Decentralized Storage Alliance, where we have AMD, Seagate, ENY coming together, working on a regular basis, actually brainstorming, and not just brainstorming, but testing stuff in the lab, because these vendors are running a Filecoin storage provider system to also not only feel the pain, but also find ways to optimize where they can improve performance and optimize the hardware specifically for a Filecoin system. So, through this alliance, we can actually drive also more standards, right? So something that we didn't want to drive from Protocol Labs or the Filecoin Foundation ourselves, we wanted to do it with the ecosystem, and that's hopefully over time going to get more of the new emerging technologies that in a lot of cases only the hyperscalers, like the cloud providers, have access to firsthand, right? Because they're buying the most hardware, and so they get access, so they get first dip into this technology. Our goal is to bring that technology faster to our ecosystem so that the cost will come down, performance will go up, and over time the goal is for them to be competitive with the cloud providers as possible. through this alliance. Yeah.
That makes sense. And yeah, huge announcement, yes, 2 days ago now. So great work on the Decentralized Storage Alliance. I think we'll take questions maybe for a couple minutes here. If anybody wants to ask our panelists anything, now would be a great time to do so.
My favorite color is blue, just in case if anyone wants to know.
Yeah, maybe we have a mic up here, or if not, you can yell it and we can repeat it as well, if that works.
There's mic coming. IPLD. IPLD.
I apologize for not getting the name. The second man. Yeah.
Orion.
Okay. You hit on something that's near and dear to me. I'm John Sekerbeck with Seagate, and you said that some of the challenges is the redundancy at the storage providers. And I'm wondering if you can expand on that, what single points of failure you're trying to mitigate for, the manageability aspects. And I'm wondering if you guys have seen any of the storage providers starting to leverage composable infrastructure. As Stefan alluded to, part of my mission is to bring the technology we haven't restricted it, but our only customers for hyperscale technologies have been the big players. And we, Seagate and AMD want to bring the hyperscaler technologies and enablement to you guys. So on that note, when you are talking about the need for redundancy and the single points of failure, can you expand on what you want? Tell me what you want.
Yeah, so there are, and as I also said, Magic will talk a little bit more about this in his talk, the deep dive into the Lotus miner. But there are parts in the Lotus miner that are not redundant, that definitely should be redundant. The storage providers can do a lot on like the storage level themselves, which Lotus does not do anything about. But there are like things in the Lotus miner, like the window post that you have to prove every day. Like those kind of things should be like redundant in the Lotus miner software. There are teams that have forked Lotus and like built their own software, which is a lot more redundant in every place of the stack. So there are definitely like enterprises that just takes Lotus, leverages it, and makes it more redundant, basically. I'm not sure if that answered your questions or not, or.
It does indirectly, because if you are pointing to single points of hardware failure. You're pointing to systemic failures where you need to be able to reappropriate and repartition the infrastructure. Yeah, it doesn't. And thank you very much. You're not pointing to single points of hardware failure. You're pointing to software systems failures and the need to be able to repartition and reorganize your physical infrastructure to compensate for those things, or to be able to spin up more backup instances. And to me, that dovetails into something near and dear to me, that your infrastructure needs to be composable from a DevOps perspective, and what we can do on the storage backend and the systems backend to make that infrastructure composable, it sounds like a common goal.
Mm-hmm. Yeah, and I definitely agree. And that is also like things where we also have to keep the small users in mind, because like if you make it too composable, it might be really hard to spin up, while enterprises really want it really composable. So yeah.
Any other questions? All righty, well, let's give a round of applause to all of our panelists. Thank you so much.
rest of the day. Well, here we'll have somewhat deeper dives into technical matters. So pick your room. You're welcome to stay here. If you're interested in this other talk, now's the time to move out these doors and to the right. Sorry? Oh, that's her. Yeah, I did. Well, we'll get. Oh, that's fair. Okay, so the first talk we're going to be having here is a shallow dive into FIPS, which are Filecoin improvement proposals, followed by a series of technical deep dives. So those are the two that you're choosing between. Good job. All right. Last call. Anyone who wants to move to data onboarding focused room, out that way. If not, you're locked in here and have to listen about FIPS forever.
Forever. As people may know, I'm not Kubuhu. I'm not Kuba. Kuba has some personal things that, like, last minute he cannot join in here. We miss you, Kuba. Hope you feel better soon. But as someone who works on Filecoin and who works on Lotus regularly, I kind of know a thing or two about FIPS as well. So I'm gonna try to cover his talk a little bit. So how many? Oh, Deep, you're supposed to be there.
Yeah, I just have a question.
Okay.
You want somebody to MC or can I just keep it up? Great. Get a volunteer MC. Get a what? Get a volunteer MC.
Okay. Pop quiz. Who knows what FIP stands for? Okay, so many people know, so I'm gonna pick someone. So, DVD, you go. Cool, exactly. Filecoin improvement proposals, that's how we drive Filecoin evolutions and introducing new protocol changes and breakthrough into the Filecoin network. I didn't make these slides, so I'm gonna try to cover those, so bear with me. But yeah, Filecoin improvement proposals, that's how we actually introducing new protocol changes to the network via FIPS through network upgrades. As many of you already know, in Filecoin, we don't have any hard forks or whatsoever, or soft forks. All we do is network upgrades. So whenever there's a consensus change or new protocol, we have to perform a network upgrade to introducing the new Filecoin improvement proposals into the network. So I think Filecoin has now been 2 years old. It's time flies. There are over 48 FIPS that have ever been proposed. Majority of them were accepted. Some of them were postponed or rejected. But there were also over 130 discussions, and that's ever being fired as improvement ideas about Filecoin protocols. So if we take a time machine and travel back time, back into the 2 years, how everything started. So a couple of folks, Enos, David, even Rene, Luca, Nicholas, CX, they decided to create this FIP 0002, free thoughts on newly folded sectors of a missed window post. If you are SP and you love this FIP, please clap, Okay, but yeah, this was the first functional FIP that's ever on the Filecoin network. Actually gave people some grace, gave storage provider grace period on window post thoughts. And then we can never stops, followed by many other FIPs. We introduced Filecoin Plus principles, which is the same started for the Filecoin plus like data cap and giving people like 10x QAPs for onboarding useful data to the Filecoin network. We also changed some crypto econ things so that we can adjust the liquidity improvement for the storage provider miners. Again, providers are super important to the whole ecosystem, so we want to make sure they have a sustainable business in the network. We also removed I actually don't remember what this one is, but if you're curious about FIP 005, go look into the FIP repo. We sent there some like technical changes on the HAMT v3, how we store the data. Also, we introduced a batch sector pre-commit method, so you can pre-commit like a bunch of sectors in one message, which saves some of the miner costs. Another thing people would love, I would love to hear some like claps from Benjamin again. Yes, we exempt window posts from base fee burn in FIP 9 during like Christmas season. That's the time when base fee like arrives and people have to pay a lot for window posts. But it's so important for people to prove storage. So we exempt the window posts for a little bit while so people can prove their storage. Oh God, and this is the actual big one. So FIP 009 was actually a stopgap for the holiday season, so like people can keep their like operation maintained without like paying too much attention to it during the holiday. However, it was not a long-term solution, or it's not an ideal solution for the networking for the long run. So what we did is like following up with an optimistic window post FIP. So basically what we do there is like we do all the window post verification off-chain. So on-chain, we don't actually do any validation when the window post message like landed on-chain. We just assume the miners are honest. Are they though? Maybe. But if they're not honest and they do have like fake posts, we do have a dispute mechanism for people to challenge the posts that people has been posting. And if you got disputed with like fake proof or bad proof, storage provider are gonna pay. So you don't wanna do any bad things onto the network. So that's what that FIP is about. However, this FIP significantly reduced the cost of window posts for storage providers in the long term. How many of you folks knows about hyperdrive? Okay, what's hyperdrive? Okay, Benjamin, you go.
It's aggregating proofs.
Why is it good? Exactly. So as many of you may know, so when we ship like Filecoin network, we have never thought the network can actually grow this fast, this big in such a short time. So the chain was a little bit congested sometimes. People were having like bad time getting the message, a little bit getting message on chain. So that's the time where we were like, hey, Filecoin is a huge snarky network. Maybe we can, combine the snarks for like multiple sectors and aggregate those into one single messages. So that's when things were super cool happened. I think it's like FIP 9 and FIP 8 and FIP 13. We introduced proof commit sector aggregated and also pre-commit sector batch to reduce the on-chain congestions. So what you can do is basically you can onboarding a bunch of the sectors. I believe it's like up to 800 sectors, and then you can just send one single message to prove commit all those storage into the network. That's super cool. For this effort, the CryptoNet team, lab at PL, they created a very cool thing called Snark Pack, which is the first Snark aggregation ever in the Snarky world. So if you are curious about how the Snarky system works, there's a link in the FIP 13 as well. So go check it out over there. Yes. Unlike we did some data mass counting. If all the storage provider was still onboarding super fast as they were before, it was supposed to be on block 20x onboarding capacity of the Filecoin network, and then we while the network won't facing like any congestion and base fee increase. Snap deals. Who knows about who are doing snap deals these days? Okay, so I guess you know about snap deals. Okay, Nicholas, what's snap deals?
That's that.
CC sectors to deal sectors, but like most importantly, super fast. So before like the whole sealing process, as you may know, may take from like 4 to 6 hours based on your software and your hardware. And if you are onboarding even you have like capacity sectors on the Filecoin network, you are trying to put data inside of it. You still have to reseal, like perform the whole resealing process and like basically onboarding a new sector. It was not the most smart thing we could have ever did. So we are trying to make it better with snap deals. What snap deals does is like you have a CC sectors, you can directly put data into that sectors just as it is. Under 20 minutes. I think that data is from like Nicholas' machine. So like if you are facing like longer time, don't yell at me, like talk to Nicholas. He will help you try to figure things out. But yeah, so for client, that's a great news as well. That means like once you publish your storage deal, getting your data to a storage provider, you don't have to wait like 6 hours to see your data on chain. However, you only have to wait 20 minutes. Assuming Snap Deals works, it does work in Lotus on some level. No, but yeah, if you haven't tried Snap Deals out, I highly, as a storage provider, I highly recommend you to, because it's pretty easy. We do have great toolings in Lotus manner to help you onboarding Snap Deals into the network. I know it's on Filecoin's like roadmap maybe next year. Hint, hint. Don't call me on that. We may even have resnap, so updatable storage coming in 2023. So that means, you know, today if you put data into a sector and it's like if the deal is expired, you will have to onboard new data coming into the new sectors. Maybe sometime next year, you can just put the data into the existing sectors that has expired data, so you can better utilize your storage soon, guys. Yeah, this is pretty cool. We have only launched like Snap Deals for seven months, I think. I think that covers 7.8 like pip of data was snapped into the sectors. That was like 250,000 Snap Deals that's ever performed. So that's like pretty amazing. I didn't even know we have that many Snap Deals being onboarded. So again, if you haven't tried, please try. I think we have like tutorials on our YouTube channel as well. Okay. Anybody? Yes? Yes, it's in the sector info. There's a field to confirm whether it's a snap sector or not a snap sector. So yeah. FVM. I feel like everyone has been hearing about this a lot, but like starting last year in December, 2.5 people from the FVM team joined by like a huge from the Lotus team. We had basically like hacking on FVM to make sure it's like shippable into the Filecoin network. Like this year, I think we finally launched FVM M1 from the Scare upgrade in July. So in this upgrade, we basically set the good foundation of like having the Filecoin network to run FVM, and this was based runtime like virtual machine. We also like officially switched the whole actor from Ghostback actor to the built-in like the Rust actor, thanks to the Forest team. I don't know if we have the Forest team here, but they are the original contributor, creator of the Rust actor. But now all through implementation or all implementation in the Filecoin network is empowered by this built-in actor that's written in Rust. And last but not least, a Shark is coming. We have a Sharky upgrade that's coming up. Sorry. Yeah. Before we can fully unblock programmability by FVM, introducing FEM early next year, we do want to do some refactoring on the Filecoin protocol so that we can have use cases built on top of Filecoin with FVM. So we did some like protocol changes, actual refactors, things like that. So the first one is like FIP29. We are introducing beneficiary address for storage providers. And this is pretty cool because I know a lot of the storage providers are actually working with the lending providers to get like collateral to support their like miners. Most of the lending providers, they currently require to hold miner's owner key so that they not only they can fund the miner, but also they can do risk control when something like goes wrong with the miner itself. With beneficiary address, we hope there are lending solutions to support like people to develop like lending solutions that miners don't have to give up their owner key. However, they can still get like funds from different like providers. If we are building like any like lending market, I will like on the Filecoin network, I will recommend you to check this FIP out. And then we did a couple like security fix like in FIP34. And the star of this upgrade, we are the couple verified registry from markets so that we can enable different like user programmable storage market possibilities when FEM is landed. What's cool about this FIP is it's getting all the data cap stuff out of the market actor, however, living in its own data cap token contract. Yes, you heard me right. We now have a first like token contract in the Filecoin network. It's called data cap. So if you are someone has the data cap, you can find you as a token holder of our very first like token on the network. What this means to storage provider is, as many of you may know, if your deal is like this short while your sector is this big, your like 10x power is actually not spread for the whole sector lifetime, but they're actually distributed over the lifetime. So for example, if you have a deal that's like for 5 days, but your sector lifetime is for 10 days, you only get like 10x power for like half of the power. So like maybe if 5x the power for the whole sector lifetime. But with this FIP, as long as you have the valid, a valid verified deal in that sector, you can enjoy the whole 10x QAP for the whole lifetime of the sector. That's also great news for the client as well. So what you can do is you can actually claim, I want to extend the term of my data cap to this piece of data. And if the storage provider says, yes, I also want to store this data longer for you, you don't have to remake the deal. Storage provider can just extend the sector again, and then they will be storing the data again with 10x power incentivized by the network, and keep the data for you. And the client, you can expect the data to live on the Filecoin network as long as the deal lasts. So I don't know if we have mentioned, the Shark upgrade is coming in November, I believe, early December. We just upgraded the calibration net to Shark. So if you, no, okay. The calibration is going to be upgraded to Shark next Tuesday. Next month, Monday, Tuesday? Okay, Monday? Yeah. So if you want to help testing, please join in the calibration net discussing Filecoin Slack. If you find any bug, I bet Benjamin will. Do ping the Lotus team. We are here to work things out with you. There's a new thing that has been introduced this year. They're called FRCs, Filecoin Request of Comment. These are the things are like standards for the Filecoin network. So there's a lot of things that would be great for the network or the ecosystem to agree on. However, they are not necessarily like consensus bonding. That's why we have this platform, this forum to help like people develop like such standards. Why standards is like important? Let me give you an example. maybe let's say the APIs. Why you share like a common API standard like in the whole Filecoin network? Like among different implementation of like Lotus or like Forest, you as an application developer, you can actually have like 2 different nodes running. So if the Lotus node is done, you can just like easily switch to the Forest node and expect everything is still working because all the API interface, is still being enabled for you to talking to the chain. And that's why we want like standards. So there are 4 that's being opened up. The first one is by the Bedrock team, is the indexer protocol for Filecoin content discovery. And the next one is we are having a new storage dual market protocol built by the Boost team. We are having calling convention for hash messaging and also fungible token standard for data cap. Sorry. Excuse me. Sorry, I'm not in my best form, but yeah. So a sneak peek into the future of Filecoin. So again, this talk was supposed to be delivered by CryptoNet Lab, which is the research protocol development team at PL Andreas. So they do a lot of forward-thinking, bleeding-edge research on how to enable better opportunities for the Filecoin network. So what's next? Next, we have FEM, FEVM, that's launching into the network, a programmable storage market that you can build your own incentive or deal mechanism into the Filecoin network. We will have Halo 2, which you will hear from the Feel Crypto team to give you a deep dive on what Halo 2 is, what does it mean for the Filecoin network soon later. And Snap, upgradable Snap deals, as I mentioned earlier. And also we are introducing a pull-rep bug policy, proof expiration, and longer deals. So as you may know, right now the sector maximum lifetime on Filecoin is 5 years. That's because we want to make sure all the proof is secured on the Filecoin network. But as the hardware getting improved, or the decryption, encryption word that people get creative, there's no guarantee the pull rep we have today can be forever secured. That's why we have a 5-year max lifetime onto the sectors these days. However, with this new bug policy, it does allow sector max lifetime to go beyond 5 years, even forever, and it gives us when the sector lifetime is longer, clients can make longer deals, and maybe we can even have permanent storage onto the Filecoin network if people want that. So that's pretty cool. That's FIP47, by the way. So if anyone wants to check that out, go take a look. I think I covered all the slides. I hope that makes sense. Any questions on FIPS or introducing protocol changes to the Filecoin network? No? Easy peasy, everything? Okay. Yes.
These topics are all very heavy, and they're very context dependent, and they spawn really big discussions. How do we go about ensuring that all the right stakeholders are involved in each of the FIP discussions? Because that seems like a pretty big problem.
That's a very good question. So it's still an ongoing discussion on how we should deal with FIPS. What's a healthy life cycle of introducing FIPS to the Filecoin network? So how things goes today. So first you can check out the GitHub repo in Filecoin Slack. It's called the FIPS channel. If you go to the discussion, there's a whole life cycle being written up. But normally things start with idea generation, right? So you basically create a FIP discussion to bring up the idea with the community to introduce what can be better on Filecoin, and circle all the community members and the core devs, core developer teams to help you to form the idea to make sure it's on the right path for the Filecoin. And then during the discussion, you will slowly form up your actual FIP proposal. So that's the time you create a FIP draft and opening a PR in the FIPS repo, opening a draft, and that once the FIP draft is open, the FIP is gonna go into our governance process run by Filecoin Foundation core dev governance team. So what they would do is like first to make sure we solicit the FIP draft among the community, and also we ask the FIP authors of the FIP to present the FIP in the core dev call or like in any recorded form, basically to go like a deep dive on like why we are doing this. Is this the right like a solution? Like having a couple like iteration of like how the FIP should be looking like, and then slowly we try to finalize the FIP to a stage that like people are like, okay, this is in the right direction, and now it's in the hand of the core devs. Core devs is a pretty distributed governance development community that has people from like all the implementation teams like Lotus, Forest, Venus. We have research team. We also have Bedrock's teams. A lot of team of Crypto Econ Lab, like all those teams, and we will have a discussions on like whether we should put this into the Filecoin roadmap and making sure like it doesn't kill the network. You know, it actually makes the Filecoin network better. It doesn't kill the network. If it's a controversial FIP, for example, as you may know, FIP36, which is a crypto econ change that was like proposed, and a lot of storage provider has raised their concerns about that change into the Filecoin network. Then we will have a longer governance like process, and eventually, if we have to, we will do a field pool to gather the sentiment from the community on whether that's a good idea, whether a FIP is a good idea or not to introduce into the Filecoin network. Most of the time, because like, you know, Filecoin is still like super young, not a lot of the things are like controversial, so not like FIP36. So most of the time, core dev will just be like, yeah, this is a good idea. Then we schedule things into the network. We make sure all the parties review the FIP and audit the implementation to make sure it's going to be secure to land in the Filecoin network, and that's pretty much it. So like FIP goes through a process of FIP draft, then the last call. Last call is a 2-week process. Everyone in the community can say, hey, this seems wrong. You gotta fix this, FIP authors, before we land this into the Filecoin network. And then we finish through the last call, assuming the community are okay with the FIP. We move FIP to the accepted status, and now when the FIP is in the accepted status, now the FIP is in core dev's hands, core implementation's hands, to actually implementing that into the protocol and into the client implementation. And once it's finalized, meaning it's introduced by a Filecoin network upgrade, then that's when a FIP is like finalized. I hope that answers your question.
So 36 went to a poll. What's the trigger for it to go to a poll? Was that just oh, this is controversial, we better actually ask?
Actually not. So like I wish like Caitlin, the governance TPM is here. She will always say, we never want to do like, we don't want to have like a field pool for all the FIPs that's ever going to be introduced into the Filecoin network. That's only going to slowing down the network, and also like we as a community, we should easily be on soft consensus on like what's good or bad for the network. FIP36 is because a couple things. So first is like different like community members have different perspective on how crypto econ changes will impact their business. Token holders or like storage providers or like, you know, clients will all have like different ideas. At that time, it's really hard to signal how everyone feels about, you know, how things will impact them. And for the core devs, we focus on the code. We don't run a business on Filecoin network, right? So we were seeking for signals from the community members on like, you know, how this is gonna impact them. That's why we launched a pool. But yeah.
I would like to quickly add to that, because this is a really interesting question. Thankfully, this is a problem for the Filecoin Foundation to solve, and not a problem for Lotus to solve for the most part. But I don't, honestly, going back to your original question of like, how do you make sure all of the relevant stakeholders have weighed in? I don't think we have a good answer to that yet, because there's kind of two obvious models, and we've kind of tried both. One model is you identify the relevant stakeholders, and that's a easier thing to do, and you require them, or you ask them to kind of be paying attention to every FIP that's being discussed, proposed, written. Now, that's a reasonable thing to do. This doesn't work well because we do have a lot of FIPs, as Jennifer covered, and not every FIP is of interest to every stakeholder. As an example, I opened a FIP a couple months ago that added a new method to the account actor that basically just redoes signature validation. The Boost team, as an example, probably does not care about that at all. It's validating a signature. So requiring everyone to be paying attention all the time doesn't work. The alternative model is obviously you try and, for every single FIP, you try and identify the stakeholders that will be impacted, and then you go and get their special attention. This is kind of what we're doing more of today. The reason this doesn't work is because it is a notoriously hard job to identify who those stakeholders should be, especially for one person or one team, Caitlin Beagle and the Foundation, to try and do so for the broad range of FIPs that are written. Historically, we've gotten this wrong. We've opened FIPs that we thought were, let's say, purely technical matters, and did not realize that there was a crypto economic concern until we were much too late in the game and then had to intervene at the last minute. So I think this is a work in progress. Yeah, I definitely don't think we have the right solution yet. But the Phil Phipps channel, Slack channel, is a place where this conversation is ongoing. And Caitlin, I can briefly speak for her, is very, very interested in trying to solve this problem and solve this problem well. So opinions and feedback is very welcome. And hopefully we keep getting better at it.
There's an active governance discussion in the FIPS repository as well. So we do want more people joining the governance process of the Filecoin network. So if you're interested in that, please go check it out. Any other questions on FIPS? Okay, no. Cool. Okay, I'm gonna be super loud. How many people has been waiting for this forever? Updated Lotus Miner workshop. Okay. Yeah. Okay, joining us now is gonna be our one and only Magic, D Magic, who is gonna be one of the Lotus Miner with you all for the next hours. And there are gonna be 40 minutes. Okay, there are gonna be sneak peeks on what the next stage for the Lotus Miner. So that's definitely the content you wanna be here if you are running. Oh God. Okay, cool. If you're running Lotus Miners, that's what a mess is like in the Lotus Miner.
Welcome to Lotus. That should be right there.
Hello. So yeah, that's me. That's the cake. It's usually not orange, but don't worry about it. It works most of the time, like this. So yeah. I will talk about the Lotus Miner, or the Lotus Storage Provider software stack, or whatever you want to call it. It's hard to tell what it is. It's a lot of things. Okay, so yeah, it's a lot of things. I will talk about what it means to be an SP, how you become one, what power is, how to maintain power, how to get power, how to run at scale, and then I will have a brief Q&A, and after that I will talk about the future plans. Maybe we'll probably have some time. There'll be that small Q&A in the middle for 2 or 3 questions, and then hopefully have time for more Q&A after the future plans. It may be dense, so bear with me. Okay, so what does it mean to be a storage provider? It generally means that you want to provide storage to Filecoin. It's what it says on the box. But in more practical terms, it means that you get data and you store it. And the reason you do that is you want to earn Filecoin. What? Okay, it's fine. You want to earn Filecoin. You spend a lot of time in spreadsheets. Maybe you have a horrible data hoarding problem, or all of the above. And you know, yeah, why? Like, how do you earn Filecoin? You win blocks. How do you win blocks? You participate in this lottery that happens every 30 seconds. And the lottery works by just drawing a random number and multiplying the total power by it, and then getting another random number derived from the first number and multiplying it by your power, and then doing some more math, and you either get a true or false. If you get a true, you won, and you can mine a block. You can attempt to mine a block. So you are then challenged by the network to also prove that you are storing one random bit of your storage. It basically checks that the amount of power you have is actually real and you cannot fake it. But yeah, let's say you've proven to the network that you want a block and you create a block. Now you have to send it to the network. So you do that. The network may or may not accept your block. It probably will if you have fast enough internet and if you've proven the thing on time. So great. You send the block. The network accepted it. Now you get a reward. So you have fill. Great. That's what you do as an SP. So yeah, mining is great. It's very simple, but it depends on this power thing. So what is power? Filecoin is a storage network. So it's kind of logical that the power is based on how much you store. And so we've chosen 1 byte as a unit of storage. So if you store 1 byte, you have 1 power. But Filecoin is a network for real data. And so we then decided that, well, if you store something that's considered real data, you get more power. And we also decided that, okay, if the data is real, we get 10 times more power. So we have a very good incentive to store real data. So, okay, you've, know what power is. Power comes from proving storage to the network. And the way you prove storage to the network is by sealing, and more precisely by sealing sectors. And what are sectors and why do we need them? Yeah, sector is just the minimum. It's the smallest amount of storage we can prove at a time. It could be larger, but we cannot really make it much smaller. It makes some assumptions very complicated. So actually having sectors be 32 gigs or 64 gigs, just the right balance between how much memory you need to seal stuff and how much it costs to seal stuff. It comes from how the SDR-based POREP works. There are maybe other mechanisms, but so far we think this one is the cheapest, I believe. I think. And this one is also the one that we know that is secure. We know of cheaper constructions that are broken. We actually know of many. And so, yeah, we have this one for now. Maybe there will come a better POREP. Maybe, hopefully, we'll see. So, yeah, getting power from seeing sector is great, but getting power from seeing sectors with real data is better. So how do you get fill plus data? You go to the other room, they know better. But the simple ways for especially the smaller, medium storage providers is to go to onboarding platforms and other clients like Estuary, Web3 Storage, Evergreen. The large data set working group stuff also probably can help you a lot. They have infinite data. And so, yeah, you basically go to clients and go get data. Simple in theory. And so, yeah, you've got data, and now you need to seal it. How do you do that? So the first thing you do is you need to create a sector. And to get a sector, you just need to find either like 32 or 64 gigs of data. I will use 32 gigabytes for like in place of sector size, but it's like one of those you can choose. But yeah, you get like 32 gigabytes of data. You put this into one block of bytes, and deals come with pieces of data attached to them. So like each deal refers to a piece of data. You get a bunch of pieces, you get a sector. Then you do the first step of the seeing process. That's pre-commit 1, at least that's what we call it. And really what you do in pre-commit 1 is first you compute some Merkle tree hash of your unsealed data. And then in the second step, you perform this very weird sequential process where you build 11 layers of some very specific Merkle tree that you can only do sequentially, and it's called SDR, which stands for stacked DRG, which DRG stands for depth robust graph. And it's basically a type of graph where you need to store some amount of parent nodes to like create the later nodes. Otherwise, it's very, very, very expensive to compute. And we create 11 layers of this graph. It still doesn't encode your data. It's just like an encryption key. And then in the next step, that's commit 2, we go and encode your unsealed data into the, prepared encryption key that we created in pre-commit 1. And we built some Merkle trees on top of that. That's highly parallel, so it can happen on GPUs. So you definitely want the GPU for pre-commit 2. And for pre-commit 1, you only really need a whole bunch of memory. Then you send a message to the chain, and you wait. The message you send contains the sealed CID and the unsealed CID, or comd and comar, or commitment to the data and commitment to the replica. There's probably 5 different names for that same exact thing. But yeah, so we send the message. The message is the pre-commit message. And this message tells the network that, hey, I claim that I will be able to prove that I am storing this, that I've created this replica for this data in this amount of time. And the reason for having the pre-commit message is kind of technical. And in theory, we could just have a one single commit step. But if we do this in this 2-step process with waiting, this gives us some better security, and it makes the proving process, so it makes the commit snark much lighter and much cheaper to compute. And at the time we were developing Filecoin, that also meant it makes it physically possible. So yeah, we do this 2-step process. We send a pre-commit. Then after some time passes, and we finally have arrive at the epoch at which the network gives us a random challenge which decides which parts of that sealed data we have to prove to the network. So we get the randomness from drand. It's just the unbiasable random beacon Filecoin uses. And then we feed it into the step that's called commit1. That step just reads a bunch of sealed data and all the associated miracle proofs. In total, it's give or take 8 megabytes of proofs. And yeah, so we got 8 megabytes of proofs. We need to send them to the blockchain. That's not good. It's a lot of data. So we compute a snark. And through this, like snarks just let us prove some claims are true. And in this case, our claim is that we can prove that we have created a copy of data that's unique. And this is the same thing that 8 megabytes of miracle proofs prove. But the thing that comes out of a snark is 2 kilobytes. So it is literally 4,000 times less data for proving the same exact thing. And yeah, then we send that proof to the chain, and the chain believes us if the snark verifies. So great. We have proven that we have created a new copy of data to a blockchain network. And so, yeah, that's great. There is another way to get power, and that is snap deals. So through seeding sectors, we can either create empty sectors or sectors with deals. If we create sectors with deals, they can contain fill plus data that gives us the 10x power for that data. But we have this other thing called snap deals, which lets us do a similar thing, but it's mostly for just upgrading, like putting new data into existing, for now, empty sectors. And this is very cool for many reasons, mostly because it's fast. But like if we sealed some C sectors way before, we may want to reuse this storage to like gain more power. And if we get some fill plus deals, we can put them into our existing sectors, get more power. And like we can also just use it to onboard data faster, or to smooth our work, to smooth our workload on the seeding hardware. So we can just seal at some constant rate, just create C sectors. But then if we get bursty client demand, we can use snap deals to have more onboarding bandwidth. And yeah, there are many other valid reasons to use snap deals. Some clients care about latency. That really, really helps, because the snap deals process more or less 20 minutes. So yeah, how does it work? You get data, you get an existing CC sector. You do a replica update, which is basically what we do in pre-commit 2. And you basically, you encode the unsealed data into an existing sealed sector, just in a slightly smarter way, which makes it impossible to know what bytes are going to come out in the sealed sector. It's a very tricky, very fun math. Then we do a similar thing that we do in commit 1, just with slightly lighter proofs, because we don't need to prove that we have sealed, that we've created a copy of data. Like we already have a copy of data, we just encoded real data into the existing copy, so this is much lighter. But we still snark the result. It's a fairly light snark. It's not that light. It's comparable to the PowerUp snark. Really, most of the weight of the PowerUp snark and the SnapDeal snark lies in having to prove many SHA-256 like trees, and those are very, very not friendly to snarks. But yeah, we've done that, and that's how SnapDeals works. Next, so yeah, we have some power. We have to also maintain it. And the way you maintain power is you just answer to network challenges. And those come in through window post. And window post is fun and also annoying. Yeah, we get many other ideas throughout the development process of Filecoin how to prove storage. Window posts seem to be good, and it is still very, very good. It's way better than any other solution. So to give you some idea, one way that Filecoin used to work in pre-testnet days is that on every single epoch, you had to run the same computation as for winning post on a bunch of random sectors. That was called election post. And like to have any chance of winning blocks, you have to run post on every single epoch, even if you didn't win, because that's how you check that you won. And so yeah, that wasn't so good. So now we have something better. We have two posts. One of them is window post. Essentially, every sector that's onboarded on the network gets checked daily. And the checks happen in so-called deadlines. So when you create your miner actor, you get assigned a random time of day at which your first deadline starts. And then you get 48 deadlines. So in a day. It's like just windows in which sectors are grouped to be proven every day. And yeah, so when time comes for a deadline with some sectors, you have to go read some random number that's generated by the network. I think it comes from Durant. Then use that random number to generate some challenges for what data you need to prove. You read that data, you snark the data, and you join a window post, and you send it to the network. There is many things that can fail in this process. So yeah, the Lotus miner takes care of most of those things. But yeah, like things that can fail is, your chain may be out of sync, your connection to the daemon may be dead, your storage may be dead or slow, or both. And yeah, then you may be out of funds to send your post, or your post may fail randomly because gas numbers changed, or your message may be slow to get on chain, like so and so on. It's surprisingly hard, and there are so many ways this can break. But yeah, that's window post. Let's say you manage to send it every day. And so yeah, that's basically the part where it's like how and what you do as an SP. It's just like onboard storage and prove it and mine blocks. Very simple. There's nothing more to it really, technically. So yeah, how do you run Lotus? If you are a developer, you buy a very beefy computer, or a medium beefy computer, and you just start a Lotus daemon, start a Lotus miner. If you run it for a longer time, you probably also start a Lotus worker. You may or may not start another process for the market, like a boost node. But yeah, like overall, it's a really, really simple setup. It's just one computer. Probably run it in like Tmax. But yeah, like it's just like the tiniest setup we support today. Not really interesting to most SPs because you can't possibly mine on this today. So a more realistic setup, you start getting a pile of computers. And yeah, you run a Lotus daemon, a Lotus miner, and boost. Those processes may be on different computers. They may be on one computer initially. For reasonably small scales, you can probably get away with just a single computer for all the large processes. And then you get a bunch of workers. You get workers like for pre-commit 1 and 2. Those can be on different machines. Those can be a single machine. You get another set of workers for commit 2. You can execute them on the same machines if you have GPUs balanced out. It's a very fun game to play in Excel in spreadsheets. There's quite a lot to balancing and having efficient hardware setups. The thing that's on the slide is horribly inoptimal. You do not want to run this setup. And then the other part is you need some storage. If you're a small SP, you can probably get away with putting hard drives into the same servers that seal your storage initially, but you will very quickly find out that you need more drive base. So you'll start, getting real storage servers, and you'll need to configure some real scalable storage. Many people get away with just, initializing a giant RAID and using any file system that works per server and using NFS to connect to Lotus. And it kind of works quite a long time, actually surprisingly long time. But at some point you will notice that NFS is a horrible, horrible solution. And there are far better network file systems. You will probably want to use something like Gluster or something like Ceph or something custom. Or you can also just have still independent servers, but run storage workers on them. And storage workers are just sealing workers which are not doing any sealing work. They just accept sectors and respond to changes. It works quite a long time. You can scale a decent amount. So how is a small SP different from a big SP? You have more computers, way more computers. You have rows of computers. And the first thing you do as a medium-large SP is you want to make posts work all of the time instead of most of the time. So you get post workers. Post workers are just dedicated processes with their own GPUs, so the GPUs are always available. And the second thing you do is get more storage, more serious storage. And it's just more computers. To be fair, Lotus wasn't designed to be super large scale. You might have noticed that in Wise talk, we were mostly about going fast and doing simple things. And it kind of shows. So in the second part, I will go more into how we want to address things. But this is probably the most complex setup that Lotus supports today. Today, if you connect more than, 100, 200 computers to a single Lotus node, it will be very unhappy. That's the plans for the future. Any questions so far?
So just to be clear on the window post requirements, is it possible that a large storage provider is doing window post every window of the day? Or is it per? Okay.
Yeah, so I believe that you can fit something like 72 terabytes worth of sectors if you're on 32 gig sectors. You put 32 gigabytes of sectors in a single partition, which then if you have more than one partition, you go to the next deadline, next deadline, next deadline. And this is something like 2.5 petabytes to have all deadlines full of at least a single partition. And what happens if you cross that? You just like add more partitions to deadlines. So you have to compute multiple window posts per partition. And this is where you actually, when you need post workers, because you need to compute multiple window posts in parallel. And I realized that Lotus doesn't do that today, I think, but it is something that we need to fix. And it's not hard. So yeah, if you are a really big storage provider, you just compute multiple window posts.
Thanks.
Okay, well, if there are no other questions. So yeah, plans for the future. This is very simple, I promise. Yeah, we know that there are many limitations, and they are actually not caused by all that many reasons. It's actually a few very simple limitations for making Lotus scale really big. At least we think so. If you think we are wrong, please tell us before we do this work. So yeah, the first problem is that Lotus daemon isn't perfectly reliable. And usually, often what happens is your chain node that your Lotus miner is connected to will die, or you need to take it offline for maintenance. It can happen that there's a network upgrade and you need to take your Lotus node offline, and then you may miss winning blocks, you may miss your window post. It can mess with your seeding pipeline and so on. So the first thing we want to do is to basically just add a way to connect your Lotus node, your Boost node, all the nodes that we need to talk to a chain node, to just connect it to multiple chain nodes. And this sounds simple in principle, but there are some problems. So we sign messages on chain nodes, so you need to coordinate nonces. You want to be really careful with mining blocks to not get slashed if you mine blocks with two different block mining processes and send them to the network. And also, if one node gets out of sync, you probably don't want to use it. You want to use different nodes in the cluster. So it's, on paper, very simple. Just connect to a bunch of nodes, but you actually need to coordinate them a little. And yeah, this work is actually happening. It's in a PR by Shrenuch. And it's probably weeks away from landing. We keep discovering new and new reasons why it's more complex than we thought. But yeah, overall, this is probably a problem that will be solved in this year, hopefully. It'll be really annoying if it is a thing for longer. So yeah, we want this. That will be so nice. Yeah, next. Boost scalability. That is something that the Boost team is very more qualified to talk about, but essentially we want more boosts. More boosts better. We want to be able to connect multiple Boost nodes to a single Lotus miner node, and we probably also want any Boost process to be able to talk to multiple Lotus miner nodes. So it's this many-to-many thing going on there. And it really just allows the Boost process to not be bottlenecked by any single computer not being able to push bytes fast enough. So yeah, that is easy. So when we built Lotus Miner, we decided that we want to keep sectors in storage paths, and we'll just index them in the central process in some in-memory maps. That's fine. It's not fine anymore. So since then, things happened. So there are snap deals. Snap deals break a lot of assumptions if you just assume that your sector data never changes. And then you implement changing data in sectors, things will break. That is one of the major causes with the issues with snap deals. Another limitation this introduces is you cannot use the same Lotus storage paths for sectors of different miners. And this is a very annoying limitation. It's less annoying if you use enterprise file system like Gluster or something that just create a pool per miner. It's slightly better, but still, we would like to not have this limitation, and we'd like to be able to just connect different, use the same storage for different on-chain actors. Maybe not even actors that we own, that I will go into later. So yeah, we want to pull the storage index out of the Lotus miner process, and we'll probably use some established database that is that everyone knows how to run reliably. We don't want to reinvent the wheel. We did a lot of that, and maybe we can do something simpler. So yeah, we'll probably use something like Redis, TBD, some database to store metadata about where sectors live and this kind of thing. So yeah, that is part one of how to make Lotus scale. The real big problem that exists today is how tasks, the seeding tasks are scheduled. It's not good. So in the initial early days, we needed to move fast. So we just wrote a scheduler, and then we make it less bad progressively over months and years. So now we have a scheduler that's mostly not bad, and it's still not good. And there are many ways to make it better. And the best way is probably to get rid of it and just replace it with something sane and simple. So we probably want to move to a simpler model where really the scheduling decisions are made on workers. And the Lotus miner process really just sends messages to the pool of workers that is hey, I want to seal this sector with this data. Or I want to do pre-commit 1 or pre-commit 2 on this data. It's just much simpler. This also allows you to put boost processes and talk directly to workers to do the remote compete. Or even better, it lets you participate in seeding marketplaces where you can have a seeding marketplace plug in directly to this centralized message queue that goes to workers and be hey, if you have time, also seal this sector. And yeah, it seems like a much simpler architecture. It seems like workers can do much better job of deciding if they are ready to take more work than the centralized scheduler, which is some wild model of the worker resources. This is very TBD. I don't know if we go this way or a different way. Definitely talk to us if you have different ideas, or if you agree that it's good. Please also try to tell us. Yeah, this is we're trying to figure out how to make Lotus a lot better. We don't know when this will be happening, but yeah, sure. Yeah, we can talk about it. Yeah, other interesting things that are going on in the ecosystem is seeding as a service is a cool idea. You can just pay someone to seal stuff for you. And we spent a bunch of time this year, a few months ago, with some people who are very interested in building this stuff. And we've actually shipped a set of new APIs in Lotus that already make it possible to import sealed sectors or even partially sealed sectors. And Lotus will continue the seeing pipeline from there. It can also call back to the seeing service for doing some other work like reading commit 1 challenges or reading or like doing commit 2 for them if it's like that's full seeing service. It's possible to pay someone to seal sectors for you without giving them your keys, which is very convenient because they cannot steal your money. And yeah, so that's happening. It's probably a bigger deal than it seems initially because it makes it possible to become an SP without investing into seeing hardware at all. It's very, very cool. And another, like the next logical step from that is full sealing marketplaces. You can trade your like spare compute. If you have a lot of storage, you can like buy compute from some other SP, and like vice versa. If you have, a lot of compute but not all that much storage, you can pay someone to compute stuff for you. We'll see when that happens. It's happening. We'll probably see first seeing services in weeks. Yeah, probably talk to Daniel if you want to hear more. Seeing marketplaces, I'm not exactly up to date on, but yeah, this is the stuff that's happening. Wow, that was quick. I want to hear questions.
If you could have done one thing differently before launch, what would it have been?
I would like to know that the scheduler would be such a pain.
Right, so I think that we have had some talks going forth and back on how much needs to be inside Lotus. So this is more like a comment and probably also something for you to respond on, but I heard earlier on that Stefan was also talking about having other storage backends. And I just wanted to know what is the kind of the Lotus dev angle on this, because obviously we don't want everything going into Lotus, but then on the other side, we are competing with cloud providers that has these kind of benefits, and I do see it like Lotus is basically the one that is that wants to audit the data because of the Filecoin spec. Yeah. But we need to audit data, and that is not a usual case. So are we looking to actually integrating better support for that in Lotus, or is it still like that is the SP's own problem, how to create storage that works with that?
Yeah, so we want to stay flexible. You might have noticed that like the simple dev setup is one computer with barely any storage, and we need that to still work. So there is a very large degree of flexibility that we need. But what you're saying is very valid. So we will maybe look into this. We probably want to rewrite a lot of the worker, like the current worker code. It may be in Rust to just have way better access to the proving APIs. And if we do that, then it's very, very easy to abstract the storage layer and make it possible for SPs to use literally whatever they want. Like, it would be very nice to have direct object storage access, like from the workers. And if that's the case, then it's you can do whatever you want as an SP without having to go through the pain of storage paths, mounts, things. Yeah, that is something that's on the table.
Yeah, I just want to add on to that. It's like as we are thinking about next steps for Lotus Miner or Field Miner for support large large-scale enterprise storage provider. If you're a client solution provider that have like storage expertise and knows how to help us to make things better for our storage provider community, I'm looking for help. Our team is looking for help. So if you have ideas, reach out to me. Again, Jenny Juju on Filecoin Slack. You can find all of us in the Lotus dev chat. We're looking forward to collaborate with different solution providers in the ecosystem to make the next generation of Lotus miner. We cannot just do it all by ourselves, so.
Maybe more of an observation, but also a question. It looks like we're moving towards a more like microservice type architecture where there could be specialization for sealing, for example. Is there like an explicit, and I think Ayush, you kind of alluded to like, hey, we want Boost to do storage or other people to make better implementations. Is there a path where we see specific areas we want to create those APIs to make it easy to specialize for these services? Or is it more as we see these problems, we'll break it up at that point?
Yeah, I think what is likely to happen, what is likely to happen is the services that are heavy, that are like kind of logical to scale, will be broken into their own processes. So like, workers for the sealing part are a very obvious, box to make scalable. Another thing that's logical to make scalable is like post workers, or the chain nodes. You don't really care all that much about scaling. Maybe if you are some like data platform, but chain nodes are kind of an easier case. But you can also scale them if you really want to, and you mostly do that for redundancy. Other things, the like sector metadata process, that you can run reliably, even if it's not redundant. You can also shard it fairly easily on sector numbers, but it doesn't really make all that much sense to scale. And then you have like the market sides of Boost. Boost makes a ton of sense to scale, and in two different ways, as was mentioned. It's like you can scale for retrieval and you can scale for storage. And those processes talk directly to the workers. At least they send data directly to the workers. So there's like not much else to scale in there. Like I hope that we capture all of the bits that need scaling. There are always new surprises. If you design for some scale and then someone makes use of your software at 100 times the scale, you'll be surprised at what things can break.
So I will quickly go into what the Filecoin crypto team is, because I mean, we've talked about the Lotus team and we've seen the forks, but there's also the Filecoin crypto team, which works kind of on the lowest level of the proofs. And so currently we are 5 people, and we have also like I'm here, I'm Volker, but there's also Sean, which will later present the roadmap. And then we have also Jake, Nemo, and Ardem. So Ardem will do the actual deep dive. He sadly can't be here because not everyone is as free to travel as we are. So it will be a pre-recorded talk, but he will watch it on YouTube. So afterwards there will be a Q&A, and he will also be able to answer the questions. And so what the team is actually doing is we are implementing the cryptographic core functionality. And related to this, there's many things. So of course, maintaining things, but also keeping things secure. So if there's any vulnerabilities in cryptographic protocols, we fix them. Or this is specifically what I'm working on GPU acceleration, because else it would take way much longer to do the proofs. And things that we've also talked about or heard about, things like new proofs, like snap deals that just shipped this year. We were responsible for the implementation. And currently, with the current proving system that we will hear about, there's a thing called trusted setups, where the short version is you have a long running process that many parties are involved, and it runs over weeks and weeks, and then you need hours and hours of verification, and we make this a smooth process, and yeah, it takes a lot of time. All right, but now I will get into the talk.
Hello everyone. I'm really excited to give a talk on this event representing my Filecrypto team. Despite it's covering quite technical aspects of Filecoin's proof stack, I try to make it easy to understand for a wide range of folks in PL ecosystem, including people who are not engineers. Nonetheless, I think it can be useful for both engineers, potential future newcomers to our team, and to those who joined Protocol Labs recently, and also engineers who may develop external products on top of the protocol. The main idea for this report is composing knowledge base and making overview of proofs stack utilization in Filecoin protocol from a crypto engineering point of view. I'll tell you about replication proofs, proofs of spacetimes, how they are used in Filecoin, and try to answer the question, why are they used in this way? Okay, so I will briefly recap about Filecoin basics in order to create a context, and then I will switch straight to the proof stack. So Filecoin, being a globally distributed storage provider, is a network of individual storage providers of miners and public validators or clients. Similar to regular centralized storage providers, Filecoin supports basic data operations like creating the data, updating, retrieving it. Every individual entity in the network does not trust to other entities. That's why Filecoin has to provide specific cryptographic enforcements that mentioned operations with the data were performed correctly. This is being implemented with the help of cryptographic primitives called proving systems. Proving system operates with abstract prover and verifier, where prover attempts to convince verifier in correctness of some well-defined statement. Prover is always an individual storage provider that attempts to convince rest of the network, clients and other storage provider who are verifiers in this case, that data operations are being performed correctly. Considering this, at this stage, Filecoin uses 3 mechanisms: proof of replication, POREP, which is used to enforce valid creation or registering the data in the network. Upgrade mechanism is used for the data modification. And finally, so-called window post proof, which is used to enforce that during particular time data is available for retrieving. Filecoin can be considered also as a blockchain, so we can also distinguish block miners among Filecoin storage providers and chain validators among Filecoin clients. In order to support correct blockchain operations, there are two additional proving mechanisms, winning post proofs and election proofs. They are quite supportive in a sense that they do not explicitly involved into data operations like creating or updating the data. However, they are quite important for security against fundamental blockchain threats like grinding, as Filecoin uses proof of storage stake consensus, and cyber attacks. Okay, if we take a look at our Filecoin white paper, we will see that the idea of proving the fact of storing some data is not actually new. There are some well-known approaches that allow user to check whether its storage provider is still storing outsourced data in a very efficient way, much more efficiently than downloading the data. PDP, which stands as provable data possession, and POR, proof of retrievability schemes that implement mentioned approaches, considered centralized storage providers, while Filecoin requires some additional guarantees due to its decentralized nature. That is why proof of replication plus proof of spacetime bundle inherits challenge-response nature of PDP POR schemes, but also provides additional security against following fundamental attacks. It's a Sybil attack, where malicious storage provider may create multiply fake identities and tries to get more reward for the physically non-existent copies of the originally stored data. Outsourcing attacks, where malicious miner tries to collect reward for the stored data which is actually delegated to other storage providers and relying on fast fetching the data. And the generation attack, where malicious miner claims to store a large amount of data without possessing enough storage, and instead of actually storing the data, it generates it by demand using smaller program. So in the rest of the talk, I will try to explain how combination of proof of replication and proof of spacetime help in provision security against mentioned attacks and allows satisfying mentioned requirements. Okay, now we are starting from POREP, proof of replication. It is always performed by storage provider when new data is registered in the network. In Filecoin, data is stored in a form of 32 or 64 gigabyte sectors, and initially, life cycle of the data in the network starts from zeroed sectors. We call them committed capacity sectors. They appear when storage provider allocates or commits its empty storage to the network, and eventually sectors are being upgraded and the user's data from deals is being written to the committed empty sectors. Sealing the sector starts from representing its data as a Merkle tree. Here on a slide for simplicity I used one base binary tree with 15 leaves, but in practice for 32 gigabyte sectors it is millions of leaves where each leaf is 32 bytes. Also for optimization purposes we use more complicated trees like octrees where parent node is constructed via hashing 8 child nodes instead of 2 as in binary trees, and even compound trees constructed from subtrees. Once we've done with Merkle tree construction over sectors data, we can convince verifier that we indeed have sectors data in the storage by sending inclusion proofs of particular leaves. The pointers to random leaves are called challenges, and those challenges are selected by verifier. So later, after registration the sector in the network and after obtaining Merkle proofs for a challenged leaves from the storage provider, verifier can very efficiently, much more efficiently than comparing data bit by bit, check whether particular data parts are indeed stored by storage provider. Every sector is completely unique piece of the data within overall Filecoin's distributed storage. It has complex identifier called replica ID computed from set of separate identifiers. comd is a root of the Merkle tree that is built on top of raw sectors data. Obviously, it is impossible to modify the sector's data without modifying its commitment, and since it is included into replica ID computation, which is used as an input parameter for proof computation, we will see it a bit later. Publishing this commitment in the blockchain guarantees immutability of the sector's data until a legitimate upgrade will be performed. Sector ID is a unique identifier of this sector. Prover ID is an identifier of particular storage provider which stores this sector. Ticket parameter provides a link to particular block in the chain, and finally seed is used as a randomness for the challenges deriving. Some more specific info about ticket generation and verification is provided via link below. So ultimately, as you might notice already, one of the main tasks of PowerApp proof is guaranteeing that particular storage provider has saved the particular sector in its storage and committed to store it from now within some period of time, which is one of high-level design requirements. Another design requirement to the proof of replication is provision security against generation attack, where malicious miner tries to work in the mode of performing infinite sealing the sector one by one, generated via a small program like pseudo-random generator, and registering them in the network, trying to exploit consensus and increase the likelihood of winning a block reward. To prevent this, PowerApp is designed to be computationally slow sequential process that cannot be easily parallelized. As far as I know, the ideas for the PowerApp construction that fits mentioned requirement were taken from following papers that describe how to use directed acyclic graphs in order to achieve memory hard function suitable for proving space and replication, which is actually our case in Filecoin. The core property of such graph is that it can deterministically generate arbitrary number of derivative nodes from some initial node, which is A in this example, and it will never form a closed loop, unlike cycled graphs, so that any child node will never point to the parent one. PowerApp uses such graph in its internal encoding process, which has configurable complexity. The idea behind encoding process is following. Original sector's data is divided to nodes, which is N0, N15, marked red, and with the help of directed acyclic graph, each node is mapped to so-called encoding labels, label 0, label 15, marked blue. For each given node, treated as a child node, a set of parent nodes can be deterministically derived using a cryptographically strong Feistel-based permutation that lies in a basis of particular directed acyclic graph in Filecoin protocol. So this produces us first encoding layer. Then repeating the process and feeding layer produced on previous stage, the second encoding layer can be derived, then third, then fourth, and so on until necessary complexity will be achieved. Obviously, we cannot obtain next encoding layer without computing previous one, which gives us sequential computation with configurable complexity that cannot be parallelized easily. If we want to increase replication complexity, when, for example, new, more powerful CPU becomes available in market, it is sufficient to add one or more layers computation to the encoding process. Here there is a table that represents how labels for the first layer are computed. What is interesting is that the relation with the original sector's data is achieved via mixing replica ID, which involves commitment D value into every label. In current settings, we use graph that operates with 6 base plus 8 expansion equals 14 total parents for each given node. Each parent is actually a pointer to a different node for a given node. Base parents are used for computing labels for current layer and expansion parents for referencing labels from previous layer. So as you can see here, 0 node doesn't have parents at all. That's why label 0 is computed without referencing other labels. Label 1 can reference only 0 label. Label 2 references label 0 and label 1, and so on. For the first layer, we don't use expansion part of parents, since we don't have previous layers. So 8 last values of parents array produced by graph object are actually ignored. They are marked by dashes. For the second and further layers, we start using expansion part of parents, which graph produces. That means that we bind second layer to the first one. Again, since 0 node doesn't have parents, label 0 doesn't reference previous labels. First label can reference a 0 label, and since we already have previously generated layer 1, we can reference labels from it. They are marked pink. Encoding process is continuing up to producing final layer of encodings, which is 11th in current settings. And now there is a question how to incorporate this process into sealing, as this is our ultimate goal. This is performed in the following way. Sectors nodes form a tree which we call 3D. Final encoding layer that we so slowly computed form a tree called 3C. Then every sector's node is summed with correspondent label from final encoding layer modulo to 254 according to current settings, and form a tree called treeRLast. Finally, all those trees produce inclusion proofs for provided challenges. These inclusion proofs obtained from 3 distinct trees are combined together into the object that we call vanilla proofs, which is an actual proof that certifies correct registering new sector in the network. Replica ID is also part of vanilla proofs object, which is essential as it is also committed to the blockchain and allows any validator of vanilla proofs to check all bindings between sector, miner, and chain. Since vanilla proofs object can take megabytes for production Filecoin sectors, it is quite problematic to keep this information for each sector in the blockchain, and also maintain transferring this data through the network. That is why we use snark primitive that allows compressing vanilla proofs object into succinct argument of knowledge that has much smaller size, 192 bytes for a single Groth16 snark proof. Interesting point is that we don't use zero knowledge property of snark primitive because values of vanilla proofs are not secret. The only property of snark that is relevant for Filecoin is its succinctness property. Of course, usage of snarks primitive requires global parameters accessible for both prover and verifier. They are generated via trusted setup ceremony on blockchain Genesis. If you follow the link below, you will see that we have a bunch of parameters for each proof type, including POREP, and also for each sector size. Publishing succinct snark proof instead of large vanilla proof is obviously beneficial, and any other participants in the network can use snark verifier with corresponding global parameters to validate correctness of replication. Okay, now after producing short snark POREP proof, storage provider can remove data required for a 3D and 3C construction, actual data of the sector and final encoding layer, and store only sealed sectors data, which is actually an encoded replica and some additional metadata. Talking about actual numbers, the duration of sealing heavily depends on CPU type, whether it's Intel or AMD. Fastest sealing is achieved on AMD CPUs due to its SHA-256 intrinsics. According to our latest results for 32 GIP sector, producing single encoding layer takes approximately 22 minutes, while sealing 11 layers are generated, so in total it takes approximately 4 hours in current settings. So the link below refers to our build bot, which we use for such experiments, and includes data about actual software and hardware. Summarizing all the above, proof of replication is an essential part of sealing process performed while uploading and publishing new sector in Filecoin's network. It cryptographically enforces miners' liability to start storing particular sector in its storage from a given epoch. It satisfies key high-level design requirements of the protocol and protects against fundamental threats to decentralized storage provider by binding actual data to the sector in the storage of particular storage provider, which actually provides security against a cyber attack, since changing identity of already registered sector will lead to changing the prover ID and consequently the replica ID, which is used while snark proof computation. Moreover, it provides security against generation attack when miner attempts to generate sectors by demand using small program instead of actually storing them, trying to increase self-likelihood of winning the block reward. Making sealing process computationally expensive prevents this, as miner cannot quickly generate large amount of fake sectors. However, nothing actually prevents miner to outsource the sealed sector to third-party storage provider and fetch it while retrieval request, as POREP doesn't guarantee that data is stored for some time after replication. This is the task for another proving mechanism, proof of spacetime. As we discussed, POREP is used by miner for committing available capacity to the network while registering new empty sector. And in order to prevent outsourcing attack mentioned above, a window proof of spacetime is introduced. Here I need to refer to a couple of external services, which is DRAND, distributed randomness, and clocks, based on NTP protocol that Filecoin relies on. DRAND produces randomness with a couple of properties critical for decentralized nature of Filecoin. First of all, DRAND's initial seed, which is essential for every pseudo-random generator, is generated through a multi-party computation between a diverse set of reputable entities on the internet, like Cloudflare, Kudelski Security, Protocol Labs, UCL, and other, which guarantees its transparency. For each randomness producing request to DRAND, a threshold of those entities is required to generate actual output, so there is no central point of failure. And moreover, DRAND mechanism produces publicly verifiable and unbiased randomness, so any third party can fetch it and cryptographically verify its authenticity, making sure it hasn't been tampered. Clocks is also quite essential for Filecoin. Protocol has strong requirements to clock deviation and enforces every entity to run NTP daemon synchronized with reliable external services. It's Cloudflare, Google, NIST, and some other. So, relying on DRAND and clocks, the idea of Filecoin's proof of spacetime is following. According to current consensus rules, every 24 hours time window is divided into 48 30-minute slots. Filecoin network requests every storage provider to submit particular evidence that previously committed sectors are definitely stored in miner's memory. To do so, network randomly selects particular slot, provides set of challenges, and asks miner to respond to these challenges. If miner does not respond in time or respond invalid post proofs for a particular sector committed previously, network treats that this sector is not available anymore and the mining power of this miner is reduced. Having that this process is continuous, miner has only limited capability to somehow delegate storing of committed sectors to third-party provider. Technically, it works as following. Having a set of sealed sectors in its storage, miner creates instance of trier last from each sealed sector, labeled from 1 to n. Network uses drand as a source of randomness and provides set of challenges that miner should address. Each individual trier last for each sector generates Merkle proofs for a given challenges, grouped together into vanilla proofs object that are finally being compressed into succinct snark proof. Here it is shown in more formal what is going on. Every sealed sector, which is actually an encoded sector plaintext data, is used to instantiate trier last, and vanilla proofs builder uses this tree to create inclusion proofs for provided set of challenges. As you can see, unlike POREP, here we don't need to generate encoding from scratch, so proof of spacetime mechanism works much faster. Note that here, unlike POREP, we deal with multiple sectors. That is why vanilla proofs builder takes set of replica IDs, one for each proven sector. Finally, vanilla proofs are passed to snark prover for compression. As the structure of vanilla proof is different for post mechanisms, we have separate set of global parameters for each sector size, started from proof of spacetime fallback string, which also was generated while trusted setup. Similar to POREP, publishing succinct snark proof instead of large vanilla proof, especially if miner has significant power storing a lot of sectors, is obviously beneficial, and any other participant in the network can use snark verifier with corresponding global parameters to validate correctness of spacetime proving. Okay, now summarizing window proof of spacetime, one can say that it accompanies proof of replication in high-level protocol design by providing security against outsourcing attacks when miners try to delegate storing sealed sector to third-party storage provider. Its continuous nature makes mentioned delegation unreasonable, as a malicious miner needs to perform transferring sealed sectors back and forth anytime when window post proof is requested. In the rest of the talk, I will cover winning proof of spacetime and election proofs, as they serve for protecting against important practical security issues related to blockchains in general and to proof of stake blockchains in particular. Let's start from winning proof of spacetime. Essentially, these proofs are very quite similar to window post proofs, but single winning post proof covers only single randomly selected sector for the storage provider. Current consensus rules dictate that new block should appear in the network every 30 seconds, so once new block is being generated, network agrees on the set of challenges and also an index of the sector to use for addressing the challenges for the storage provider elected to mine this new block. If storage provider is not able to produce valid winning post proof within short 30 seconds time window, it is not allowed to mine a block. There are no specific high-level cryptographic or security requirement for this proof, only practical one. It ensures that given block is mined by legitimate storage provider, storing active proving sectors and not some sort of cheat or spoof from malicious entities in the network. Schematically, it can be described as following. Again, similar to window post, storage provider keeps n sectors in its storage. Once it is elected to mine a block, network generates index between 1 and n that points to particular sector in miner storage and challenges for this sector. Rest of the logic is the same as in window post. In a bit more details, sealed sector specifically selected by the network is used to instantiate trier last, and Vanilla Proofs Builder uses this tree to create inclusion proofs for provided set of challenges. One can see that the winning post works always with only one specific sector, so size of vanilla proofs is smaller comparing to POREP and window post proofs. Finally, vanilla proofs are passed to snark prover for compression. Here, structure of vanilla proof is similar for both window and winning post mechanisms, so we use common set of global parameters for each sector size. And as it was mentioned, winning post proofs are used together with Filecoin proofs while new block creation, so I'll abstractly describe election proofs and then we'll summarize winning post and election proofs together. The consensus used in Filecoin is actually a proof of stake, where stake is measured in amount of useful storage provided to the network. The way how miner is selected for block creation is called secret leader election, and the election proof actually demonstrates that a given miner won the secret leader election, so it acquires the right to submit its block to the chain. And this is how it works in a bit more details. Let's consider a toy example with 3 storage providers, where storage provider 1 has 4 storage sectors, A1, A4, storage provider 2 has 2 sectors, B1, B2, and storage provider 3 has 3 sectors, C1, C3. Here on the slide, SK and PK pairs are private and public keys of particular storage provider. The probability to win the secret leader election will be approximately 43% for first storage provider, 33% for third storage provider, and 24% for second, according to the amount of storage they provide to the network. You may notice that Flashing Miner is a storage provider that wins secret leader election for current epoch, and the storage provider 1, as it has 43% of power, flashes more frequently. Every epoch, each storage provider in the network which participates in mining blocks takes a set of messages from the pool and generate a candidate for a new block with election proof computed from the direct value based on current epoch, plus storage provider secret key. A VRF function can be treated as a digital signature cryptographic primitive that allows signing particular data with private key and supports signature verification via public key of signer by any interested entity in the network. Once election proof is computed, storage provider sends this block candidate to the network and at the same time receives from the network block candidates created by other storage providers. In that way, all storage providers that participate in secret leader election have set of block candidates which includes own block candidate, and this set is evaluated and block candidate with heaviest weight is selected as a new block of the chain. Below there are links to how Filecoin computes block weight, and essentially heaviest chain should reflect the most amount of work performed, or in Filecoin's case, the biggest amount of committed storage. In order to check which storage provider was the author of heaviest weight block, the election proof is verified, similar to verification of digital signature, and the winner of secret leader election obtains right to include his block into the chain and collect reward for this block. As the length of election proof is not large, it's the only proving mechanism that doesn't use snark primitive. So that's the idea behind the election proof. Okay, now let's summarize winning post and election proofs. Main motivation behind them is making creation of new block fair and secure, enforcing secret leader election process, and proof of storage stake consensus rules of Filecoin. Besides that, these proofs have some important role in securing Filecoin against practical attacks like grinding, when malicious miner tries to manipulate with randomness used while election protocol. That's the task for election proof, actually, having that it relies only on randomness from DRAND, which is secure against grinding by its design. Also, as storage provider is required to submit winning post proof while new block inclusion into the chain, this guarantees that miner is legitimate storage provider that stores active proving sectors with the data useful for the network, and not some sort of cheat or a spoof. Okay, we have discussed quite a lot proving mechanisms that satisfy design and security requirements of Filecoin. However, updating the data of existing sectors wasn't covered yet. As we discussed previously, POREP is used while sealing the sector when miner commits capacity to the network. Eventually, after making deals with users, storage provider engages to store users' data, and in order to fill registered sectors with users' data, storage provider performs upgrading sealing sector. Let's return a bit to the results of N sectors replication. Remember that sealed sector is actually plain text data N0 and X encoded with labels label 0, label X, produced as an output of computationally expensive encoding process. And in theory, we cannot change sectors data directly as it is encoded, so most straightforward way of upgrading is resealing the modified data from scratch, removing data from the storage, and finally replacing the sector that is upgraded with newly sealed sector, which is sector N mark. So after upgrading, network start treating this sector as a completely new sector. This approach for upgrading was used initially in Filecoin implementation. There is also a practical use case when sector is empty from users' data. We call such sectors as committed capacity sectors, meaning that they are actually replications of zero data. And currently, such sectors represent the vast majority. It's 90+% of sectors in Filecoin. For this use case, there is a specific protocol that is called snapdeals. Its details are available with the links below. Essentially, due to particularities of encoding, using, so to speak, reversible modular addition operation, it allows reusing encoding labels generated while initial expensive sealing and avoiding modifying the sector's data and resealing at cost of additional storage, which is obviously beneficial for current state of Filecoin. Snapdeals is implemented as a separate mechanism called sector upgrade. It involves snark primitive usage. That's why while talking about upgrading, we treat it as a separate proving mechanism. But it is a bit out of scope of current talk. So that is mostly it regarding proving mechanisms used in Filecoin. I only want to stop a bit on Grot16 Halo 2 snark system replacement, which is actually the task number 1 for our team. As you might notice, snark primitive is quite important building block that Filecoin uses while compressing vanilla proofs object, as it can reach 2 megabytes, and it becomes a problem supporting transfers of this data within the network and maintaining it in the blockchain. But the cost of this compression is inconvenient centralized trusted setup required for generating global parameters for snark prover and verifier, which is the case for current snark system, Grot16. Halo 2 is a potential long-term replacement, and it tries to eliminate some limitation inherent to Grot16, We currently are in progress of investigating potential benefits and optimizations that may improve Filecoin scalability. I think my colleagues Volker already touched this work direction, and Sean will elaborate in more details while presenting our roadmap for the next year. Final thing that I would mention is that we have huge Rust codebase that implements all described proving stack, and we in Filecrypto we really welcome external contributors to participate, and looking forward to collaborate with the rest of the teams in the PL ecosystem. Thanks for your attention, and we'll try to answer your question.
Okay, so we are now ready for the question and answers. So I have Artem also on Slack to answer questions. He has a bit of a delay, like 10 seconds, because he's watching the stream. But yeah, but I can also help to answer questions. So are there any questions? Okay.
So one thing that came up was that the snarks used for POREP and posts don't have zero knowledge properties, which was probably made for some trade-off. Do you know like what we got out of not having actual zero knowledge over those proofs?
I can answer that one. So we don't use the property. Currently, the system still uses the zero knowledge part, but there's a PR open to remove it. But it's really only, it makes only it doesn't make much difference in the performance, basically. But basically, we figured out that we actually don't use this property, so we could remove it, but yeah.
So we do actually use it right now on mainnet?
Yeah, so we actually do use it. So the proving system is using it without actually we needing it, yes.
Cool.
Hey, thanks a lot for this. This is incredibly useful. I've been waiting a long time to get a walkthrough like this, and I think a lot of people have. I'm interested in that kind of the heart of this, which was the proof of replication process itself, what we call the sealing process, where we started off by breaking your data, or essentially merkling your data into, in this example, we used 15 leaves, and then going layer by layer, essentially constructing these labels, right? And the next layer is based on the previous layer's labels. What do we keep at the very end of it all? So I assume we don't keep all of the layers that we've constructed. What is the final thing that we actually preserve and that we need to keep for posts and so on? So essentially, what's in the replica?
Yeah. I hope to get Artem's help, but I can start answering, but I hope I will get his answer as well. We certainly keep the replica itself, obviously. I will.
I believe all the Merkle trees as well.
Yeah, so
Tree D, tree R last, all the Merkle information, I believe, gets stored away.
So we keep the last layer, essentially, is what I'm saying? Okay, cool. In that case, what is the unsealing process like? Because I know we can do it, because I know you can unseal the sector, but I don't see how from that last layer you can go back to the unsealed data.
Yeah, so this is quite simple, actually. So the last layer of the sealing process, so the layer 11, basically, that's not the replica. Okay. That's just the replica key, so I would call it a replica key. And that one is used, this one is applied to the original data, and then you get the replica out. And as we already work on like cryptographic primitives, it's in the cryptographic space, it's just an addition. And to unseal again, you do a subtraction, basically. So you can think of, if you are like familiar with an XOR operation, it's the same thing. So you use the key, do an XOR on to get the replica, and to get the original data back, you do an XOR again.
So what are the two things being XOR'd at that step?
So the layer 11 is the key, okay. And you do XOR it with the original data and get the replica out.
Gotcha. So you keep the original data around.
Just checking if it's correct what I'm saying.
Yeah. Well, Artem was just saying that it's the nodes plus labels that actually get stored after the sealing process.
Cool. In that case, how long does unsealing take? Because I thought it was a computationally intensive process, but if we're just XORing some data, shouldn't that be quick?
Well, it's it is kind of like an XOR, but it's a cryptographic operation, so it's not as fast. So.
Regenerate the whole sealing key. You need to seal again to get that, but you then XOR.
Okay, unless you keep it right.
Yeah, except if you keep the key, of course. Right. So then it's faster. Okay.
Cool. Thanks a lot.
Yeah.
Other questions? Otherwise, we can go into the roadmap for the next year. Just over here.
Yeah.
So as an SP, one of the things that we really care about is to plan ahead. And every time there's a performance upgrade to the proofs, it basically means the size of our seeding cluster could change, or the balancing or the size. Now we also have sealing as a service coming in. I was just wondering if you could share some light on what your roadmap looks like for improvements. Now, one thing is Halo 2, but I see as an SP that does not really worry me much. That's probably more about the trusted setup. But from an actually sealing performance, are we looking into getting much faster sealing soon? Because that could impact if we are going to sell excess capacity as sealing as a service. Stuff like that. So do you have any, I don't know if it's a short answer, but any ideas about if something will happen?
Yeah, so we will have the roadmap soon. So the short answer is we are fully concentrating on Halo 2 now. So I won't expect any improvements soon. But so we get into the roadmap. It's a perfect question for.
Right. So the CryptoNet Labs, which is basically the research end of proofs, they're looking into some things regarding speeding up the sealing process. Yep. So as far as our roadmap for the next year, Artem already talked about this a bit. A little bit of background on it. Halo 2 is a ZK snark that's developed by the makers of Zcash, electric coin company. So we're working on incorporating that into Filecoin proofs with their assistance. Also something that we've touched on, that it eliminates the trusted setup process for Gross16. So this is really important for us in the future now to deliver different types of proofs, such as with FVM or compute over data, beyond just the current proofs with Filecoin proof of spacetime on the network. It'll also accelerate any bug fixes or anything that needs to be rolled out on the network, since we no longer have to do this months-long trusted setup process. One thing that's important to note is Gross16 is not going to be going away, so they're going to be supported side by side. It will be expected, though, that future use cases, especially with compute over data or any proofs off-chain, are going to be Halo 2, at least immediately, but possibly some features will be Halo 2 exclusive. So I kind of touched on both of these. This is kind of our roadmap. So the quarter that we're in currently, we're working on getting functional parity right now between Gross16 and Halo 2, making sure that all our dependent Rust libraries are up to date. Volker is also working heavily on getting GPU acceleration up for Halo 2. So all non-recursive circuit code we plan to have done this quarter. Really what we want to have by the end of 2022 is a library that's available so that any of the Filecoin clients can begin to start incorporating it and start their own development cycles off. Going into Q1, we're looking to have proof recursion fully integrated. So any generating proofs of proofs, also continuing our optimizations, getting feedback from any of our development partners, especially the client development with Lotus and Venus and Forest, and using that to come up with a final API, get it in a draft of the FIP available. We also plan to start external code audits with Electric Coin Company, as well as any other security audits to make sure our code is robust. In Q2, so planning to have it ready to get it to production state, to have the API refined, and have a FIP, be ready to have a FIP out for vote. And this will also be some of the final testing performance gathering. So we'll have a better idea at that point how the final performance lines up with Groth 16. So Q3 is going to be probably the biggest change for our team. So up until now, we focused entirely on proofs for specific to the Filecoin chain proofs. We'll be looking more at other use cases so that the Filecoin proofs library will be able to be used for more generic proofs, like some potential use cases we're looking at are chain snapshots and chain bootstrapping to allow lightweight client nodes. Also integration with smart contracts to prove arbitrary proofs. Also looking at possibilities with L2, L3 networks, so compute over data, possibly integrated with WASM. Lurk is another project that we're looking at integrations with, so verifiable compute. So it's really up in the air, but it's our main goal for Q3 is sort of unlocking the proofs library to allow more generic proofs. So that's it. This is where to find us. We have a Slack channel, Phil Proofs, which is an open channel anyone can join. These are a few of our projects. Rustfil Proofs is really the meat of it. The project where you can dive into all the code. Rust Filecoin Proofs is our external API condensed into one place. And you can find our crate with all the dependencies on crates.io. So it's a Rust-based project. Filecoin-proofs-API. So any questions anyone has regarding a roadmap? Let's go back there.
Not specifically roadmap, but what keeps you up at night, I guess? Like the proofs, like you talked about scaling or adding another layer to the proof of POREP if, CPU speeds or GPU speeds go up really high. What are the things that you guys look out for in terms of like making sure it's secure?
Volker has the most tenure here, so maybe you should answer that. For me, I would say getting adequate test coverage, especially for making sure that every hole is plugged, that we have coverage for everything, especially with Halo 2, which is a huge change coming down the pipe. You want to go ahead and give your answer? For what keeps you up at night with?
Good question. What keeps me up? I would. I'd really like to make it like using less resources, basically. So coming up with something that is more efficient would be great, but I know the limitations of the cryptography. So yeah, but this would be great if we find better ways to use less resources, but having the same security properties, basically.
Right, so again, as an SP, what we're facing is basically when we talk to clients is that we need to tell them that Filecoin is really cool because we are actually verifying that we have the data. But we also have to tell them that we use quite a lot of energy on making that happen. That's partly of the sealing process. I don't consider the proving afterwards to be such a big thing, but especially the sealing. Meaning that for example, for 40 racks, we might have 10 of them filled up with compute that does nothing else than POREP. If there is speed-ups available out there, even getting open sourced. Is it because of constraints in your team that you're not like pushing for getting that speed up implemented right away versus Halo 2, for example? Because I feel like also talking to the Filecoin Green team, this is one of our pain points, is that we have this very high consumption of power on doing this part of the process. And I guess as an SP, where we want to go is, in the future, we'll see that this gets smaller and smaller. But part of that would be to make sure that, we are always aiming at getting faster seeding speeds, taking up less resources and so on. But it seems like right now, since we got the last speed updates on the C2 and PC2, I think, it has been a long time since we've seen anything. And we know out there's a lot of SPs that are starting to develop their own stuff. There is a lot of implementations or speed ups being done out there, but not really implemented centrally. And I guess implementing it centrally would mean that it comes out to more SPs and then generally using less energy. So is that something that you're, is that because of lack of resources or what is going on?
So there's two things. So I would say, there are pieces in the seeding process, especially the first piece of the seeding process is especially expensive. But so the GPU parts basically are just slow. So they are not intentionally slow. They're just slow because snarks are slow. So we hope that there will be breakthroughs in research where basically this will for free kind of in the future. But the first part is really this is where you get the security into the protocol to make sure you really have the data. And that's intentionally computational intensive because this is how you can make sure it's secure. There are certain improvements, but it's not there could be improvements on RAM usage, for example, but really the CPU usage, for example, I currently don't see a way to get away with it except doing a completely new POREP. In regards to the optimizations, I would say it's a lack of people working on it, but also people are free to contribute. So I can see that the problem is there's the problem of course, it's beneficial for miners to hold this information back because they have an advantage. But if people would contribute, we would surely look into it and Cool, all right. I think we have to close the Q&A, so thanks for the questions. And
I'm going to disconnect the HDMI. Is that okay? No? Thank you. What's this? Oh. I don't have another one. No. Oh, sorry. That's okay. I don't need a clicker. Okay, perfect. Yeah, it's fine. Yeah, it's fine. It's very low resolution, is that? Yeah.
So it will duplicate at 1080 to take it into the production. So that's the reason.
Okay, well, that's fine. Yeah.
Okay, thanks.
Yeah. Okay, yeah, perfect. Okay. So, sounds like there's some people trickling in. Are there folks who, can get started. Okay. Alrighty, so here I am again. I know that you folks are probably losing some steam. It's one of the last sessions. What I want to do today, I want to first of all say, it says workshop, but unfortunately it's not quite a workshop because some of the things that I had anticipated would be working live actually are not. and that's what we have to deal with something so new. So I'm going to basically try to tell a story more with some code that I had written, and I'm happy to share that you can reproduce, hopefully, on a Google Colab at home, which is pretty agnostic of whatever you choose to do. So what I want to talk about today is the full story of what is enabled by what we're building, right? It's not just a decentralized storage solution. It's not just the FVM. It's not just compute. What interests me, or I guess why I joined Protocol Labs, was to build an end-to-end solution that enables a data economy. And I know that the Compute Over Data Summit it's happening today, also tomorrow. There's plenty of cool stuff there. But I also wanted to give the opportunity for this audience to understand how certain things might fit together and why this is so cool. Like, why are we building all this? I want to start with the master plan. This is probably something you've already seen, where Juan likes to say there's 3 steps, right? Step 1 is build the largest decentralized storage network. We have used crypto-economic incentives to build an incredible amount of capacity. But then really the question is, well, what do you do with this? We don't want to be in a helium situation, right? Where everyone's like, man, no one's really using this. Or like Decentraland, I don't know if you saw that a few days ago, where people were like, oh, well, this is worth $2 billion, but there's like 40 people using this. Like, what's the deal? You know? So usage is going to be a function of utility, not just in terms of the onboarding, but fundamentally also bringing the compute to that data or to the state on the blockchain. And really that's going to unlock an insane, in my opinion, data economy that I think is going to be, transformative if we manage to execute. So I want to tie this all together, and I just wanted to give you a few examples. I want to caveat by saying it's probably not going to take 40 minutes. Thank God. But I hopefully just want to impress on you a few interesting use cases that I felt were pretty cool. I started off my career in data science, and I spent most of it in a big tech company where I was beholden to centralized infrastructure, and I was always very frustrated that we were building some of the best machine learning models in the world, but not really able to share them, not really be able to share the value they created back to the data owners, to the labelers. And so I just wanted to give you some cool examples of what's possible today and what might be possible in the future. All right, so a couple of things that we're going to do. First of all, I'm going to give you an example of how we can use data on IPFS and compute over data to go from this, which is a dash cam frame, to this, right? Just typical object recognition. It's a really standard task, and it is something that for autonomous vehicles is, something you need, obviously, to understand where are the other cars, where are bicycles, where are the people, to make sure you don't hit them. The second thing we're going to do is go from that video, which is a NASA archive of the landing on the moon, to a transcript of the audio, right? So these are like real tasks, especially in a machine learning world, that we have crazy cool models that are coming online, open source, things like Stable Diffusion, like everything from generative, from image to text, text to image, and whatever, everything in between. There's some really, really cool stuff happening out there. And so I wanted to just give you some examples of how you can literally do that today using compute over data, which I think is awesome. I've already showed you this slide. It starts with onboarding data to Filecoin. We are doing a lot of work to abstract away the complexities involved in this. And so, this is checkmark 1. Hopefully, there are enough tools today, actually, that you can use to put the data in a format that is decentralized and that you can use either from IPFS or through Filecoin. So I won't spend too much time here, but my bigger point here is this is something that exists today. None of the things that I'm going to show today are fully baked products, but I want to really highlight that you can do some really cool stuff with the stuff that is already built, even if it's 20%, 30% there. So putting data somewhere, right? How does it work? Generally speaking, it's one of 3 ways. There is via an on-ramp, right? There's the method number 1. Generally speaking, you're talking about something along the lines of Web3.storage or Estuary, where you have a third-party hosted service that is doing the data transformation for you, and it's sort of like a plug and play almost, right? Or plug and pray, as Shrek like to say. So you just hope that it gets there eventually. then there is a mostly client-side option, right? This is the example of a enterprise taking their data that is on-prem and leveraging some tools. It could be like, GoCar, for example, to take some data and transform it into some car files, and then basically ship them over to a storage provider where they will do the sealing. And then there's kind of the opposite, right? Where I, as a company or as a research institution, might not have the technical know-how or the resources to do all this stuff on the client side, but I have way too much data for an on-ramp. I can't just do 5 petabytes of data using Estuary. And so I will just basically ship some raw data, I'll encrypt it, and I'll ship it in some hard drives to a storage provider who will then do it all for me. And so I want to really highlight that in terms of getting data to the network, there's many different ways. And I welcome you all to talk to us at Protocol Labs to figure out what might work, whether you're a data onboarder or whether you know someone who is. So the thing that I am going to discuss today is something that looks somewhat like this, where I'm going to highlight some ways in which you can get data into IPFS, take that data and do some computation over it, and also leverage Filecoin as a way of archiving that data, right? So if I'm a machine learning researcher, why is this important? It could be for many reasons, right? Number one, I have collected valuable training data. I don't want thousands and thousands of images or videos just sitting around. I might want to just archive them to Filecoin. If down the line another researcher wants to reproduce my experiment, they know exactly what CIDs I might have used. They know exactly the sequence of steps necessary to transform them using another sort of CID, but for data transforms, and so they can reproduce it. I don't have to waste valuable hard drive space. If other researchers also want to download the data that is available in IPFS or Filecoin, they are free to do so. And above all, right, when it comes to compute over data, this is a really incredible promise of the sort of eventual end state that we're shooting for of storage providers co-locating storage and computation, where I can actually run things in a decentralized manner in a way that I'm not beholden to large Web 2 cloud providers to do it. So this is the general thing that I'm going to architecture somewhat, that I'm going to explore today with you to achieve those 2 tasks that I talked about. So step 1 is onboard data. Step 2 is do some compute over it. Step 3 is retrieve. I will talk a little bit about the end goal of actually doing this all in a Filecoin ecosystem that does not exist today. And so I'm taking many shortcuts right now, where I'm just using IPFS as really a proxy for what Filecoin might become in terms of its ability to efficiently serve retrievals, for example, as one example. So example number 1 is, I want to take some data that might exist in my Google Drive. As an example, I might want to put it on Web3.storage or Estuary, and in doing so, I just put it on IPFS, and then I want to run some compute over it. So very simple code, actually. There's many ways to use either of these tools. There is something like estuary.tech, where I can actually go in here, I can sign in, and it allows me to have some sort of oh yeah, so this is why I didn't do this. Hold on, Web3.storage to the rescue. All right, cool. So I can actually manage my files, and I can actually have a user interface that allows me to onboard files onto IPFS and Filecoin in a very seamless manner with a web UI. Of course, this doesn't really work if I have tons and tons of data, but it is a good way to get started, so I encourage you to explore this option. If you want to play around with compute over data after this session, and you just want to onboard, 10 pictures or 100 pictures or something not that big, you do have 1 terabyte of data, which is great. But what I wanted to show you is, it actually really is straightforward to use other methods, right? You could use an API, right, and just make a simple post and basically attach a file to that request, and that's it. It'll work. So right now I can, let's see, this is Web3.storage. I've attached my key here. All right, and I can, let me just transform that response, and I can print a CID, and I can create a gateway URL, and there you go, right? Super, super easy, almost instantaneous. They're using Elastic IPFS. It's really cool. So for experimentation, it actually works really well. And so you can do this. You can onboard a bunch of data pretty easily. If you are scared of code, you can even use something like this, which I didn't know existed until last night. It's so easy. It uses the same thing in the backend. It actually just gives you a CID for a folder, and then the respective, you click into that and you see all the different CIDs and within that folder. There are command line tools. There's so many, there's so many things you can use to onboard your data. If we're talking about a sort of sub 15, I would say in my experiments, anything above 10 to 15 gigabytes starts getting a little iffy. But yeah, it'll do the trick. So you can use any of these tools to onboard your data. And these are very useful because, you can just share this link using a CID. You'll know exactly what you get. Now, Bacalhau is a solution that is being built by other folks within Andres inside of Protocol Labs aimed at doing distributed computation over data. And so it is actually also very, very easy to run. What it allows you to do is to just specify an arbitrary Docker container, and it'll execute that on some remote magical thing, and it'll return the results. It's very straightforward, right? So in this example, by the way, I will share this with you. This is very easy to rerun. So go ahead, you can install Bacalhau. Bacalhau, by the way, is Portuguese for COD. COD is an initialism, COD. COD, compute over data. It's a big stretch, but I've had several people ask me, like, why the hell is it called Bacalhau? Especially Portuguese people who are like, what? So you can, it's really as easy as this, right? Where you can specify what you want to run. You can even give it runs GPU jobs, which is pretty nice. So for all ML type stuff, it does both training and inference. You can specify then like where you are serving, like where to pull data from. So in this case, this CID is essentially just a folder to which I uploaded a couple of pictures, right? And I uploaded those pictures of my, a bunch of pictures of the dashcam footage, right? And so you point to this, you give it a Docker container. In this case, I'm using YOLO v5. YOLO is a common ML model for object detection. It's right off the shelf, and then you basically give it the command. I'm giving it, say, hey, go run detect.py, and use this checkpoint that I also onboarded to IPFS. Here's the source, and give the outputs. Put the outputs on this folder. You'll run it. It'll go through this. I wanted to do this all live, by the way. I'm sorry that I can't. It's way more engaging, but hopefully I don't want to linger onto this too long. It'll do the job, and it's surprisingly fast too, which is pretty great. And so, even though this is just in the beginning, I was really excited that I was able to just, go ahead and like use this solution and get a Tesla T4 GPU to go and like do my ML inference. So I did all that. I create a directory for my results, and I get my results. And it's actually really, really cool. If I go here, and I go to my Lisbon demo, oops, there you go. That's a CID that represents the folder in IPFS that contains my, come on. Oh my God.
Google Chrome doesn't work, unfortunately.
All right, there you go. There you go. So these are different frames of that video. I, pre-processed this to use FFmpeg to just basically extract a handful of frames. But that's that. It's really simple. And it did this in, I believe, a few seconds, which is pretty cool. So once the resource is provisioned, it'll execute really quickly. And there you go, right? So it's pretty neat. The other thing I experimented with that is also really exciting is, let's say you're generating video, right, or using something like Stable Diffusion, and you're running at 60 frames per second, you could, in theory, parallelize this across the 60 machines and have it run way faster instead of doing it sequentially. So I encourage you all to experiment this. Maybe I'm just nerding out on my own up here, but I think this is pretty cool. So that's one example. Example number 2. By the way, once this is here, I could do a bunch of stuff, right? I could use Estuary to take those CIDs and say, hey, shoot this over to Filecoin. It's already there. It'll happen pretty quickly. All Estuary does is it waits for there to be a 32 gigabyte sort of collection of files, and then it shoots it off to storage providers. In the future, this is going to be way, way, way more seamless. And if you're in an environment like Colab, which I'm very familiar with, it's very easy to just basically say, hey, take this stuff that I just did and put it on Google Drive. I could use something like rclone to take my stuff from Google Drive and then put the results straight into Estuary. It can be pretty neat. Here's another example of machine learning model inference, where it is a speech-to-text model, right? OpenAI just released their Whisper model. It by far beat all their state-of-the-art for speech-to-text, which is basically automatic speech recognition. What it does here is it will take video or audio or anything else. It'll auto-detect the language, and it'll convert it to text. It's really, really cool. So I think the use case here might be automatically creating captions for YouTube videos in any language with really high accuracy. And so really what we did here was take OpenAI Whisper. It's literally just a Python script that basically takes an MP4, uses FFmpeg to extract the audio, parse the audio, and then pipe it through here, and it'll spit out. You basically use bacalhau get. You basically use the ID here, and you can get the results, the transcription. And so, I don't know why. There we go. Lisbon, Whisper, raw. Oh my God. I don't know why. There you go. So there it is, right? Again, not particularly remarkable, I think, but in terms of just one video. But I think it's really cool that you can actually just take some content that's hosted on IPFS. And one day when we have better search engines for all this stuff, you could imagine the sort of data economy that can be created by just taking data that's already there in public and just doing these transforms. And so both from a standpoint of the amount of data that's just waiting there to be processed and mined, it's incredible, but also in terms of the compute that we have access to. Alrighty, so that was video to transcript. All right, now, of course, many people here who are more familiar with our stack will be quick to point out, okay, you're way over-promising here and under-delivering because I'm basically pulling stuff from IPFS. I'm not actually taking it from Filecoin. If you did want to get it from Filecoin, I'd have to do Lotus retrieve. Hopefully that they have an unsealed copy. Make sure that it's retrievable, get it, and right? I'm also just doing computation over the data itself. I'm not doing computation over the state, right? So what about smart contracts that can be used to launch jobs? Not there yet. And so this is a very classic case of grass is greener on the other side. I promise you it is. And I believe pretty strongly we'll get there, perhaps not in Q1 2023, but soon enough. And I'm excited to see what comes out of it. And as an example of, here's what it's going to take, right? I can imagine a bunch of really cool tools working in concert, right? You have something like Singularity to onboard vast amounts of data and keep it all clean and index it all. You can use something like Bacalhau for compute over data that I just showed you. The FVM, of course, allowing you to compute over state, and Saturn for much easier retrievals. And so all of these things in concert, I think, are going to provide a much more exponential utility, I believe, in the next year. So here's something that I am personally pretty keen to explore next year as these things, as the pieces of the puzzle fall together, right? Like, let's say that you are some end user who is providing user data. Could be behavior data. Let's say it is voice data, right? Like we speak to Siri and our Google Homes every day. Imagine the idea of storing all that data on Filecoin and then creating a system by which that data can be labeled, right? Let's say you're talking about a supervised machine learning model that requires me to have data that has labels. In other words, I have a bunch of utterances in English. I want to create a machine learning model that transcribes English audio to text. I need to have many, many, many thousands of examples of actual people speaking in English alongside their translations. Just like for computer vision models, I need to have actual human beings draw bounding boxes and really show a supervised learning model what is a tree, what is a car, what is a dog, etc. Right? So in this example, right, you can have something where perhaps using the FVM, a combination of the FVM and compute over data, you can create a whole data economy where I can create something like a labeling platform that allows people to label actual data that exists on the Filecoin network. In return, they might be paid out by the model creators, by the researchers or the companies that leverage those models. I can use compute over data to do the ML model training. And as a result of that, I'm going to have new synthetic data that can be used for future model training, as well as new models that, when used, we can use the whole chain of custody over this whole thing to identify just exactly how much did people contribute to the creation of this model in terms of the data that was needed to train them. And then actually, let's say this model generates $100 million in value and utility for someone. If I contributed just 1% of that data, I mean, it's probably not going to be as simplistic, but let's say that I did, you could, in theory, reward people for the amount of data they contributed directly and verifiably, which is really, really, really cool, in my opinion. And so, you could have a whole ecosystem, right, where Phil is paid out to data owners, Phil is paid out to labels, Phil is paid out to the people who actually created those models, right, for the actual code in terms of the model architecture. Really cool stuff. So just one example of something I believe could be done in the next year as all these 4 pieces fit together. So that's the end of the talk, right? Went over IPFS, compute over data, how these things fit together. Really want to impress on you that, this is early days, but you can do some really cool stuff already, and you can gonna be able to do stuff that is 100 times cooler next year. It's really striking when you can use stable diffusion to generate whatever artificial pictures of dogs or cats using a decentralized network. It's really awesome. So I will be sure to give you the URL for the collab. You can run this on your own. Collab's free. You'll get to see, step by step. And I encourage you to play around with this. Okay.
Cool, thank you very much. We've got a 5-minute break now. So yeah, go switch your legs, grab some coffee. So our last talk of the day. I'm sorry. Next, we're going to go to the faculty for the next 2 talks, and then Jonathan Schwartz will go to us. everyone. Thank you for sticking with us. We're running a little behind schedule, but we've got 2 short talks on Saturn, and then Jonathan Schwartz will be closing us on what it's like to build on Lotus and where 2023 is going to be. So cool, without further ado, here's Ansgar from Protocol Labs to start talking about Saturn.
Is this thing on? Absolutely. Thank you. Thank you. Thank you. Good afternoon, ladies and gentlemen. Today we have a treat. We are going to go through what Saturn is, why we built it, how it's built, and we're even going to get to see a little demo of it. So we're under the gun here a bit, 10 minutes. Let's rock and roll. So my name is Ansgar Grunzide. I lead Saturn, and let's get into kind of what is Saturn and why it exists. So first of all, every great product begins with an opportunity to solve a problem. Saturn is no different. The problem that we set out to solve, that we set out to face, is the problem of retrievals on Filecoin. Filecoin has assembled an absolutely enormous amount of storage, but there's a problem. The problem is getting data out that's been stored is slow, and that is why Saturn exists. So like Filecoin has assembled 17 exabytes of storage, 300 petabytes of actually stored, but where are the Web3 YouTubes? Where are these apps? They can't be built yet because we haven't built something like Saturn yet. So we also see a bunch of evidence that people are waiting on pins and needles for faster retrievals and file delivery from Filecoin, because a bunch of people are already storing the data on Filecoin, but they can't get it out quickly. And we see this with the IPFS gateway, where a lot of people are building apps in the IPFS gateway and not being able to build and scale because the IPFS gateway can't meet their needs. So this is the problem and the opportunity that we see. Now, what's the solution? The solution, and this is what Saturn has become, is a crypto-incentivized content delivery network for Filecoin. And now, what we're going to do, and the principles we lean into to assemble and engender this content delivery network, is crypto economics and crypto incentives. We've seen how rapidly Filecoin has been able to assemble this massive amount of storage space in a short period of time with crypto economics and crypto incentives. When storage providers are incented to run Lotus and join the network and mine Filecoin, we've seen 17 exabytes be assembled. And we want to lean into those same principles, but for content delivery. And we aim to scale to millions of nodes globally, and we want to build a marketplace where people can pay for bandwidth and content delivery rather than kind of centrally organize and manage a content delivery network like Web2 CDNs. So what are Saturn's goals? We will not sell ourselves short of being the world's best, fastest, lowest cost CDN. We also want to include everyone. We don't just want to have people be able to contribute big servers and data centers. We want to, as we'll hear from Miro shortly, we want to be able to grow Saturn's network to include people who have desktop machines, laptop machines, browsers, phones, and everything in between. And we want to advance Web3. We want to take all those applications that are storing their data on Filecoin and will store their data on Filecoin and let them build YouTube. And finally, what we want to do is we want to democratize content delivery earnings. So content delivery networks like Cloudflare, AWS right now, all of the money around the world from all the websites on the internet that pay for content delivery wind up in their pockets. We want to take that money and break it up and pay everyone who contributes to the network so everyone can get paid. Now, how are we going to do this? We'll run through a quick diagram of how Saturn works in a second, but there's really some fundamental building blocks here. The first piece is retrieval clients. So in a trustless network like Saturn, where anyone can spin up a content delivery node and run it, you need to verify the content that you request as the content you receive. Imagine you request a cat picture and get back a dog picture instead. That's something that we can't allow. And so we built something, well, unless you really love dogs, in which case you're happy. But what we've built is something called incremental verification. And what this means is when you request the SID of that cat picture and you get back from one of these random Saturn points of presence around the world a picture of a dog, you can immediately reject it and say this is not the content I requested. So the first kind of nodes in Saturn's network are what known as L1 nodes. These are big, beefy servers and data centers. These are the machines on the edge of Saturn's network that sit close to end users. The next nodes we have, and we'll hear from Miro more about this right after myself, are smaller nodes in the content delivery network. These are nodes that run on desktops and laptops and phones. And then to tie it all together, we have a piece of software called the orchestrator. If you can imagine a magical thread that we can take and weave together into a big, beautiful tapestry of all these L1s, these big L1s and these smaller L2s into an actual performant network that can serve content. That's the role of the orchestrator. And then we log all content served by Saturn as the content delivery network to derive payouts and perform anti-fraud. So this is kind of the overall architecture of what Saturn looks like. On the left side, we have a retrieval client, and the retrieval client finds the nearest big server via DNS. Those are the L1 nodes. And then surrounding it is this swarm, imagine like a BitTorrent-esque swarm of L2 nodes. And again, these are the desktop nodes. So every L1 is supported by an army of L2 nodes nearby. And then we see all the way on the right here the storage providers, running Lotus and whatnot. And the L2 nodes, when they don't have content, so like, let's say the retrieval client on the left requests a SID, the kitty picture. It sends that request to the L1 node. If the L1 has it in cache, it responds to the cat picture. If it does not, it asks its BitTorrent swarm-esque of L2 nodes around it, do you have this kitty picture? And if not, the L2 nodes fall back to storage providers, which are actually storing that kitty picture. And in this way, Saturn grows its roots into Filecoin, the storage network, and becomes this globally distributed content delivery network on top. Now, that's great and all. I just talked a lot of words about how this thing is built and how it's organized. Let's show you what it can actually do. So what we're going to do here now is run through a quick demo. So in each of these little windows here, we are about to SSH into little VMs worldwide. One in Taipei, one in Portland, one in Toronto, and one in Sydney. And then what we're going to do here, after we SSH into these machines, is we're going to run 3 tests. The first test is going to be a speed test to retrieve a SID from IPFS, the IPFS network, using the IPFS command line client. So here we see this command. What this does in short is, let's see, paste. What this does in short is it clears our little IPFS cache, so we're going to the network, and then it's just simply a curl command and requesting a SID. Thank you, thanks so much. As if I'm not loud enough already, thank you. This is sending a HTTP request to our local IPFS node, which is going out to the IPFS network and trying to request it. So here we see curl sending the request to the local IPFS node. That IPFS node is going out to the IPFS network and trying to request this content. So here we see we received our first byte of content back from the IPFS network in Portland in 1.26 seconds, and the rest of them are kind of chewing on it. And the download is really slow. Oh, this is the file that's actually being requested. It's this little goofy 6.5 megabyte video of, well, you tell me what that is. So what we see here is this is about how fast it takes to download from IPFS. Next, let's go check out the IPFS gateway. So in this command, well, let's kill these. So what we're going to see here is from slow to faster to fastest. So here, we're going to send an HTTP request to the IPFS gateway, and this is kind of the current state of the art for retrievals from the Filecoin network. So we send this off, and again, we see the IPFS gateway returning with content. We see a time to first byte of 220 milliseconds in Portland, and this download's still going, 43 milliseconds at the bottom left. We'll kill these, and here, we'll see Saturn next. So here we see the same command. We're curling. Instead of IPFS.io, we're talking to Saturn's network. And so here, when we smash enter, we see every one of these requests returned really, really fast, especially compared to the IPFS gateway. This is orders of magnitude faster than any retrievals have been possible before in the Filecoin network. So what we see here is 55 milliseconds, 22 milliseconds, 20 milliseconds, 47 milliseconds. This is the fastest that content has ever been able to be retrieved from the Filecoin network. Period. Now, thank you. Yeah, now. So now let's move on and let's see how you can participate. So we actually launched 4 days ago at this very stage, and that means you, anyone out here, anyone you know, can now run a Saturn node and participate. So you can rent a server, these are the requirements for the server, and run Saturn software and earn between $0 and $3,000 a month, depending on how much content you contribute to Saturn. To get started, check out our sexy website there, saturn.network. I promise it'll be the most important website you visit in the year 2022. And then what does running a node actually look like? So, you guys know Lotus and what it means to run a Filecoin node. What does it mean to run a Saturn node? Well, the only thing you really need is you need a Filecoin wallet and a Linux machine, and a Linux server and a desktop. And once you SSH in, you can set up the machine, you can everything inside of Saturn's L1 runs in a Docker container. You can use Ansible to install it or whatnot. And then what does it look like when you actually run one of these things? Well, your node comes online, and this is the giant kind of table of all the nodes we have running right now. This is a live set of all the nodes, and this has grown 4x in 3 days. And we're off to a roaring start. And then you'll also see a dashboard here of what your node's doing. So you can see your earnings, the number of retrievals, the amount of bandwidth served. And with that, let's wrap up for what Saturn is. Here's our roadmap. So you'll hear from Miro again in a second on L2s, kind of the desktops, and adding L2s to the network. That's coming. What we just launched a few days ago is just the L1s, just the big servers. And kind of Q2 2023, we want to scale the L1 network to achieve hundreds of nodes worldwide. We're probably about 150 now. We want to get to 300, 400, 500 and on. And again, we'll hear from Miro. We want to start the L1 nodes to start cache missing to that BitTorrent-esque swarm of L2s around it. And then later in 2023, this is the big one. We want to connect to all of the Lotus software running on SPs and connect Saturn end to end and dig those roots deep into the fertile ground of the storage providers. And with that, we have run through a quick run-through of what Saturn is, why we built it, how it works architecturally, and we've seen it actually work in action. So with that, I'd love to open it up to any questions you guys may have. Thank you.
If we're running a Saturn node, is there a penalty for going offline for 24 hours? Or?
There is. Great question. So there are a bunch of heuristics that factor into how much Filecoin you earn when you're running a Saturn node. A lot of those are performance-based metrics. So your time to first byte, like how quickly you can upload content to the network, and one of those is availability. So there's absolutely a graceful way to take your node offline, do some maintenance, and plug it back in that avoids essentially any penalties. But if your node goes offline without warning, built into the kind of payout calculations, you will receive a penalty. Because these L1 nodes need to be online and accessible so that users around the world can retrieve content from them. Does that answer your question? Yep. Great question. Great question, yeah.
What is the source of the Filecoin that's used for paying out incentives?
Great question. So in the beginning, we've set aside a pool of fill to help grow Saturn and bootstrap the network for early adopters. But in the end, it's going to be from customers. So these are websites and other entities who pay for faster content delivery with Saturn. So you can imagine kind of this virtuous cycle where in comes money from websites for delivering movies, NFTs, images, JavaScript, CSS, and accelerating that. And that big pool of funds then gets divvied up proportionally to the L1s and L2s of the network who are contributing the bandwidth to deliver that content. So imagine classic kind of market supply and demand. Great question. Does that answer your question? Yeah, great question. Any other questions? Are we ready to go hear about L2s? Okay, with that, I would love to have Miro come on up and talk about L2s and the other piece of the network. Thanks, guys. Are you gonna jack in?
Yes, of course.
Okay, cool. All right, here you go. Thank you.
Cool. Ansgar did a great job of introducing Saturn. And we see Saturn as a way how to cross an adoption chasm to allow more people to join the Web3 as users, but that's only the first step. And the second step is how to allow these users to contribute their resources or to participate in the Web3 economy. So they are not only consumers, but actually actively participants. And the opportunity here is great, because if you look at the current computing landscape, we have about 3 million servers running in data centers of AWS, which would be the L1 nodes or the Web2 technology running out there. But now compare this to the number of Raspberry Pis sold in the last year alone. That's 10 times more. And it's still nothing compared to the amount of personal computers sold. So we have hundreds of millions of PCs running out there and not being used to their full potential. For example, a typical user doesn't use much of their CPU power. The CPU is just sitting there idle. And even power users like people of writing code or editing video, they are not doing this 24 hours a day, right? And similarly, the internet connection bandwidth is not being utilized. Even if we are watching videos, we don't saturate it by 100%. So there is another opportunity which we can leverage. And now the question is how we can put all these idle resources to work for us. And our answer to the question is Filecoin Station. And Filecoin Station is a desktop app that anybody can install on their computer, like your parents or your friends. And this application will contribute your spare resources, be it CPU, disk storage, internet connectivity bandwidth, to the Filecoin network and reward you with Filecoins back so that you are incentivized to run it more. If we look at this from a technical point of view, we want to allow people to run untrusted code, do some useful work on untrusted computers, and we want to pay for this, which makes it very tricky. But it's a big dream, right? Because once we build this technology, it can allow us to do plenty of amazing things. We can run distributed computation to accelerate, I don't know, research of cancer treatments, whatever. We can pay Saturn L2 nodes to actually provide content to the network to accelerate retrievals. And we can also check whether the network of peer-to-peer nodes is actually behaving as it should, whether the nodes are up, whether they are doing what they are supposed to do. And we can also do pretty good measurement of network performance from real computers running in real home networks, as opposed to just running some simulations in data centers. So that's all cool, but where are we now? Saturn L2 launched. The station are still in alpha. You can download the app, give it a try. You will be running Saturn module, the L2 node, already in your application. It will be connected to Saturn testnet. It will start receiving real traffic. And there are no Filecoin earnings yet. That's something we are working on. And we are iterating on the user experience to make this application as easy to use for consumer-grade users as possible. And very importantly, we are looking for ideas of what other modules we can run. So imagine you have hundreds of millions of stations running out there. What would you like to run on these stations? And let me do a quick demo of what the station looks like right now. So nothing happens, right? We want the station to run in background to be very inobtrusive, so you don't even notice that it's running. It's just this icon here, which I need to change to white soon. And when you open the UI, we are keeping everything minimal, just the total number of jobs completed, and hopefully the number, oh, it goes up, right? So I'm connected to the Saturn network, I'm serving retrievals, and that's the jobs I'm handling in my station. Soon we will add earnings, the Filecoin, to reward you for running the station, and a nice log what's happening in the Saturn. So that's station right now. And what's next? Next, we would like to build, oh, that's the demo time. Next, we would like to do a public beta where we would have a built-in Filecoin wallet to make it even easier for people who are not familiar with crypto to actually start earning Filecoin. So the wallet will be provided for them. We will have Saturn module connected to the mainnet, serving real requests for the CDN, and we will be paying out Filecoin earnings. Okay, that was like the introduction, and now what the station, how does it look like under the hood? Technically, station is composed of the station itself and then one or more modules. You can think about this as of the International Space Station. You have some infrastructure, and then you have different modules connected to the frame. So you would have a habitat module where people are living. You can have a scientific lab where you do the experiments, another module to recycle water and air. And similarly, we are building station. The station component is providing the integration with the operating system, UI, all the things which you don't want to build for your module. You want the station to take care of it. And then a module can be anything that can run jobs on the computer, preferably not using all resources, because then people will just shut it down. And it needs to pay rewards in Filecoin. If you would like to build a module, come to talk to us. It's super easy. You just write any, or you just give us any binary. It can be a Go binary, Rust binary. Probably Node.js would work as well. Station will configure you using environment variables. This is the well-known 12-factor app approach. And the communication is over STD out and HTTP. Very easy. And the important thing to mention here is that we support only trusted modules right now. We trust you as the module author that you are not going to do something malicious like stealing SSH keys or similar stuff. And which probably makes you think, why are we doing it this way? There is no support for untrusted code. We are using Electron. Oh, not wrong. And the reason is you want to ship quickly and iterate fast and get user feedback and find out whether this is actually the right way to take. And yeah, that's it. Thank you, Ansgar, for the approach. Okay, and going more longer term, we are already researching ways how to actually make our dream come true and build a runtime that will isolate individual modules so that we are sure they are not going to do any harm, so that you can trust this application and you can install it on your parent's computer. And we also want to enforce limits on resource consumption so that even if your module is not aware of limitations, we will make sure it's not using too much of computer's resources. And the way how to implement this, there are different approaches. We were looking into containerization or virtualization, but unfortunately that doesn't work. One, not all consumer-grade computers support virtualization. And what's even worse, Windows Home Edition doesn't support virtualization at all. There are no APIs for that. So we decided to take the path of isolates, which is a technology used by Chromium browser to isolate your tabs. It's used by Cloudflare workers on the server. And the idea is to build a station runtime, maybe using FVM or IPVM or similar technology, which will provide runtime to run your JavaScript or WebAssembly code. It will sandbox your code to make sure you can access only safe subset of resources. We can do resource limiting and give you platform APIs, maybe access to file system and WebSockets, network sockets, maybe something more higher level like an API to fetch a CID from anywhere it can be in the network. And on top of this, it will be super easy to build station modules. Except there is the third part, which I haven't mentioned before yet, and that's how do we schedule jobs? How do we prove that the job actually has been executed correctly, that the station is not cheating? Because remember, it's running on a trusted computer, and it's open source, so anybody can modify it. And then how do we handle billing and payouts? So that's still an open question to research. And that's almost it. If you like, please go ahead and download the application using the QR code or filecoin-station.app. And if you have any ideas what would be a good module to be run as part of the station, then please let us know. You can join us on the Filecoin Slack in Filecoin-station channel or follow us on Twitter, Filecoin Station. Thank you. And any questions? Yeah, go ahead.
So if I'm a casual user on this one, is the data that passes through or into my computer fully encrypted so that I couldn't be incriminated for hosting state secrets?
That's a great question. Or illegal content. Yes.
Yeah.
That's something we need to sort out, like who is liable?
Yeah.
Is it PL for running the station? Is it you?
I would love to help
the
next Edward Snowden. I just don't want to go to jail for it.
Yeah, so it's a great question, and I don't have the answer yet. But we are definitely aware of this issue. Yeah.
So the first, what we heard here seems like it's oriented against like you can run it on your desktop or your laptop or whatever you have as spare resources. Would this also be considered because it starts to look a little bit like an alternative to Bacalhau? Like computer data, like another way around it, where you're basically using the cached data, which actually works, compared to Filecoin data, which is sealed. So I was just wondering if this could also turn into something that would running on like servers and stuff like that, or is it only meant for really tiny devices?
Okay, so one idea we are considering is to add Bacalhau into Station, so that maybe the content that's being cached by Saturn L2 module can be directly used by Bacalhau to do compute over data, maybe even as part of the CDN, so we can resize images or maybe do video transcoding, something like that. So that's one area, but you were asking about servers, and I think that leads to a headless mode, so we can run Station as a server daemon somewhere, and then maybe have a way how to control it from UI. That's something we are thinking about as well.
Okay, cool.
The question would be, what would be the requirements on the hardware on such server? I would say those requirements would be much lower than we have for L1 nodes. So even if you have maybe a spare Raspberry Pi in your home, then maybe you can run Station on it. But that's farther in the future. We want to start with targeting like consumer users with their laptops, and then the next step would be headless mode. Does it answer your question?
Yeah, it does. It's just a matter of what you're solving here, including billing, having a wallet, getting all that worked out. It's like that is also usable for bigger resources. If you can actually create a network of servers that has cache data available and can actually compute on it because you have Bacalao on top of it or whatever.
Yes, exactly.
It's like if you solve that, it's like it has bigger application, I guess, than just your Raspberry Pi.
Yeah, you are right.
Okay.
I've got a couple shorter questions first. Have you figured out incentive model already for this as well, or is that still being worked on?
It's something we are working on. Initially, we were thinking about using similar model as we would have for L1s. So basically monitoring the traffic, how much data you are serving from L2 to L1, how much value you are providing to the network, and then base rewards on this. But now we are not so sure, so
gotcha. Okay.
It's in the research, yeah.
My
That's
other
why
question, yeah, perfect.
we are not shipping it.
Definitely. Other question was, how much system resource does it decide to use on small localized devices, and can you toggle that as a user?
So there are two parts to this. One is that we want to actually actively limit resource usage. So for example, to make sure we are using at most half of your free disk space, or find a way how to keep network connection saturated only to maybe 30% to make sure you still have a good experience as a user. And then many of the, or specifically Saturn module doesn't need much CPU right now, because it's just download some data from the internet, put it on your disk, and then serve it back. So there isn't even this concern at all.
Cool. I forgot my last question, but I'll figure it out later. Thank you.
It's okay, thank you. Cool, thank you.
Want me to dance? No. I'm tired. I think we should just do it through the adapter.
happen, we believe. Okay, let's do it. You can plug it in if you need to.
Oh, I just don't have an adapter.
What port are you?
USB.
USB Type-C?
Just one of these.
Perfect.
Yeah, that should work.
I think we have.
Oh, there we go.
Very good. Alrighty. We are 15 minutes running over, going into the last talk of the day. Thank you everyone for sticking around. Cool, let's wrap this up. I'm very excited for this next talk. I'd like to bring out Jonathan Schwartz from Glyph to talk about the Lotus blooming season, why 2023 will be the year for anyone building on Lotus. Thank you, Jonathan.
Hello, all's well. Energy in the room right now is low. I knew, yeah, this is why I made a clickbaity title. So, hey everyone, I'm John. I work on Glyph. I've been working in the Filecoin ecosystem for a few years now, very closely with the Lotus team. And today, I'm almost gonna give you like a pitch on why it's a smart decision to take a bet on Lotus and build on it and put it in your tech stack. Are these waters up for grabs? Cool. So I'm just gonna dive right in and try and get through this so we can get to the happy hour. So, two simple questions or challenges to sort of set the context of this talk. The first is, if you have a new idea for a blockchain protocol or a product that basically requires smart contracts, how do you choose what ecosystem to build it in? You know, there's a lot of decision-making vectors to consider there. But one especially important one that is the focus of the talk today is about how, once you've anchored yourself in that first protocol, how can you effectively like ecosystem hop to activate other blockchain ecosystems to grow your base? And this talk, we've heard a lot of amazing talks today. They've all been like really technical, really cool. This is less technical, more theoretical, but at the end, we'll get into a little bit more about architectures. But putting the conclusion first, my pitch is that this concept of foreign runtime plugins in Lotus and the FVM and Filecoin as a whole basically help us answer the first question. It's a good idea, it's a good bet to make to bet on Lotus because it will be much easier to efficiently ecosystem hop due to foreign runtime plugins. Foreign runtime plugins allow us to natively interoperate with other blockchain ecosystems. And that's kind of the pitch. And that's it. No, I'm just kidding. So, what are foreign runtime plugins? I had some notes here, but I'm just winging it. So, a foreign runtime plugin is essentially a custom Filecoin actor that implements its own validation logic. And that's a simplified explanation, but what that means is that a foreign runtime plugin could essentially implement a way to validate like an Ethereum transaction or a Solana transaction, and that opens up the doors for interoperability when interacting with The benefits come at all levels of the stack. Your users, they won't have to, download a new wallet, get a new seed phrase, write it down, put it in the safety, security box at the bank. The developers, they can just keep using the same languages and tooling and all the stuff that they're already familiar with without learning anything new. And that, I think, can help your product grow. And just to sort of reiterate this, I think that foreign runtime plugins, to me, it's a new concept in the blockchain world. And it's really unique. And the benefit of it is that we can effectively ecosystem hop to grow our audience. And at Glyph, Glyph, by the way, is a bunch of interoperable apps that are useful for the Filecoin network. I'm just going to talk a little bit about how we plan to use foreign runtime plugins to achieve this. Like, how do we harness the superpower? And at the end, I'll just talk briefly about what is immediately coming next for us. So in terms of distribution, I like to think of it as 3 stages. There's the inner ecosystem growth, which basically means how can we get Glyph and our tools like our wallet or our Explorer or our multisig into the hands of more people who are already involved in the Filecoin ecosystem? That is an important question, and it's easier to do. The next stage is to go and activate other blockchain ecosystems, essentially ecosystem hopping. And I think this is kind of like an overlooked area of growth for blockchain protocols, because if you skip right to the mainstream, you're dealing with completely uneducated people who are not used to Web3 products. Where if you look to other ecosystems, you have people who are generally educated about crypto and what's going on and how to use stuff, but maybe just not in your unique flavor of your ecosystem, right? So how can we activate the outer ecosystems? Drilling in, like, this is an important question that I don't see that many folks talking about, and for me is really important, and for Glyph is sort of like the next step in our growth before we even talk about mainstream audiences. And it's funny, actually. So I was just on the plane making this slide. Like, why is it so hard? I'm sure in this room we're all somewhat familiar with like the religious faith that some people have towards blockchain ecosystems. It's like cultish. And there's probably many reasons for that. And I'm not like a psychotherapist, so I can't tell you for sure. But like, one of the things that I think keeps people religiously aligned to their ecosystem is that the cost to change is high. So if you look at this like graph here, it's not just developers, it's end users. If you've ever tried to, for example, like coach one of your non-technical or non-crypto friends through using MetaMask, you find yourself like hitting some odd quirk where you're like, oh yeah, just like turn the volume down on your computer and try again. It's like, what? Like, why did that work? But like, we all know these unique things about our ecosystem that the thought of changing is exhausting. Like the thought of learning Rust when I already know Solidity, it's like, why would I ever switch to Solana? And we see proof of that. We see blockchain protocols migrate more easily to ecosystems that allow them to reuse the same tools and the same wallets, rather than migrate to completely different environments and completely different tools, right? And by the way, like, if this is just all heuristics and this could be a little bit off, like it's just to make the point that the more interoperable you are with an ecosystem, the easier it is to attract people to use your stuff and your protocols. So what was the next slide? Right. For Glyph, the logical conclusion for us is don't go on some crusade-like mission to try and convert the religious maximalists of other blockchain ecosystems to come to Filecoin. Let's go meet them where they are, right? So that means that users can use MetaMask, or they can use Phantom Wallet, or they can use whatever they already have, maybe just changing 1 or 2 small details. Developers can reuse their same developer tools without having to learn new languages, new patterns, worry about new security things, for the most part. And that allows us to bootstrap growth from existing healthy and vibrant ecosystems, which I think can help get a critical mass that will be necessary to bring your product into the mainstream, which is that 3rd stage, right? So what's next? Right. The synopsis is, just to check back into the conclusion of the slideshow, foreign runtime plugins allow us to do this. They allow us to build smart contracts on Filecoin, the FVM, but also make that protocol available in different blockchain ecosystems so that the users and the developers don't need to change so much and learn so many new things in order to test drive it and experiment and build on it. So the last part of this is how we try and harness this power. Like, what does it actually look like? This is all very theoretical. Oh, no, wait, sorry. I'm actually just showing that this is already starting to become possible. It's not on mainnet yet, but here's an example of the Glyph wallet. This is me sending Filecoin to an Ethereum address. And this doesn't seem like a big deal, but for a user that doesn't know what an F1 or an F0 or an F2 address is, like this makes people feel more comfortable. I know what that 0x address is because I've been using it in Ethereum world for so long, right? Same with the Explorer. Now on the Explorer, this is a little hard to see, but you could see I've searched for this address, an Ethereum address on our Filecoin Explorer, right? That just makes the experience that people are used to on something like Etherscan come to life in Filecoin, which helps our tools grow more easily in alternative ecosystems. So that's what's happening now. And what is, right, okay, now we're talking about the more tangible architectures. So for Glyph, the way that we think about really harnessing this power is through this concept called ecosystem adapters. And ecosystem adapters are essentially lightweight wrappers around core logic that's implemented as a native Filecoin actor. And so you could imagine it's almost like the Lotus JSON RPC, right? Like the Lotus JSON RPC doesn't actually do anything besides send information to somewhere else in Lotus for the heavy, computationally expensive stuff to get done. Then you can wrap other interfaces around that same logic, like a command line, or even if you wanted a REST API, or I don't know why you would do that, but you know, the point is that you have different interfaces to interact with the same logic, and with foreign runtime plugins and ecosystem adapters, you can implement that logic in smart contracts, which, one, allows users and developers to interact with your protocol doing all the stuff that you're probably like, I've heard it already, but it makes that stuff come to life where users can use their same wallets, developers can use their same coding languages, and they don't have to relearn new concepts. And additionally, ecosystem adapters can actually have built-in bridging logic or cross-chain execution logic so that you really can initiate a transaction on another EVM blockchain like Ethereum and have it finalize on Filecoin, which is extremely powerful. So what does this look like in a little diagram? Yeah, I probably should have done that one slide a little earlier. But this is sort of the very high, simple view of what ecosystem adapters let you do. And one more benefit, what I'm talking about here isn't completely analogous to, say, deploying your core logic on multiple different blockchains, right? Because your core logic still just lives in one place. But if you were to compare the two, imagine if you deployed a smart contract onto, let's say, Ethereum, Polygon, Solana, and 3 other blockchains, and suddenly you find a logic bug, not in any like syntax that you wrote, but just like some reasoning. How do you go and update that? Like that redeployment process it makes me shiver. Like it sounds terrible. The benefit of using ecosystem adapters allows your smart contract layers to also be much more maintainable and upgradable. So if you just have ecosystem adapters pointing to one core logic place, if you find a bug or logic reasoning in your core logic, you just need to update it in one place. And I think that's an important distinguishment to make. And this is just kind of saying the same thing that I've said a bunch of times, but you know, just to reinforce it because everyone here is yawning. So a couple of, and so this talk is set a little bit further in the future, right? The only foreign runtime plugin that will exist in March or April will be the FEVM, which means that we have full Ethereum compatibility with the FVM. And that's a really, really big deal. But I think once we see how successful that is and how much of the Ethereum and EVM ecosystems we can bootstrap, it might be more obvious to make a pitch about doing another foreign runtime plugin. And Lotus and the FVM can scale to I think, I mean, correct me if I'm wrong, but an infinite number of foreign runtime plugins. So then I obviously am going to use this time as just like a little bit of glyph marketing. So first, this morning, we put out our new site, new look. You can scan this QR code. You'll see there's an announcement on there. We are launching with the FEVM foreign runtime plugin, a staking protocol, and completely non-custodial that we're calling Glyph Pools. I can show you a little teaser UI, and this is kind of what it will look like, where you can just stake Filecoin and earn yield, and have different choices as to where you actually invest your Filecoin, different pools of risk. And this is sort of the high-level feature set from what we've done over the research over the last like 6 to 9 months of what's important. So you can read this. I don't have to repeat it to you, but the most important thing is for the miners, you could take out multi-party loans without giving up ownership of your miner. And for investors, or stakers, you can stake your Filecoin without giving up custody of it. So that's, I think, about it from me. And for you all who sat through this entire day and like 2 weeks, I applaud you. So yeah, thank you to everyone here. Yeah. And like, I will take questions if people have them, or if people want to jet, that's cool. Yeah.
Just one quick one. You said you're enabling multi-party loans. Is this like nice. So you just mentioned multi-party loans for SPs. Is this a thing that's going to happen after the FVM? Or are you saying?
It has to happen after the FVM.
Okay.
Yeah. Or the FEVM, but yeah.
Thank you. Thank you for the talk. This is almost definitely a question for the FEM team, but you're the one standing on stage. I find the argument persuasive, right? Like it's exciting, and if you say this is a game changer for users, I believe you. But nothing about everything over there is kind of like core to what we think of the bones of Filecoin. You know, that's not about POREP. It's not even about IPLD or content address data. So my question is basically, why has no one done this? Why has no one taken this approach before? Do you know what is novel here?
Totally. Well, I think I have two thoughts on that. One is that in like the broader crypto space, I think there's this like competitive nature with layer ones, right? So Filecoin isn't going to compete on like transactions per second, or it's not going to compete on the size of transaction fees. So I'd urge you, if you are building a use case on Filecoin, the best business bets that you can make are ones that use the unique features of Filecoin, which are making deals, which are storing data, retrieving data, computing on data, time lock encryption. I mean, that list goes on, and that list is growing. So this is like a generic, if you have an idea. But if I had an hour, I would probably drill down into be like, it probably isn't a good idea to build this thing because it's not unique to Filecoin. Now, you do actually see other blockchains try and emulate this. So if you look at like Cosmos, Cosmos has an app chain that is EVM compatible. I think Solana has like a patched layer that allows you to deploy Solidity to Solana. But these to me are, they're not native to the protocol, and that's the difference. So like in Lotus, we have the delegated address class. Like we have the protocol natively knows about alternative runtimes, or it knows that this is kind of, it needs to be validated elsewhere. In other blockchain ecosystems that I know of, and I don't know of every, like the space has so many possibilities, there probably is a blockchain that is doing something like this. I think that I lost my train of thought, but I think that having it natively in the protocol is different than a patched layer on top. Yes.
Just a quick question on these pools. What would be the lockup requirements? And I missed this part. Is it live already, or is this coming in the near future?
Yeah, so in the Glyph pools, there should be several pools that you can choose from with different rules. So things like lockup period, those are details we're still working out with any given pool. And this will launch alongside the FEVM. So it's not out yet, but whenever the FEVM launches, we will too.
Thank you.
Well, thank you all, and enjoy your drinks and your sleep. Yeah. Yeah.
I'm gonna be quick. Thank you to everyone who stayed for the whole day. Everyone just like in need of a drinks, which will be upstairs. Again, this is our first like Lotus Summit. We have like a pack of contacts. Thanks to all our speakers who showed up and like, giving us amazing talks. And also like if you, and like thanks to Solaris or like event organizers, cannot do this without you all. It's been like 3 months of effort, like throwing all these together. So thank you so much. The swag team, if you like all the cat swag and everything, the swag team, Astrofaders, I believe that's your name. They are not here, but please send a lot of loves to them if you like all their swags. And again, we're the Lotus team. We try to make Filecoin better with a lot of our friends. So if you have any questions, you can find us in Filecoin Slack. Phil Lotus Dev channel. That's that. If you have any questions on like how to collaborate with the Lotus team and like contributing to the Filecoin ecosystem, you can reach out to me on Jenny Juju on Filecoin Slack. Thank you.